Hello. Yeah, hello, sir. Morning, sir. To Dr. Pankaj in the meeting. Mr. Arun from
Hello,
Prometa.
hello, hello.
Meeting.
All, whether the online participants can hear us? Can someone please confirm whether you can hear us? Online participants? Dr. Pankaj, can you hear us? Dr. Erilarasan, can you hear us? Am I audible? Yes, okay. Yeah, okay, thank you.
நம்ம ஆர்சிஎல் சும்மா
Good morning, everyone. Welcome back to day 2 of our workshop. Before we dive into today's sessions, let's take a moment to reflect on the enriching discussions we shared yesterday. Day 1 of our workshop opened with a networking session, followed by an inaugural ceremony graced by esteemed dignitaries and experts. We had the honor of hearing insightful opening remarks and addresses from the esteemed dignitaries. The first technical session by Dr. Ronan and Dr. Eric on the global and regional perspectives on the marine litter issue, while the second talk by Dr. George Grinson on the critical issue of ghost fishing nets threatening India's marine ecosystems. And post-lunch, we had 2 panel discussions which helped us collectively identify research gaps and chart possible ways forward. And it highlighted the importance of strengthening the research policy linkages and discuss the innovative strategies for managing marine pollution across the Indo-Pacific. Adding an artistic touch to the day was the exhibition, The Art of Reuse, Breathing Life into Waste, reminding us that creativity and sustainability can go hand in hand. With that recap, let's gear up for another day of collaboration, learning, and shared vision. To commence the day's proceedings, we have a third technical session which will examine the origins, pathways, and monitoring of marine debris with a special emphasis on emerging technologies. And before starting the presentation, in order to keep the track of the time, we'll be reminding before completion of the presentation 5 minutes before, we will be reminding all the speakers in order to keep the time. And now, without further ado, I will welcome our first speaker, Dr. Eric Chamal, a senior research scientist at AIMS, who will deliver a presentation on quantifying the geographic patterns and temporal dynamics in marine debris pathways, connectivity modeling, perspective on ghost nets and microplastics. Welcome, sir.
Thank you. Essentially, what I plan to do is give you a bit of a vignette. All right. Thank you. Can everybody hear me? It's amazing. If I can pull up my slides. Yep. Before I get started, as Ronan mentioned yesterday, we do have an online form that we would love all participants to quickly log into, just so we can record attendance. There we go. So if you don't mind just taking a moment to scan that QR, that'll give us some really important metrics and help us understand the audience, where to direct conversations in the coming days, and really help us give context to some of our conversations coming up. As you do that, I'll just briefly introduce my talk. So I'm going to highlight the ghost net context of Australia, which is largely focused around the Arafura Timor Sea. There's been a fair bit of work coming out of CSIRO. You're likely familiar with a lot of that research from the Wilcox Group and others, and some great work out of Charles Darwin University. What I'm going to do is highlight a bit of the state of science, the complexities of that seascape, and chart a bit of a way forward where we're using a numerically intensive, spatially explicit framework for quantifying retention of ghost nets in that seascape and potential stranding. I'm hoping everybody's good with the QR code. Fantastic. So I do need to mention that this work is in partnership with Kiki Didmers. She was up at the Charles Darwin University for quite a few years, and she's recently made a move back over to Europe and is now working on complex marine spatial planning challenges in the Netherlands. So this is very much a group effort, and it's some capacity that we're expanding at AIMS in our research group. So I'm going to simply walk through the broad context of the Arafura Sea. Based on some conversations that I had yesterday over lunch and last night over dinner, I've tweaked some of my slides to take a bit of a sidestep to really highlight some of the nuts and bolts of the modeling approach. If you're not across kind of numerical approaches of modeling in general, You can just take a quick timeout as I move through those slides and then check back in when I get back the results. So we had a couple great talks yesterday by Ronan and others highlighting the global importance in the global context of abandoned, lost, or discarded fishing gear at sea. And of course, this became a real big problem since the 60s and 70s when synthetic fishing gear was developed and then was mass produced and was widespread across the global seascape. It's a global problem and it's geopolitically complex. And what's really interesting about this problem is that there are widespread transnational, cross-jurisdictional challenges between sources and destination. And it's really kind of that's the heart of the problem that I'll be addressing in this talk. So the Arafura Sea is on the northern side of Australia, borders with Indonesia and Timor-Leste. It's a large semi-enclosed body of water. It's very important for quite a few marine, mobile, and benthic taxa. This is an important breeding and feeding ground of 6 of the 7 threatened sea turtles. There's strong spatial, temporal, monsoonal dynamics, so it's a very complex environment and it's huge. But what I find perhaps most challenging is that it's socially important and complex. If you map the local groups around this area, it includes over 100 unique national groups of Indigenous Australians who have been living in this seascape for many, many thousands of years. So there's economic importance, there's biodiversity importance, and there's social cultural importance. It's a major fishing ground for trawl and gillnet fisheries, as you might suspect. The vast majority of ghost nets that we see in this seascape, about 75%, are from that trawl fishery. But there's an awful lot of unreported, illegal, and unregulated fishing just by the rich nature and the high demand for food fishes across the seascape. Some fairly recent work out of CSIRO suggests it's one of the highest density of ghost nets, a ghost net hotspot, a global ghost net hotspot on the planet with around 3 tons of ghost nets per kilometer found along these beaches. It's a major, major problem, and unfortunately, the rate of ghost nets washing up on shore is increasing. But it's not all doom and gloom. There's national, global, regional, community-led efforts to clean up beaches and create that circular economy that was mentioned yesterday. I don't have time to dwell on these. You're probably familiar with a fair bit of them, but they span national parks, granting programs. They've funded up to $13 to $15 million since the inception of that program, and national and international databases to track the dynamics. But at the end of the day, we don't know where these ghost nets enter the seascape, and we don't know when they enter the seascape. And that makes for a very, very challenging marine debris problem, and that's what I'm targeting this morning. So like I mentioned before I dig into some of those results, I'm simply going to highlight our general modeling philosophy and numerics that we use for not only tracking marine plastics, but also quantifying marine population connectivity. So a lot of the language in the next 2 slides is really around larval ecology. But in terms of ghost nets and marine debris, we can essentially consider marine debris as passive drifters floating through the seascape, a passive particle, if you will. And I know there's nuances involved with that, and I'm happy to dig into those later, but that's our numerical view of ghost nets in our modeling framework. If you believe that, or some aspects of that, I wonder if that video is going to show. It will not show. That's right. Imagine this is flowing and its amazing dynamics of sea surface temperature across the tropical Pacific. You can imagine that there are very, very strong spatial temporal dynamics, monsoon seasons, El Nino impacts. Amazing. There it is. Thank you. This makes that challenge of understanding where and when ghost nets are in the seascape and where they end up very, very challenging. So what we do is we harness, through partnerships and collaboration, data on ocean physics, working with real physical oceanographers. And what we do is we use a simple advective transport algorithm to move virtual ghost nets through that seascape based on some empirical data that might drive those dynamics. And again, this is for larval ecology, looking at the larval movement of fishes and invertebrates. But if you solve this equation in space and time, you can predict where and when larvae nets move through the seascape. So that's the foundational numerical modeling framework that we use. But what I love about this framework is if you know the location of a source and the location of a destination, you can harness the power of graph theory. So half of our research group uses network analysis, where you can quantify a source or a destination as a node in a network, and the dynamics or the movement from source to sink as an edge or a link. And that's a very, very simple, spatially implicit numerical representation of the seascape. And that opens up a massive amount of algorithms to ask questions about the emergent properties, where are the strongest sources, what is upstream from your most precious beach or protected area. But if you use this network philosophy, you can map pathways, which are shown in arcs, and sources and destination, which are shown in nodes. And you can read the directionality by following the arcs in a clockwise direction. It is a very, very simple, lightweight, powerful representation of dynamics. But you can run all your traditional spatial analysis in this framework, but you can also divorce yourself from space and analyze the emergent network-based properties of that complex system and ask, how does that source destination structure of ghost net sources and ghost net destinations or beaches, how does that emerge just with respect to the background dynamics of the system, ignoring space, because sometimes space can complicate things. So we use network analysis and spatial analysis based on the numerical framework to ask questions about where are the important sources and the important destinations of ghost nets. All right, back to the Aerophora Timor Sea. Like I mentioned in the first couple slides, it's very, very complex. This modeling environment is bound by the Torres Strait to the east, the Western Timor Sea to the west, and we've modeled dynamics up into Indonesia and down through the entire Gulf of Carpentaria. As I mentioned, it's very, very complex monsoonal environment, complex hydrodynamics, and quite a challenging seascape to work in. So what we've really focused on in this work are three, I guess, key innovations, building on the existing work of CSIRO and other groups. One is to increase the spatial resolution. A lot of that earlier work was based on 8 or 10 kilometer resolution or even 1 degree resolution analysis. We're trying to dig into down to about 4 kilometers or less using some of the Osram's products out of Australia, and doing a hindcast analysis back to around 25 years, really to get a handle on those cross-year or decadal patterns, because I think the temporal dynamics of the system is absolutely critical. We're focused on those source destination pathways, those unknown sources and those destinations on beaches, and simply to get a better understanding of stranding to help us inform policy making across the seascape. So we had 3 primary objectives. The first was to quantify the spatial temporal structure of retention zones. Where are these ghost nets accumulating in that complex environment? The second is really to understand stranding zones. Where are they predicted to accumulate on beaches? Are there hotspots? Are those hotspots seasonal? So it's really to give us a better understanding to direct efforts into cleanup or intervention. And finally, we just wanted to understand how long do these nets stay in the system and circulating through that Aerophora Timor Sea. We have some estimates at global scales, but I think when you zoom into the complex hydrodynamics at more local scales, it gives us some great insights into the background dynamics and how long-term these challenges will remain in that seascape. All right, so for the next couple slides, I'm just going to walk through a couple key results. Before that, I should highlight some of the key modeling environments. So we use HICOM and Osram's. Like I mentioned, there's some we don't know where these nets enter the system. So we essentially tessellated the entire seascape and said, well, we're just going to release virtual ghost nets everywhere. We released virtual ghost nets on a weekly basis across each one of these tessellated sources and looked at 132 different beach segments, and then completed, or we are completing a sensitivity analysis to look at what the impact of those decisions are on the results. Okay, so for the retention model, asking how long and where do these nets are retained in this system. We released ghost nets from every element, from every tessellated source. We let them drift for 365 days, so a full year. And we didn't allow them to strand, because we want to see how long they land and survive in that seascape. The results on the next slide are presented like this, where if you can imagine at time 0, it's just a constant value of 100% ghost nets. So if you see warmer spots, that's an accumulation where ghost nets are being gathered up by ocean currents. And if you see cool areas, that's where ghost nets are being kind of pushed away and flushed out of the system. So you can see hot spots of high density. I saturate these plots at twice the original concentration. So that's twice the amount of ghost nets than was originally released. Very stark seasonal patterns. If you're familiar with the physical oceanography in this environment, perhaps not a surprise. We have a lot of eastward flowing and accumulation in the Gulf of Carpinteria for half the year, and more westward flowing in the other half of the year. But we're able to create that spatial temporal structure of those potential ghost nets. The stranding model was very similar to the retention model, but here we allowed ghost nets to stick to the shoreline, so you can identify stranding hotspots perhaps. So in this map, I'm only highlighting those destinations, all those beach segments, as well as some of the open ocean boundaries, so you can see where the virtual ghost nets leave the system. And again, you can see strong seasonal variability, although some of the hotspots stick out no matter what season you're in. So what our next step is to combine these data with empirical data from the last 15 or 20 years, where local communities have been counting and extracting stranded ghost nets from that seascape. For that last objective, just looking at broad scale retention, we found that around 75% of the nets were retained in that central Arafura Timor Sea for up to 100 days. And after a full year, around 25% remain in that seascape. So this is a long-term retentive problem with strong spatial temporal structure. And in the final slide, I just want to highlight a couple take-home messages. And they are that, there we go, fantastic, thank you. The spatial temporal insights from this modeling framework is really kind of a proof of concept. What we're doing now is combining some empirical data and going through some sensitivity analysis, working with locals across that seascape. But I think it's a powerful, numerically efficient framework to explore those spatial and temporal dynamics, and allows us to tie those hot spots of known beaching of ghost nets back to potential sources. And that's really where the power comes on. And some of the empirical data recently reported by the CSIRO group highlights some of those same hotspots that we found in our model, so that's encouraging. So we're looking to build some of that, more of that empirical analysis into the results, and in the end, hopefully to inform surveillance, interception, and cleanup activities. Thank you.
Thank you, Dr. Eric. We can take a couple of questions from the audience. If anybody has any questions, can ask now.
Can you hear me, Eric?
Yes.
Yeah, my curiosity was about the primary data of density. Is there any good method you found how you could find the density of something in the water, not on the beaches, of course?
Yeah, that's a really, really good question. So one of my assumptions is that I had no idea of densities. It turns out that Josh will be presenting this afternoon with some ideas on how to inform that with real data. So there are some data sources, but I'm going to leave that discussion for this afternoon. Good question.
I have a small question. So, thank you so much. It's excellent work is that. And as you have mentioned, the standard zones where the retention time and the potential accumulation zones, as you have been mentioned. So, in which finally.
So, sorry, you can switch on the mic.
Yeah. So you have been mentioned these potential accumulation zones as well as the retention time of that particular whatever that gave. So you have given that particular locations. So in that is the case, what is your viewpoint on that? Whether we can able to use this information for to collection of this, these gears from the amount of debris for the coastal cleanup or whatever in the sea related.
So are you asking around the empirical data to inform the sources and destinations? There's a fair bit of effort in cleanup, in monitoring, and that's something that the CSIRO group and some of the local communities are well across. So a lot of those data exist as well as the temporal dynamics in accumulation. But I think using perhaps satellite-based and AIS ship tracking-based data for those fishing densities is a good start. But I think with the amount of unreported small-scale illegal fishing that happens across that seascape, it's really, really hard to get spatially explicit data on some of those potential sources. But of course, that's just the potential input of ghost nets, and it's not the actual ghost nets in that seascape, and that's a harder problem.
Yeah. So my point is about, so whether based on the study what you have suggested, this many tons of accumulation of plastic or this much amount of 70% retention, 25% retention as you have been mentioned. If that is the case, whether there is a possibility to collect the material, what I'm saying.
Got it. Okay. Yeah. So it's the spatial temporal dynamics and our ability to actually take it out and collect it. I think that could inform some of those activities. I know we're going to be hearing more about that later today. I'm not across that technology, and that's why I'm really excited to hear some of those talks, because it's quite a vast seascape. So I think having some of this information to direct some of that effort would be good. But perhaps after we do more of the sensitivity now, so we know a little bit more how confident we are in some of those dynamics. Yeah.
Thank you, Dr. Timmal, for the comprehensive and insightful presentation. Now, our next presentation is by Dr. Tune Usha, Scientist G and Group Head at NCCR, who will elucidate the application of remote sensing, artificial intelligence, and machine learning from marine litter tracking and management. Ma'am?
A very good morning to all. So before going to the actual topic, I thought I'll give you a brief intro on the kind of work that we do at NCCR so that we can look to see whether we can do further collaborations, because all these three areas that you have selected for the workshop, like climate change, biodiversity and marine litter, are specific themes in which we work here. So I thought we'll just give you a brief overview of what we are doing here, so that there'll be more scope for discussion for different kind of works later on. So the mandate of our institute is basically to develop scientific tools and solutions for integrated management of the ocean and coastal areas. So predominantly we work on these thematic areas, like we work on coastal pollution, coastal hazards, coastal ecosystems. We do lot of solutions for the state government based on their request. We call them G2G, government to government. And of course, we work on capacity building programs. So these are our major verticals in which we work on. Just to tell you the kind of work we do in marine pollution, Dr. Ramo is heading this project. Dr. Marigold is also working. Dr. Sharma is coordinating ecotoxicology work. So a lot of people working on different projects under marine pollution. So what we basically do is we monitor the coast, then we do prediction of how the pollution varies across the coast, and we also do a risk assessment. So the first program that would like to discuss is called the Sea Water Quality Monitoring, which is headed by Dr. Ramo. This is a long-term monitoring program. We started doing it from 1990. We collect coastal water quality data across the Indian coast for different parameters, and since our ministry is committed to SDG 14, we need to give this data to the NITI Aayog to be passed on at various forums. So this seawater quality program is being done for a long time, and a huge data set is available on various water quality parameters. These are the various parameters that are listed. So we have physical, chemical, biological and microbiological parameters that are collected at regular intervals at specific hotspot locations that have been identified along the coast. So this gives you an overview of the coastal water quality across the Indian coast. Then we have the data buoys, which have been stationed at 3 locations along the Indian coast, and this data is used to do a prediction of the water quality. Dr. Mishra was handling the program, now presently handled by Dr. Panda. Then we have something called as marine ecological risk assessment. So wherein we try to identify the safe levels for the water quality. So this work is also being done. Then of course this is the point for discussion, marine litter and microplastics. I'll give you a detailed presentation on the kind of work that we are doing here later on. This program was started by Dr. Mishra, and now presently Dr. Marigold is handling this program. So basically under marine pollution, we collect all these data, and it is given to an agency called as NITI Aayog for SDG 14 index, and we do a lot of capacity building programs also. The second theme that we work on is coastal hazards. We do a lot of work on coastal flooding. So this is actually a picture that we normally use to see what would be the impact of sea level rise maybe in future. So this is the very famous gateway of India. So there is normally a high tide alert that is given to this area. So suppose you have a sea level rise, this could be the anticipated situation. So we do work on how much of area we would lose due to various coastal hazards and things like that. So that is one area in which we are working. So we have developed something called as the flood warning systems for 3 coastal cities, wherein we'll be able to give over 24 hours in advance the kind of area that would be inundated due to various floods and storm surge. So this hazards is one area that we work. Since we are also talking about biodiversity, now there is a concept called as coastal bioshields. That is the coast that would be protected not only by the hard structures, but also by the bioshields like mangroves and corals and seagrass. So extensive mapping of these bioshields have been done along the coast, and we also have developed something called as coastal inundation risk atlas, wherein the coast that is protected due to the bioshields, and without the bioshields, how much would be the area of extent that would be affected. So that kind of work is also being done. Extensive work is done on coastal erosion. That is the area that we would lose due to erosion. The entire Indian coast has been mapped and lot of data is available. And once this data is available, how to protect the coast, that kind of work is also being done. So the shoreline atlas, we release it every 2 years, and the entire coast has been mapped, including the islands. So the hotspots of erosions have been mapped for the entire coast. So as you all know, these are the different causes for erosion. All of these have been studied, and these inputs have been taken to identify the hotspots. So since just rushed through, this is one work that was done for Pondicherry. So this was done by ministry along with NIOT. Dr. Ramnamurthy was handling this program when he was there. So this is the kind of intervention. So the first picture, the before shows there was no beach at all in this. Pondicherry is a, I don't know whether you have heard about it. It's just next to, I mean, it's a very beautiful tourist location, very close to Chennai. So the first picture shows there's absolutely no beach. There's a sea wall there, and then an intervention was put into the sea, wherein the beach was reclaimed. So these kind of works are also being done. So this we call as beach restoration activity for Puducherry. Similarly, lot of coastal restoration work happens along the Indian coast, and NCCR plays a role in all that. So this is the reclamation work that was done for the state of Kerala. You can see completely, there's a place called Chellanam which is inundated every monsoon, and we proposed some intervention that was executed by the state, and then how the lower picture you can see after that how the coast has been protected. So we do lot of coastal protection projects to help the state government. We do not do the actual execution, but we give them solutions that can be used by the state government for execution. And then the third theme that we work on is on ecosystems. So we have a center, I mean, we have a field center in Ramanathapuram wherein lot of work is being studied in coral restoration. Dr. Shanmugraj is handling this work. So a lot of coral restoration and monitoring also happens along the Gulf of Mannar and the islands. So that work, so this is another work that we do, ecosystem modeling. Now we are working on ocean accounting, ecosystem accounting, and things like that. So these niche areas of ecosystem are also being studied. And then we developed something called as coastal biogeographic information system for the entire Indian coast, so that we get all the biodiversity data at one portal. So that work is also being done, and of course capacity building and training, and we have a lot of collaboration like how we have with you. So I just go to the, and Eric was mentioning that you work on marine spatial planning. So this is a collaboration that we have with Norway, wherein we have developed MSPs for 2 pilot areas in India. So that has gone in for implementation. So that is one of the most successful international collaborations that we have. This work was done along with Norway, wherein we developed a dashboard called Sahav. Sagar for the Hindi word for oceans, and Have is the Norwegian word for oceans. With that we developed this MSP portal, which is now used for implementation of MSP in those 2 pilot areas. Now coming back to the subject of discussions. So we have all the work that we have done in NCCR with respect to the use of remote sensing, AI and ML, have then put them together in sort of a portal called GeoAIM, Geospatial Artificial Intelligence for Marine Litter. The biology part of all this has been handled by Dr. Marigowda. So this I will only present the geospatial and the use of AI ML for quantifying marine litter. So I'm sure you all know this. This is the, what is this? All the students, any idea what this is? Dr. Eric, have you seen this batch?
But it's not really visible.
Exactly. So that is my point. So this is the picture. So I try to see whether this is visible in the satellite data. So it is not visible at all. So you can't pick up this thing. So when we do a lot of work, my doubt was whether we'll be able to study this kind of litter from the satellite data was a subject for question. So I tried to pick up, and as of date, even such a huge patch is not visible from the satellite data. So the kind of litter that we are talking about in NCCR is primarily the litter that is collected along the rivers, the coastal areas and the shore and beaches. So we do work on these kind of litter that are collected along our shores, and this is a very big problem for us. So the idea of all this work is to address this kind of litter, called as the marine macro litter. So we have done a lot of data collection along the beaches, the coastal waters and the rivers, and the primary data sources are, as you all know, is remote sensing data, drone data and the field data that we collect using apps. So some of the objectives, actually we had a project with Jamsticks, and some of the objectives were to map the distribution and abundance of marine macro litter in the coastal regions, utilization of remote sensing satellites to understand the spatial and the temporal resolution of macro litter, develop the spectral library for marine macro litter using the radiometer, and then develop different indices. This are all, we are all trying in all this. All this work is not still complete, it is in various stages, and developing a marine litter detection algorithm using AI/ML, and develop a centralized repository in a GIS platform wherein all these data sets that we collect can be put together. So these are the major objectives. So as we all know, the major data sources that we right now use are satellite data, drones, and we collect lot of data from the all the various campaigns that are done by the Government of India using the citizen science approach. And the technology that we will be discussing are remote sensing, AI and ML. So the first objective, to map the distribution and abundance of marine macro litter along the coastal regions. What we have done for this till date. Okay, this this is a campaign that was launched by the Government of India in 2022, wherein 75 beaches were to be cleaned at the same time. It was totally coordinated by Dr. Mishra. So this was a huge exercise, 75 beaches, 2000 volunteers per beach, and lot of government agencies came together to do this work. Then we had an organization called Indian Oil Corporation Limited, who collected the plastics from 16 beaches, and they tried to use it to see whether they can do it, some fuel purposes kind of thing was also attempted. So these are the 75 beaches that were cleaned at the same time. The specific hours were given in the morning and how you have to do the cleaning process. The entire thing was coordinated at the same time, and so many people were involved in this work, primarily coordinated. All the data collection was all coordinated by NCCR. We have one project scientist, Sujit, who developed the dashboard and the app to collect the data from these 75. It was a huge exercise. So it was not just done cleaning and then saying how much of kg. We also wanted to collect all the data, bring it to the database so that you can use it for various ML purposes. So this is the app, we call it the SS Sagar. So the major features of this app was developed in-house, and then it was disseminated to all the volunteers working on all the beaches. So the salient features was it would work both with Android and iOS. It was developed and uploaded in Play Store. So the background picture is of our Prime Minister plogging. So as he was walking, he was picking up trash. So that picture was put in the background. So the users were presented with a map view of all the litter points that they were collected, and the user need to select his participating beach. And then he can upload the photo and say what is the kind of litter. Why this was done is to validate, this data was used to validate the output from the AI/ML, whether whatever the prediction we made and whatever data we got from the field were okay. So this is the app. So this is the home screen with navigating icons, where flags to indicate the beach in which person is collecting data. And then once he collects the data, he can see what he has collected and give. Then there's the feedback form and all that was all that. It was a complete package, and this was distributed to everybody who was involved in this exercise. So this is how it happened across all the coastal states, the islands, the union territories. It happened at the same time. So people started collecting data, and the app was used. And these were all some of the concepts that were inbuilt into the app. So I'm sure you all know about geofencing. We can't take a picture from a beach in Chennai and say it is Australia. Immediately check and see whether you are in that particular location. So geofencing concept was introduced. So if you try to give the wrong beach name, it will definitely warn you, you are far away from the selected beach, do you still want to upload your photographs? So geofencing concept was used in this app. Similarly, irrelevant images were filtered out. So that cannot be, I mean, selfies, since it was given to a lot of students, normally there'd be a tendency to upload your selfies. So all the selfies were removed. So we used image filtering techniques. And then data was collected. It came to our server here. And this is the kind of output that was developed. By the end of the day, we knew how much of trash was collected from each of the beach, and it was quite a huge amount from each of the beaches, and the kind of litter that was collected. So for example, in Gujarat alone, on that particular day of cleaning, this is the kind of data that we collected, and the various kinds of litter. So all this was developed and collected, and data was stored in the database. So this was the exercise. So huge amount of field data, field photographs came from this one exercise. So at the end of the day, we knew at each beach what is the kind of trash, which is the cleanest beach, which is the dirtiest beach, and all that data was available in this one exercise. Now this coastal cleanup activity, but not at this scale, is being organized every year. Ministry of Earth Sciences plays a very important role in this. So we do this exercise every year. So when we get more data, we refine the database so that we can sort of give more training to the AI ML app. Then the second objective is using remote sensing satellites to understand the spatial and the temporal distribution of marine macro litter. So as we all know, the most important thing would be to collect the spectral signatures, and India has got a plethora of remote sensing satellites. We have from 1 meter resolution to 360 meters. So we have a huge database here. And now the government has opened the data. It is available for free and even the fine high quality, high resolution data is also available for, you can download it and use it. So the first thing that we attempted was, Dr. Das is coordinating this program. So the first thing that we attempted was to create the spectral library for all this marine litter. So we had our all our project scientists working in this project. So we developed a development of spectral reflecting library for various marine litter. So the initial level of work is carried out using the VNIR region of the electromagnetic spectrum. So spectral reflectance of around 173 litter items were recorded, and Dr. Maya, Dr. Saji, Nimlan, Dhanapalan, Gayatri, a lot of people worked in this project. So 173 litter items were picked up, and for each of that, this spectral curve was studied, calculated, and the database was created. We all know that the litter per se will not be exactly like this. There will always be a combination of all this put together. So various trials and error were developed done to get the spectral curve. So all this data, we now have a library of all about 170 odd objects which can be as marine litter, has already been documented. Then we thought, how do we use the satellite data? So of course all of us know about the floating debris index. So we tried with that to see, we took images wherein we knew there were debris because right after the floods, so all that was used to create the FDI. Then we did a controlled experiment. This was in a lake here, it's called Kolavai Lake, wherein you have plastic raft. So this exercise we carried out sort of to see whether this kind of signature is picked up in the satellite image. These are quite a huge rafts. So we used this and we could locate it in the sentinel image we ran the various plastic index, FDI and all that to see whether this signature was picked up, and it was possible. Then we use the remote sensing data to see whether the same kind of objects. Of course, we all know the plus and minus of remote sensing data, but we are attempting to get a modified FDI. Dhanapalan, I think, is working on that, and we will come out with something in the near future. So this is called as modified FDI, wherein we are trying different combinations because we have a huge data, remote sensing data available in India. And we'll try all this to see whether we can get some good index to study the marine macro litter. Then the second data set that we use is the drone data. We have employed drones to collect lot of images, and that also is being used for this particular study. So remote sensing and drone data for this marine macro litter, we have an extensive database, and we are working on that. Then developing a marine litter detection algorithm using AI ML. This per se was already done in the app that I showed you, but now I'll just tell you a detailed way in which it was done. So first we do the model development, wherein the database is generated. Then you integrate it with the app, the SS Sagar app. Then the user uploads the picture based on what is uploaded, and it checks with the database, and the litter is detected. And then we do a data analysis, and the insight is provided to the authorities. This is the process that we have used to develop the SS Sagar app. So the process normally that is followed, we all know. First is the data set creation. Initially, before starting this app development, about 5,000 images were collected from various sources, and using bounding box approach, it was categorized into the various litter categories like paper, plastic, wood, cloth, etc. So this was the primary database. Then all these images that we collected, we used the blurring, rotation, the flipping options to augment the data sets. So that of course is a second this thing. And these are the various classes. We have bio waste, glass, metal, paper, wrappers, styrofoams and others. So these kind of database was created, and then annotation was done using the RoboFlow tool. So all those 5,000 objects were annotated like this, and so the huge database was used to train our tool. And when we started, now we have like the model has gone through 3 phases now of development. So first when we started, it was YOLO V5, now it is V8. So one set of data was used to train, then we used the grid division, then we went for prediction, and then the final validation was done. So the second, as we got in more data, we enhanced the database to 10,000 plus images. All the data that was collected during the cleanup operations were used to enhance the basic database so that you can have better prediction. So this was the second level of evolution, which we call as semantic segmentation using YOLO 8. So then the process of course is the same, only you have a better database and better prediction. Right now we are so this is how the database was augmented. The upgraded version of RoboFlow was utilized for semantic segmentation. Just for cardboard box alone, so many training sets were given. And so this is the latest version. So this entire thing was done by Sujit. So he gave me this slide, so I have no idea what a hugging face paste means. So he gave me this slide, so I have just put it here. So right now this is where we stand. So we have now using YOLO V8, and this is like prompt based segmentation with SAM. So as of 2024, this is the third level of AI ML technique that we are using, and this if you want more discussion, you can have with him, so that he will be able to tell you what exactly all this means. Okay. Now once we feed the image, this is the kind of I'm interested more in the output. So once he brings it to me, I will check with the image and say whether this is okay with me or not. So this is the kind of accuracy that we have. The system is able to identify at various levels of accuracy, right from metal, bio waste, paper and things like that. Sorry. Okay. So now the way forward is, so we have gone through 3 iterations. We started with object detection to semantic segmentation, and now towards this prompt based vision systems. Each step the accuracy has increased, the usability and scalability are much better. So we are now using deep learning, image classification and things like that, and as the system improves, more and more data sets will be fed so that we get better prediction. Then finally we come to the repository, wherein we have a WebGIS based dashboard, wherein all the data that has been collected from satellite data, drone and all that, we have started populating it, and it will be a database which can be used by anybody to kind of use the spectral signature. So this is also a work in progress. So as the remote sensing advances, we have better AI ML algorithms. I'm sure we'll be able to do a better detection of the marine macro litter. As far as the litter in the beach, in the waters, I still have my own doubts. Now papers are coming with using sentinel data and the roughness they study to predict the micro litter, but we haven't tried anything like that. So all our studies is for the macro litter space. So the integration of remote sensing, AI and ML presents a transformative approach for tracking and managing marine litter. So this is all that we have done. Thank you.
Thank you, ma'am. Any questions from the audience? Yeah, yes, please.
Hello, ma'am. Yeah, I think I can work this too. I was wondering if you use these satellites also on the ghost nets and try to identify those.
We
From
have
some
not.
of the resolution, it looks like you could be using.
It might be possible. Actually, we do not have. We haven't tried. We did some data collection on ghost nets and corals and things like that, but we still haven't tried, and we still haven't identified areas where there is like how you have shown, right? So when I saw that, maybe we will also try. So, but we still haven't. Maybe we can have a discussion on that and to see whether we can use it.
And just as a note as well, I think the other option would be radar satellites to use on the floating later instead of the multispectral.
Yes,
ones.
yes.
It's very impressive. Thank you.
Currently, the best resolution of the satellite is still a meter plus, whereas our macro plastic would be roughly 25-30 centimeters each. That's one challenge.
Exactly.
And the NISAR satellite, do you think there is more hope there this year?
We can, I mean, all this is, that's what I was saying. We are just trying with various things. That controlled experiment in Kolawai Lake gave us an indication that if the plastic, like all of us know, if it's of one particular dimension, you can definitely pick it up. And from till date, we still have, even like you have seen this Adyar and Kuvamouth, wherein this huge, the plastic gets washed across the rivers. But then when we try to do a classification or something, there's a lot of mixing with the other pixels also. So that is a problem. So that's why we try to redefine the index to see whether we can get that particular feature that we want. So it's a work in progress. I'm sure we'll be able to do something.
We have a MOU with ISRO to profile plastics in the coast using AI. So I'll speak about it in that.
Sure. Actually, Dr. Chavan called us, and all the data sets is now open, right? So I think we can discuss more, and it's just a trial and error method to come out with it. We have a lot of spectral signatures, so that can also be used. So let's see how we can take it forward. We all have an idea of how to do it, but still I can't say that any one of us have figured out exactly you use this and you will get this.
Yeah. Thank you, ma'am. Any more questions? Online question. Ma'am, you will take a question from online. May I know the purpose of taking VNIR readings from the litters?
So we assume that is the particular wavelength in which you will get the maximum, you will be able to detect the litter at its best. So I think and the spectrometer that we used was what? So Das, you can answer.
Actually, mostly we work on the near Actually, mostly the plastic debris can be detected in the near infrared range. So it is almost 600 to 710 nanometers like that. But when the litter is different type of combinations, so we need to see that what type of other spectrums, data sets, even lower wavelength is also is actually influencing or not. So that study actually we are continuing right now. Hope I can answer your question.
adding in this, we are not focusing on the floating debris, and we are focusing on the debris on the land. So for that, visible and NIR band is enough. So once we are trying for a floating litter, like litter on the water, then we can go with the sphere band.
Ashwini, is that okay for you? Yes. Okay, thank you. There is one more question. Chat box. How are the spectral indices from different items identified? Laboratory test as satellite data analysis.
We actually have taken, we have gone to the field and physically we have done some places, and some places we have taken the photographs and we have analyzed that. Yeah. Hello.
What is her name?
We have taken actually mostly to the field, and we have taken the spectral radiometer, and we have taken the spectral profiles directly to the target. Plus, as well as we have also considered some photographs where we have also analyzed the spectral characteristics.
Spectral indices. Actually, we don't have specific
The
indices.
question is how the spectral indices for different items identified, laboratory test or satellite data analysis.
Like indices, we already have some fixed indices like FDI, then this plastic index, the coastal litter index. So that kind of work is basically done using the remote sensing data alone. But the spectral curves are developed from the field using the radiometer.
Thank you, ma'am. Jay Bhavani, I hope you got the answer. Thank you, ma'am, for demonstrating how AML technology is playing a key role in marine debris monitoring. Now, I kindly request Dr. Eric Trimmel to honor Dr. Tune Usha with a memento expressing our gratitude for her invaluable contribution to the workshop.
It should be the other way around. I am the host.
No, ma'am. Thank you, ma'am. Thank you, sir. Our next presentation for the session will be presented by Dr. Marina F.M. Santana from AIMS, focusing on making beach cleanup data count key factors for science and management. Over to you, ma'am.
Thank you. Thank you. Well, good morning, everyone. Thank you for being here. I would like to start the presentation as Eric did, just by reminding everyone to scan the QR code. And fill up the form for us. It will be awesome to capture everyone's attendance and expertise and areas of interest. So give you all a couple of extra seconds. And online. Oh yeah, for those online as well. Yes, absolutely. I'll go back to that. For everyone that is online as well, if you could just scan this QR code and complete the form, it would be fantastic. I can see some phones scanning it, so when these are done, I'll start the presentation. Awesome. All right. Let's move forward. Okay, so today I'll be taking off my microplastic hat, and I'm here today to discuss methodological considerations on how we can use beach cleanup data to support science and inform management. Using an ongoing work I've been involved through this hub as an example. And I'm going to start perhaps in a provocative way by acknowledging that plastic have actually revolutionized our life completely and in a positive way. It allowed the invention of many life-saving devices and the implementation of new technologies that changed the course of history. It has also, which in my opinion is extremely important, democratized the access to goods and technologies to undeveloped countries and vulnerable communities. And for that, I actually thank plastic for existing. The issue is that we've been overusing it. We are producing and consuming so much plastic that it became an environmental pollutant, exacerbating the impacts of all planetary boundaries. There's a recent paper that just came out December last year talking about that. And that includes climate change, ocean acidification, and biodiversity loss, as we've been discussing since yesterday, which calls for urgent action. So how do we action? Well, identifying the problems and its risks is paramount, and we've been doing great on that. But now governmental and intergovernmental bodies are discussing on how to address it. And that goes from policy and regulation to identify, understand, and monitor key hotspots, develop strategic cleanup and restoration initiatives, and build feedback loops for better policy. And all these topics support each other, and they are all correlated, hence the cycle symbol that I've used in this slide. But as environmental researchers, I think that identify, understand, and monitor key hotspots is where we can act the most. And when it comes to executing this type of work, beach environments are great to use, and so is beach cleanup initiatives and the data associated with it. So marine debris often gets deposited on coastlines, and as we all know, beaches are easy to access, so they are cost-effective environments to use in this type of exercise, and they reflect upstream and downstream processes by capturing both land and marine-based sources. And although there are many ways of assessing beaches regarding marine debris, like scientific surveys, remote sensing, as we've been listening to, numerical simulations, citizen science beach cleanups are a great tool to explore given its cost and data accessibility, high temporal and spatial coverage, and public engagement and policy impact. So saying that, one of the projects we have through this IPOI hub aims to use beach cleanup data to support environmental management and policy by, at this stage, identifying spatial and temporal patterns of anthropogenic marine debris, abundance and hotspots along the coastline of Western Australia, and investigating environmental factors influencing the observed anthropogenic marine debris distribution. And at a first sight, this seems pretty straightforward, right? But as anything plastic pollution related, as most of you know, it's not, and that's mainly because of the lack of standardized and minimum methodological requirements available in the literature. So as a result, we step back from jumping into publicly available data sets and generating some results to first identify methodological considerations we should be aware of when developing this type of studies, which some of them I'll be sharing here today. So overall, there are several key considerations when it comes to methods that we need to take into account to accurately and robustly identify, understand, and monitor marine debris on beach environments using cleanup data. And this would include the spatial and the temporal resolution of the data that you are working with, standardized methodology of data collection and data reporting, a robust data validation and quality control approach, integration with relevant environmental drivers, and inclusion of relevant source attributions. And if you think about this type of investigation as an equation, where the amount of marine debris is a function of the environmental drivers and the source attributions, these key considerations could be applied to either parts of the equation separately or generally considered for the equation as a whole. And in this presentation, I'll be breaking up these considerations by each one of these parts of the equation. So the load of the marine debris, the environmental drivers, and the source attributions. In terms of load of marine debris, that's what the beach cleanup data will give you, as we have just heard in the previous presentation. There are many national and international organizations that actually conduct beach cleanup and make their data publicly available, so we have a huge load of data to work on. And this would be mainly NGOs or government initiatives, but talking about NGOs, I'll give some examples like the Ocean Conservancy, which acts worldwide, Kangaroo Blue, which is a very famous organization in Australia, and Reef Watch, which is also an international organization that actually has a lot of initiatives here in India. And the data provided by these organizations is usually an Excel file that you can download, where every row would represent a beach cleanup with respective information regarding the date of when this cleanup happened, how many people were involved, the extension of the beach that was cleaned, all sort of background information that they think it's valuable, but most importantly, the amount of marine debris collected, which is usually reported based on weight or number of items. They also provide a lot of background information regarding the methodology they use, which is really good to go through and make sure that you're using or choosing to work with initiatives that follow a minimally structured methodology and that the data is reported in a consistent way. If you choose to work with multiple or with data sets that come from multiple organizations, which is also welcome, it's just important that you consider using methodologies or initiatives that follow similar methodologies in data collection and reporting. Another very important factor is the temporal variability. One cleanup event per beach is just a snapshot, and you might end up either under or overestimating the loads of marine debris. Let's say that you actually use a data that is followed or it comes right after an extreme weather event. You'll be clearly overestimating the amount of marine debris on that beach. And unfortunately, there is no standardized approach when it comes to number of beach clean that you need to use to make this type of study. So running a power analysis could be a good strategy to determine how many, a minimum of beach cleanup events that you need. And in our study, for example, all beaches that we are using had a minimum of 4 years worth of cleanup events, with some beaches having monthly data, for example. It's also, or I would also like to call attention to the need to standardize the data. So I'm pretty sure lots of you have participated on beach cleanup initiatives or a single event at least. And you can understand that most of the time this is conducted by volunteers and the number of participants can vary, as well as the extension of the beach that is covered by that event and the time that it took for the participants to clean that specific stretch of the beach. So, and all of that is expected logically to influence how much debris you are collecting and reporting on those data sets. So before running any analysis, it's paramount to have all of these factors built into the load of debris that you're using as the start of your function.
Ma'am, you have 5 more minutes.
Luckily, I'm almost at the end. Moving forward and talking about analyzing the environmental drivers influencing the accumulation of debris on the beach. As you probably know, there are many factors that could be influencing the amount of debris that you find on the beaches, from currents to wave, wind, beach morphology, presence of vegetation in the backshore, and others. And these factors will clearly change from beach to beach, so it's important to be considered. early review and exploratory analysis can be quite important at this stage, so you can choose predictors that are relevant for the region that you're analyzing. For example, for the coastline of WA, we have chosen to work with tide and wave height and direction, wind conditions, beach slope, and backshore features. And that could actually be different here for India, for instance. Rainfall, because of the monsoons, could be actually quite crucial. The temporal variability is also crucial to be considered because the conditions for most of the environmental predictors will change over time. And so when you're extracting this type of data for your analysis, when possible, it's good to use average or mean and maximum conditions between cleanups and not actually as a number that will be replicated over time in your data set. And lastly, in terms of data resolution, this is also something that is key to be considered. Ideally, you should incorporate predictors with data resolution that is compatible with the spatial distribution of your beaches. So in case you have similar values for different beaches or over different time periods, this is not a resolution issue, but it's actually demonstrating how accurate your data is. Now, finally, but not the least consideration is the inclusion of source attributions, especially when working with beach cleanup data. So ideally, when you're trying to assess hotspots of accumulation and environmental factors that influence that, you should focus on surveying sites with no local source of debris. But of course, when it comes to beach cleanup, we are constantly looking for beaches that have easy access and they're actually used by people, so you can create that public awareness. And the problem is that these beaches might not be naturally prone to accumulate debris, and the influence of environmental factors might be masked by their local use. So you need to consider these local uses in your analysis. So in our study, for instance, we're going to be using the Human Modification Index as one of the source attributions, which is an index that measures the cumulative impact of human activities, such as urbanization, agriculture, infrastructure, and energy use. But because this is a global-wide index, we also need to include important local attributions. In our case, that could be boat ramps, tourism. In other places, could be presence of landfills. And as much as for the environmental predictors, resolution of the data that you're using is something that needs to be considered. So to summarize our learning from this ongoing project, I would like to reiterate that fundamental methodological considerations should be made prior running any numerical simulation and statistical analysis with beach cleanup data, with some of them highlighted in this presentation. From our perspective, this turned out to be a stepping stone project towards a standardized approach and minimal requirements for this type of analysis, which we would like to extend to other coastlines of the Indo-Pacific through this hub, if anyone is interested. So in terms of expected outcomes, we believe that robust analysis such as the one that we are proposing here should support environmental management and robust policy frameworks and should be expanded to other coastlines of the planet. So saying that, please come have a chat with me if you're interested on collaborating and using part of your coastline in this study, or if you're interested in knowing more about what you need to do to actually use beach cleanup for this type of initiative. Thank you.
Thank you. Since we are past 15 minutes of our session, let's take a quick one question from the audience.
I have published a guideline or protocol. So you want to make a Indo-Pacific study, suppose, to different, if you, the same pattern, if you collect the data, suppose, beach data, so that that can be also useful.
Yeah,
have you published this?
No. So this is an ongoing project, and we are here to extend the invitation to collaborate with whoever is interested on using their local beach cleanup data to expand that.
So I think on the regular basis, also a number of institutions, they are also involved in cleanup in beaches. So you make a guideline or a platform like thing, that we
Yes.
can integrate maybe
Yeah.
so that we can have more data.
Absolutely.
And that will be more useful and I think that will be better way.
Yeah, no, absolutely agree. Yeah, I think it's paramount. I mean, the data is usually publicly available when it comes to beach cleanup, right? We've just heard about some initiatives here in India. But I think what's really missing is that lack of minimum requirements for you to work with this data and generate minimum valuable information for policy. So coming up with a platform that give these guidelines would be a great idea moving forward.
So in the same thing, we can also, I think, collect data on beaches, different type, as you said, the beach parameters like wave, current, and all this. And I think Australian ADSOT group is very strong in that. So they can they have done a lot of modeling work that can be also integrated, so that parameters beyond that also can be collected.
Yeah.
And we can have a real picture for the different beaches and how that is getting accumulated.
Absolutely.
So we can develop some sort of guideline and integrate it with the GIS, so that at one place we can have data. Okay.
Yeah, that would
way.
be fantastic. Great idea. Thank you.
Thank you.
Thank you, Dr. Marina, for your valuable insights on the presentation. We shall now break for tea, and I kindly request everyone to reassemble at 11:30 a.m. for the next session. Tea will be served at Manthan Hall. And the new participants can register their names during the tea break. Thank you. request the online participants to please wait for some 5 more minutes. I think we'll
I'm not sure if you're waiting for me. I'm ready whenever you are.
So, Miles, this is Josh. Would you mind just practicing sharing your screen with us? Beautiful. We'll just see if we can get it on the workshop screen.
Yeah.
Now we'll start talking. Welcome back everyone. The fourth session addresses the intersection of marine biodiversity and climate change within the Indo-Pacific, featuring eminent experts from India and abroad. The first presentation for this session is given by Dr. Miles Parson from Australian Institute of Marine Science, joining us online, presenting on an Indo-Pacific library of underwater biological sounds, monitoring changes in biodiversity through machine learning analysis of ocean sound. Now I invite Dr. Parson to present.
Thank you. Can I confirm that you can see the screen and you can hear me?
Yes, we can hear you.
Thank you very much. I would like to acknowledge Australia's First Nations people as the traditional owners of the land and sea country where AIMS conducts our work. We recognise these people's ongoing spiritual and physical connection to country and pay our respects to Aboriginal elders past, present and emerging. And I would like to say thank you very much for having me here to speak today. I realise sound is a little bit different from what you've been talking about, so just to give a brief introduction, back in the 1950s, Jacques Cousteau laid out the film The Silent World, and everyone then thought that the ocean was a very quiet place, and this was of course very incorrect. The marine world is very, very noisy, and this is because underwater light doesn't travel very far, whereas sound does. You have a lot of marine life that are also in deep, dark and dirty waters. And there's a lot of animals that have nocturnal or exhibit nocturnal behaviour. Consequently, sound is the primary sensory modality for almost all marine species. So who produces sound? Well, literally almost everyone. We did a study a couple of years ago to characterise which species produce sound. Almost all aquatic mammals, 2/3 of all fish, and that's about 20,000 different species, and an unknown number of invertebrates produce sound underwater. And they do this to be able to successfully complete life functions. Most commonly, that's reproduction and feeding. And some of them, like fish, gather together in large groups and produce mass phenomena called fish choruses, when hundreds to thousands of them can make noise together. Now, what that means is that because you've got environmental drivers that drive that behavior and the response associated with that life function, you actually get spatial patterns and temporal patterns in the sound production as well. And we can monitor that. And intuitively, that means that where you've got healthy habitats and high biodiversity, those soundscapes that they produce, the collection of all of those sounds, are rich and complex. And within that as well, you also have some of the impacts of anthropogenic noise or other disturbances that we might do that affect and can change that soundscape, and we can monitor that. To appreciate, or in appreciation of this, the Global Ocean Observing System, GOOS, has named ocean sound as an essential ocean variable a couple of years ago. It's a cross-disciplinary ocean variable because it covers biology, ecology, and physics. And what they've recognized is that we can actually sample some of the acoustic diversity as a proxy for the biodiversity, particularly when you're using complementary sampling assessments. And just to give you an idea how much this has literally exploded in use over the last 20 or so years, the International Quiet Ocean Experiment, we've been cataloguing deployments of hydrophones and asking people to send in their data. And what I put there is a map of all of the locations that we've got. And as of 2023, this is the number of deployments that we had. We've actually got double that amount across all of those years now. So you're looking at roughly 1,000 deployments of hydrophones that go on around the world each year. And what you can also see there is the dip that we had during COVID when there weren't quite as many people putting out hydrophones to record sound. So what can we learn? Well, from bioacoustics, or just looking at species signals, we can get an idea of abundance, behavior, and we can get an idea of species diversity. One of the studies I did back in 2016, we were looking at fish choruses again, and we picked up 10 different fish choruses at the same site and looked at how their patterns changed with time of sunset, salinity, temperature, environmental drivers. So you can map that, and you can map the diversity of some of the fishes there. And you can look at distribution on a wider scale and migration routes if you have multiple sampling sites. We also have something called ecoacoustics, whereby we have metrics that summarize all of the soundscape and use that as a proxy for health and biodiversity. Ben Williams looked at this in Australia, where he compared high fish diversity areas and the soundscapes at low fish diversity areas and used machine learning to discriminate between the two. And his sites in French Polynesia, he actually found had individual acoustic fingerprints, which he could relate to some of the habitats. Here on the east and west coast of Australia, one of our studies that Juan Azafispa-Solano has been doing is to look at some of the habitat drivers and what is present. And we found a difference between areas driven by Pocillopora and non-Pocillopora corals and how the soundscape looks between those. And again, looking at some of the anthropogenic impacts, you can build up noise budgets, exposure levels, and start to understand threshold criteria for noise disturbance. So this is a study where we've got the summary of all of the sounds over a 6-month period and compared that to what I'm highlighting here, which is the audiogram of a fish. And you can start to look at what sounds that fish actually is detecting and what might disturb it from its natural behavior, and how that contributes to the soundscape and whether or not you can detect that in the acoustic metrics that we use to assess biodiversity. Now, when you're applying that, we can use these soundscapes as baseline reference data sets, build them up through time, and detect and manage change. So you can detect long-term changes like climate change if you have decadal records, or you can look at short-term disturbance events. And I think Mario will talk about cyclones. I've got a very interesting study where we look at the soundscape changing the fish choruses and sounds before and after a cyclone. You can get biodiversity assessments and start to look at the health of marine parks and species communities to classify habitats. And you can use it for stock assessments. And the easiest example there is spawning aggregations going through time, behavior, and biomass, and what's driving those. We can detect vessels, so you can look at areas for compliance, uses of an area, defense if you want to detect intrusions of specific areas. And one of the interesting things is to compare some of those, like looking at biodiversity and how it changes with things like vessels or, say, marine litter. And these traditionally have been done with archival data, but more and more it's being done with live data, it's being automated, and it's using AI. Now, just to highlight that so many of these sounds are actually unknown. We had an example of the Australian Fish Chorus Catalogue where we looked at about 100 years worth of data across 90 sites, and the student, Lauren, managed to detect over 300 different choruses, and there were 80 different types of chorus within that. So that's 80 different species at least that are producing these sounds and contributing to the soundscapes that we can detect. So what we did was to get several of us to propose the idea of a global library of underwater biological sounds. It's a working group that consists of about 36 different institutes. I've put them up there. We are endorsed by the IPOI and by SCORE. But what we also realized that it's too big to try and create a global library, and we recommended doing regional libraries of biological sound. Now, these reference libraries are particularly good because all of the applications that I mentioned earlier are greatly improved when you've got validated signals and when you can build detection algorithms. Now, that needs a categorized reference library that includes unknown sounds and categorize those unknown sounds into different types, and to develop a benchmark training data set for each of those for machine learning purposes. That then means that you can start to detect and classify the majority of species by sound. The nice example there is Cornell's Merlin for birds. And that is the next metric of biodiversity from an acoustic point of view. In the terrestrial environment, there are lots of studies that now use the number of different sounds as a metric for biodiversity. And you can start to look at species distribution based on sound. So the example I would give for our global library would be that we can take all of the species that we've identified that produce sound, work with the World Register of Marine Species, and we've done that to have soniferous behavior as a trait in their database. That can then get matched to a biodiversity mapping system like OBIS. And I've put the distribution of gold-band snapper because it is predominant in our region. If that's a vocal species, we can actually map that distribution based on sound. I've thrown up the description of the structure that we would have just to highlight that we have a big priority on being able to pull people together and really get a good reference database and build databases of those unknown sounds so that we can build the models and test them in an AI model database. Partly to do this and to expand our partners, we have something called World Oceans Passive Acoustic Monitoring Day, or PAM Day. That's June 8th each year, where we get as many institutes as possible, and we have 100 institutes now, and we look at 400 recording sites around the world to be able to share their recordings that they have on June 8th. And we do that to engage bioacoustics community, the public, and more artists and managers. And you can look at a particular output from an artist at the website that I put up there. When you look at that on the Indian Ocean region in particular, I know this is Indo-Pacific, I've highlighted just the Indian Ocean, we've got a number of partners from around that region that have already got recordings that they're willing to share. So we have got a nice group from within the Indian and the Indo-Pacific region looking to build one of these regional libraries. We've got those data sets. We've got some of the ability with the acoustics and machine learning knowledge, but we are looking for partners to be able to expand that. What we really would like to do with this is to build those next steps in building cyber infrastructure, coordinating partners and collating those data sets, and in particular building those annotated data sets and developing the AI models and signal detectors. Now, one of the things that I didn't mention just before I leave you is that you have to do this through time, because Ellen Garland showed a prime example of how humpback whales evolve their song across the Pacific region, and they do that over the space of a couple of years. It's a cultural development within humpback whale populations to change their song across the ocean. So if you build detectors based on things that are 5 years old, they're out of date. You need to keep this up to date. There's also the fact that even in fish, you have regional dialects in some of those fish sounds, whether or not it's the cyanids, for which I know there are several species that are being mapped in India, or you have the coral reef species like Dacilus. You have regional sounds that mean you have to have these different locations contributing to some of those AI databases, and that's what we want to be able to build. So that was just a summary of what we would like to be able to put together as a regional library, an Indo-Pacific library of underwater biological sounds. And I will stop sharing my screen. Hopefully I haven't taken up too much time, and then maybe one or two questions.
Any questions from the audience? I have a question here.
Yeah.
Thank you, Professor Miles. When you scan the sounds, is there any particular frequency which you are using, or how do we differentiate between different sounds? Is it frequency or anything other parameter?
Frequency, temporal parameters, the spectra that comes within that frequency band, it can be a large number of things, and it can vary between what your targets are. Invertebrates typically produce sound upwards of 1 kilohertz to around about 10 kilohertz. Marine mammals, it could be anywhere from a few hundred hertz up to hundreds of kilohertz, depending on whether or not you're looking at baleen whales or odontocetes or pinnipeds. Fish tend to be between 50 hertz and a kilohertz, 1 to 2 kilohertz. Within those frequency bands, say cyanids typically produce sounds by pulse trains of their swim bladder. So you can look at the number of pulses that they produce, you can look at the duration of the sound, you look at the spectral peak of those individual pulses, or the pulse repetition rate. It all gives descriptions as to what the morphology of that animal is. Even female fish use it to be able to pick which fish they want to mate with. I gave a talk where I named all of my fish after different singers. So I had some that were called Barry White, Harry Connick Jr., Elvis, and in those species, it's actually the biggest male, the lowest frequency that gets the girl. And so for me, it was Barry White that won the day.
Thank you.
Thank you, Dr. Parson, for shedding light on fascinating intersection of machine learning and ocean sound analysis. Thank you so much. Next, we have Dr. Ben Radford from Australian Institute of Marine Science presenting remotely on remote sensing and time series monitoring of tropical coastal habitats. Over to you, sir.
So can I just check that you can see my screen?
Yes, sir, we can see your screen.
Right. Okay, yeah, so yeah, my name is Ben Radford. I'm basically a remote sensor and spatial ecologist at the Australian Institute of Marine Science. Just wanted to say thank you so much for the opportunity to present here. I'm really excited to basically speak to you all. I've picked some examples in my research or my collaborative research.
Can you please put it in the presentation mode, please?
Okay, yeah. Is that, sorry. Is that better?
Yeah, thank you.
Yeah, cool. So yes, I picked some examples which I hope are relevant to you from my collaborative research. So I just want to quickly, I just want to acknowledge the Australian traditional owners. This is a map of all the different Aboriginal groups. I'm presenting today from Noongar country in Perth. The work I present will cover a range of these different areas, so I just want to acknowledge the traditional owners. So just a bit of an outline for this talk. I'm going to talk a little bit about the motivations for the type of research that I'm involved with. Really the opportunity, looking at the opportunity here, which is the scale mapping and monitoring with remote sensing technologies and cloud processing and AI. I'm then going to show you just two case studies. One, which is going to look at coral reef mapping. So that's basically a lot of three-dimensional structural metrics. And the second case study is going to be looking at blue carbon habitats, particularly macroalgae and mangrove, where we're using a lot of band indices for very effective, scalable mapping and monitoring. I'll quickly also, if time permits, talk about the lessons learned. So firstly, why is this monitoring important? So basically, this map in the top corner, this red line is approximately the area where AIMS works. If you can see those yellow dots, that's where we have at least some ongoing monitoring. There's basically reef and macroalgae and mangrove environments through the whole of that area. And many of them we really don't actually monitor on any regular basis. So this is not good, because understanding condition is really important for management. A lot of these reef systems, they're poorly understood, they may be too deep, remote or turbid, so we just don't have any monitoring of them. They're outside our monitoring programs, so we're looking to lever new remote sensing technology to do some gap filling. But the methods we have, they need to be robust as well. Now this is not, the below is a paper which is, I did some research with Becky Fisher at AIMS, and what this paper suggests is that the boxes are bioregions, the sizes of the circles are actually a number of biodiversity, the amount of biodiversity, and the red or black shows that's basically the amount of research compared to biodiversity. So not very many black blobs, so that suggests that including areas such as India, although this is research is 10 years plus out of date, that there really needs more research for looking at the biodiversity compared to what we have. So a real focus of our kind of investigation to remote sensing is basically looking at these newer satellite systems. They're lower cost, they're finer resolution, finer frequency, they're more accessible, they're easier to it's easy to access and process with cloud technology. So this figure is taken from a paper I did with Martina Melba at Melbourne University. So really what we're looking at here is the x-axis is time, the y-axis is resolution, and the colors from blue through to red indicate cost. So over time, we're finding we're getting finer resolution satellites, and the cost is starting to come down. So this is really what we're trying to see, whether we can use this data. So I'm just going to go into my first case study. So just looking at these kind of spectrally and structurally complex reef environments. So this is from a study that I've done with Andrew Haywood, a couple of studies from Andrew Haywood. So really what we're doing here is trying to work out in mesophotic reef environments. These are the deeper reef environments. This is Scott Reef, so that red area in the middle, that's basically hydroacoustic bathymetric mapping. So that's something you'd normally do for a nautical chart. But what we tried to do was use this type of data to model different reef environments. Now the key that we found to doing this was looking at not really depth, but rugosity. So those little bands, the 4 bands in the corner, those 4 areas, that's basically rugosity calculate on different windows. And what we see from the blue one on the very left, which is just depth, through to the kind of speckled one is on the very right, they indicate different patches of reefs, from individual coral colonies through to reef to clusters through to landscapes. Now we found that if we use these metrics, we can really effectively model coral environments that structure, because they're so spectrally complex, that structure is actually really important. And the result was the map in the bottom right hand corner. Some pictures are taken above from the different types of environments where we can see the mesophotic reef environments through the filter feeders. And that map, if you look at any particular pixel on it, it has an uncertainty value, which is really important. So that was all well and good, but what we found is obviously multi-beam is not a particularly cheap or scalable technology. So what we've done is adapt those methodologies, but using satellites instead. So this is a study from last year with Mari Putney, who's the next presenter. So what we were able to do is take rugosity measures and actually derive them from Sentinel-2, which is a freely available satellite system. We find when we combine them with band pixel values and multi-scale, that we can effectively map coral reef environments. So this particular study, we're very interested in reef recruitment environments, which are the areas in red here. Now, that's all well and good, so that's basically mapping out areas, but to what extent can we use them? We can use these metrics or these satellites to monitor, and this is where things start to get difficult. So this plot here, these are basic pictures from the same area of a reef, and they're at different scales. So the 1 centimeter is from drone images, 10 meters is typical for Sentinel-2, 30 meters Landsat, 50 meters Motors. And in the bottom corner, we can see basically various pictures from in water, which is centimeter through to drone. And what we find is that the satellite systems that are currently available, they really don't give you the fine scale structural metrics that you need. So there is a limit to what we can do with them at the moment. We do use remote sensing for monitoring. So in the top right-hand corner, what we've got is the AIMS monitoring system. This is basically plane-based for coral bleaching. But what we see is there is potential is really in things like planes or low-level remote sensing, potentially LiDAR to solve this problem. But currently it is a problem because rugosity seems to be particularly important for not only mapping but monitoring reef systems. So I'm going to go on to my second example now, which is look at something we think is more scalable with the current technology, and I think, again, very appropriate for your environments. So this is looking at blue carbon habitats, namely macroalgae and mangrove, and use the band indices. So these are things which are basically, they can be complex, but structurally, but spectrally, they're not as complex. And this is the first study is some research with Shireen Hickey, who was a postdoc at AIMS and now research at UWA. So what we've done here is use Landsat to develop long-term time series of change over time in these, what we call these data cubes. And then we've developed this method, a multidimensional space-time random forest tool to basically pull apart changes over time. What we were able to do with this tool was find strong relationships. So we look at the graphs on the right-hand side between basically area and the Southern Oscillation Index, basically that kind of regional scale effect, but also with temperature. Now, taking these things into account, we were able to look at these time series and not only look at change, but also understand that large areas of mangrove systems were actually not mapped. So particularly in high tidal areas like the Northern Kimberley, which is the top area of the map in the right-hand corner, we were able to find another 32% by area of basically not mapped mangrove, which are really important areas. We've also been able to develop, so that was a lot of those were using band indices, such as basic water indices and also NDVI, which any of you would know is a vegetation indices. When we're looking at marine systems, so this is another study to try and expand using band values, but again now marine vegetation. So this is with Stan Masters-Francis, who's a postdoc with AIMS and University of Western Australia. So basically what we did in this instance was take NDVI and develop a marine version of it, where the indices is actually better targeted for marine vegetation by taking into account surface irradiance. It's kind of pre-calibrated to available surface light. The plots that you see on the left-hand side, these are sites across the West Australian coastline, so the sites on the right-hand map. And with this method, we could actually track effectively vegetation over time, marine vegetation over time. We could also, in the middle, we've looked at, the plot is basically a temperature plot, and we see a heat wave. And the box plot at the bottom, we can see at these sites, we have a measurable difference in the amount of vegetation pre and post heat wave. So I just want to kind of wrap up with some lessons, some other lessons learned from basically a lot of these studies. So this basically, when we look at, this is from another study with Stan Malstranis, and what it tells is the importance of sample design. So using a spatially kind of replicated stratified sample design, often use a pseudo habitat. And why this is important, if you look at the blobs on the right-hand side, the darker purple ones are the size is area, and the purple is how accurate they are. And what we see is if you do, versus you don't use a sample design, or you use preferential sample, you get very, very different accuracy, and you get very, very different areas from different sites. So it's really important to consider this. And the second one I want to talk about is the use of spatial validation for models. So I'm going back to the Scott Reef example here, where you'll see the habitat map on the very left. You'll see our sample locations in the middle, and on the right, we've got what we call a spatial kappa. So what this suggests that while we look at the map on the very left-hand side, it doesn't tell you that the model actually varies, that this uncertainty is not the same in each of those locations where we collected data. So basically, spatial kappa is a kerneling method where we look at effectively within our sample locations, how does the model vary? And this is important because if you were going to do this study was designed to look at effectively coral restoration, and if site integrity is important, we can see that you're going to pick the areas which are green, like Surrender Town at the top, some of North Scott, because you know your models works better, and so you're going to have better targeting. Yeah, so basically, just finally, I just wanted to acknowledge all my kind of collaborators. So they're all here. They're really important for basically the success of the work. And yeah, they're just all here as well. So yeah, I just want to say thank you very much, and this is very much collaborative research.
Thank you. Any questions
and
from the
I'll take
audience?
any questions.
From online also? Yeah, we have a question.
Thanks, Ben. Very informative talk. So I have a question about whether you think similar approaches could be used for plastic mapping and marine pollution, I guess, coastal and at the beach at scale, essentially, upscale that.
Yeah, look, I think it's a great question. I think if you can, the key for scale seems to be getting these indices. So I think that there definitely are. There definitely are indices which are sensitive to floating. It can be algae, oil, that sort of stuff already. So I think if you can find an indices and you can find a sensor which collects at the right sort of scale, I think that's the key. One other thing that we can potentially look at is while there are more complicated methods which can potentially have increased resolution, like using AI tools, which can not only look at just effectively band reflectance, but also behavior. So that's another option. But I think it's really something worth exploring. I know, Ronan, some of the work that you and I have done, we kind of see potential. I think there's also contextual information. If you're going to look for, you can also basically, even by masking or thinking about your study area, there are probably certain areas where your plastics are more likely to aggregate. So there are going to be, you're really going to be able to increase your resolution by being sensible about your targeting, I think, as well.
Thanks. Thank you.
We have a question from online. How best can you integrate the drone data of macro vegetation with satellite data?
Yeah, it's a great question. Not well. The problem we have is that mangroves and things like that is fine, but it's so difficult to get. There is a drone study where we've worked on this area, and what we find is collecting drone data in water is difficult. It's just that there are issues around effectively wind waves, reflectance. You need really very, very good conditions to do it effectively. Now, the exception is potentially LiDAR. So there are new LiDAR systems. LiDAR generally wasn't sensitive enough. It didn't have the right sort of scale for the problems, but there are new generation LiDAR that we're looking at. These can be mounted on low-level aircraft or drones, and we think they have considerable potential. So it's an active area of research, and it's something that these ideas are things that we should look for collaboration on. So, Ronan, to answer your question, I mean, LiDAR could be something for plastics as well. And what's really, I mean, we've known about LiDAR for a long time, and what has changed is the reference systems that give us really good virtual accuracy have just improved markedly in the last couple of years. So it's kind of exciting. I think also for some of the examples, I was talking about for looking at rugosity metric as well. So yeah, interesting.
Thank you, Dr. Radford, for highlighting the value of long-term coastal habitat monitoring. We'll move on to our next presentation by Dr. Margie Piotanen from Australian Institute of Marine Science. And the topic is tropical cyclone risk across the Indo-Pacific now and into the future. I welcome Dr. Margie Piotanen to deliver the presentation.
Hello, everyone. I have a bit of an echo on my end, so if I pause when I'm talking, it's because of that. I'm just trying to navigate to my presentation here so I can share my screen. And for some reason, it's not showing me. Here we go. Is that it? No, that's. I found it. Okay, put that in presentation mode. Can everyone see that?
Yes, we can see the presentation.
Fantastic.
Can you please put it in the slide mode, presentation mode?
Okay. On my screen, it is in presentation mode.
It is a little bit.
But I can take it out and try it again.
No, it's not.
How's that?
No, no, ma'am.
Okay.
Yes, yes, the presentation mode, ma'am.
Okay.
Below.
So thank you very much for the opportunity to be part of this workshop. It's a very exciting initiative, very important work that everyone is doing. I also would like to acknowledge. Pardon?
Ma'am, can you please put it in the slideshow, please? The presentation.
I think there's just a lag.
Downside, yeah. Near the magnification thing, there is a symbol at the last.
Yeah, I know how to do it. It's just that on my screen, it shows that it's in. I'm starting it again.
Mari, so it's definitely in presentation mode. You might have to go to the bottom of the screen and click the slideshow to put it on full screen on your end so that I think we can see it in full screen.
Okay, where is that?
So on the bottom right of your screen, there should be a presentation symbol next to the magnification. And you just have to click that, and that should put it in full screen.
Okay. It's just that my slide is hiding what those icons are. I'll try clicking. Oh, not that one. Oh, there we go. Did that do it?
It's still in the regular PowerPoint screen mode. Is it presenting as the full screen on your end?
It was until I clicked on that, and then it.
So we can see your slides running down the side of the screen. So we can see the first 4 slides. So.
Can you please press F5 in the keyboard?
Press what?
Press F5. F5.
F5?
On your keyboard.
Okay. Do I have to hit control at time or just hit plus? That isn't changing anything at time.
Okay, ma'am, you can continue the presentation, please.
Okay.
Yeah.
All right. So what I want to talk to you today about is tropical cyclones risk across the Indo-Pacific. So the movie, if you're able to see it, is showing cyclone Winston crossing the Pacific Ocean over Fiji. It was one of the largest and strongest cyclones in the southern hemisphere a few years ago. And the point of the movie is just to show you that cyclones have a classic spatial structure, a calm area in the center called the eye, inward spiraling rain bands, and then they extend over a broad area of the ocean. Around the boundary of the eye, you get the most intense winds and waves. So why should we care about cyclones? Well, they generate extremely fast winds, which build up very large waves. They generate heavy rainfall, and that combined with storm surge can lead to flooding. And all of these things can damage our land-based and coastal infrastructure, and of course harm people as well.
Sorry, Mary, sorry to interrupt you.
Yep.
So basically, because it's not in the presentation mode for us, we can't see you changing slides, so you have to change it manually, basically.
Oh, okay. Well, maybe I'll. So, can you see my slide now? My second slide?
Yes, now it's changing.
Okay, I've taken myself out of presentation mode on my end. Okay, so now you can see the pictures of devastation in Australia and India from past cyclones. So it's not just people and infrastructure that are at risk. Our coastal and marine environments can also be devastated by cyclones as well. So you can see in the pictures some examples, extreme examples of coastal forests being damaged by winds. You can also have foliation, where trees lose their leaves, but their stems are still intact. You can get defoliation as well as dieback extending into the mangrove or other forests from saltwater inundation and flooding. And then you can have things like severe beach erosion, like we had in southeastern Australia after Cyclone Alfred, which pounded the coastline for days. And things like seaweeds and seagrass can be scoured around and even totally destroyed. Now, my research has to do with the impacts of cyclones on coral reefs. So this picture here shows you the typical locations where cyclones form and trap before they displace. And cyclones generate large waves, and those waves interact with the complex three-dimensional structures of reefs and can cause extreme physical damage to the reefs. So in this picture, you can see a whole bunch of coral bommies, which used to be underwater on the other side of this little island, and Cyclone Ingrid dislodged them, threw them above the high tide line, and then eventually they're going to turn into more sand for the island. So there's a whole range of physical impacts that can happen. And that's what I did in this study. But this slide also shows you that heavy rain during cyclones can result in plumes of fresh water that can be laden with sediment that can then propagate out onto the reef and impact corals. And less commonly, you can get deep, cool water rising due to cyclone wave action. And this deep water usually has a lot of nutrients, which can result in phytoplankton blooms. Now, today I'm not going to talk a lot more about my particular research because I thought it would be interesting to look at how what I have been doing could be relevant to plastics. And what really sparked me to think about this was when I was asked to review a paper last year which looked at the potential for cyclones to actually increase the spread of coral disease. So Eric Treble is an expert in coral connectivity, and he can tell you if I bastardize this very simple explanation. But basically, when you have a baby coral, it can't swim. It's where it is settling on a reef depends on the ocean currents and waves. And so the connectivity of reefs is determined by how far the individual baby corals can float before they die. So they can only live so long before they need to settle onto a hard structure like a reef. So Ben Radford, who just presented, years ago did a study that showed during coral spawning, when all the baby corals are born, if a cyclone came along, the unusually strong wave action can actually result in these baby corals reaching reefs that they normally wouldn't reach. And so this study that I have on screen was looking at that as well. But in the Caribbean, they looked at how connectivity of corals changed when a Hurricane Irma, had passed by versus under normal conditions. So the two pictures represent outgoing connectivity and incoming connectivity for each of these pixels along the Florida Reef Tract. So where you see a red pixel, it's up to 1,000% greater outgoing larvae, baby corals, than normal. And over here, where you see red, it's the same, but for receiving corals. And then the blue is up to negative 100% outgoing connectivity. And over here, this one are ingoing. So you can see there was a big difference. And they also looked at measuring the prevalence of disease when they were monitoring these spots. And so they found, although cyclones are useful for making corals more connected across reefs, the downside is that they can spread disease. So this made me think that, as Eric is already doing in his work, we could be using hydrodynamic modeling and connectivity tools to look at plastics, but we could do it in the context of how cyclones change how the connections work. So then I decided to just have a look to see whether people were already doing this and what was out there in the literature. So the first thing I found were papers about how cyclones change the kind of marine debris that shows up on beaches. So in this example, a typhoon resulted in 11.4-fold more macro debris and twice as much microplastic. And I could see there was a heap of other studies where people found a similar thing. And a bunch of other studies suggesting that it's not just beaches where this debris would be moved about by cyclones, but further into the marine environment as well. Okay, now this study looked at Japan, and it looked 30 kilometers offshore right after a typhoon. And they actually found that the number of particles of micro and microplastic were 2 orders of magnitude higher one day after the typhoon than before. And the mass of plastic increased by 1,300 times. But interestingly, it only took about 2 days for these levels to go back to normal. And in this paper, I very usefully summarized a whole bunch of other work that's this. Also interesting is, what do cyclones do to the floating debris? Not just debris on the beach, but debris that's out in the marine environment. And this study used satellite imagery to detect and map the extent of floating debris, and they used spectroscopy to try and identify the components of the marine debris, so what it actually was that was floating around. And this was after Hurricane Katrina. And so this map is around right here where the cyclone crossed land. And then this picture shows the area of floating debris with time after the cyclone. So you can see you get a big pulse on the second day, and then it gradually declines. Now I wondered, what are the standards like for using this type of remote sensing data for this kind of purpose? And it turns out that Mohammed Wakas and colleagues published a review paper about this in 2023. And so they looked at the different methods of trying to detect marine debris using remote sensing methods, and they go into detail about best practice for that. So that was super useful. Now here's another example of floating debris after a cyclone, but in this case, the debris wasn't coming from land into the ocean. The actual cyclone tracked over a big floating patch of debris in the middle of the Atlantic. And then this study looked at how that got transported and moved around because of the cyclone. So you can see they have 3 time sites before the hurricane, 3 of them during the hurricane, and 5 of them afterwards. These gray bars are the average particle counts, and this blue line, if you are familiar with cyclones, you'll recognize it as the classic pressure drop you get as you get closer to the eye of the cyclone at the center, where the pressure is going to be the lowest. And then it'll go back up as the cyclone moves away. And this black line represents wind velocity generated by the cyclone. So it starts off calm, and then you get a peak in wind speed, which coincides with where the lowest pressure when the strongest part of the cyclone, which is at the boundary of the eye, passes over. And you can see just after that peak wind time is when the greatest amount of particles were found to be suspended in the water. So I wondered then, like, well, what's happening in the Indo-Pacific? And I found this wonderful article in Science of the Total Environment, which establishes priority for research in Southeast Asia on marine plastic pollution. And you can see under theme 2 that question 6 focuses on extreme weather events like cyclones and says we really need a better knowledge of the probability distributions of extreme weather like cyclones in terms of their magnitude and frequency, because then we can see, like we saw in these studies I just showed you, how that normal system will be perturbed by extreme cyclone events. So I thought I would end by showing you the current frequency and intensity or magnitude of cyclones around the world and in our Indo-Pacific region, and then give you an overview of what the consensus is of climate modelers about how that might change. So here we have cyclone tracks all around the world from 1980 to 2005. And you can see when you have orange to red colors, like here, that's a stronger storm. And when you have the blue and light yellow, it's a weaker storm. And the number one thing that you probably notice is that there's a huge hot spot of cyclone activity in the Northwest Pacific, orders of magnitude more than any other ocean basin. You might notice as well that there's not much cyclone activity around the equator. And that's because the Earth is its widest or
Dr.
its
Marji,
fattest.
can you please wrap it in 2 minutes?
Sure. That's because it's too close to the equator. And then obviously you're not going to go to the cyclones where it's too cold. Here is cyclone activity in the North Indian Ocean. You can see there's a lot more activity on the eastern rather than on the western side. And here's what we call the Southwest Indian Ocean. So a lot of action around Madagascar. Here's what happens. Across the Indian Ocean over to Western Australia, where we are at AIMS. And there's a lot of cyclone activity along this stretch of our coast. And here's what happens on the Pacific side, not quite as much. And then here's the Northwest Pacific, where you can see it's extremely active. So most people think that we're going to have more cyclones because the ocean is warmer with climate change. But the ocean temperature is only one of many factors that affect when cyclones can form. Some of these factors are being enhanced by climate warming, like the warmer ocean temperature and more moisture in the atmosphere, but some of them are actually limiting cyclone formation. And the example I have here is wind shear. And so wind shear is vertical downward blowing winds which destroy cyclones. And on this map, it's showing you the percentage by which wind shear will be increased if it's yellow, or decrease if it's blue to green, with every 1 degree of global temperature rise. So you can see around the equator where blue and green wind shear is going to go down, but cyclones don't form there anyway. And where it's red and orange, it's going to promote formation. Or it's not going to promote formation because it's going to have more wind shear. Anyway, oh, I can't build the slide because I'm not in presentation mode, but anyway. So what this shows is under a 2 degrees Celsius global warming scenario, how the different ocean basins are predicted to react in terms of cyclones. So if you look here at cyclone frequency, the light blue tells you the spread of values. The dark blue line is the median, and the black line is the zero, meaning no change. So when the blue line is below the black line, it's going down. So a lot of people think that cyclones are going to become more frequent, but you can see there are downward facing arrows on all of these plots because they're not going to become more frequent. The next one is the frequency of the highest intensity cyclones. Here you can see some of the arrows are pointing up, like in the Indian Ocean. So that means we're going to have a greater proportion of cyclones that are stronger. But some of them, like in the Northwest Pacific and the Southwest Pacific, are actually going down. So you're not going to have more frequent ones. And then finally, rainfall, the blue arrows, they're all pointing up, and the blue line is quite high above the zero. And so,
Mary, sorry, I apologize. We have to cut it short. We're running a bit late. I apologize for that.
I'm done.
We can take only one question. Due to time limitation, we can take only one question. I think there are no questions. Thank you, Dr. Marji, for that valuable regional risk assessment. Thank you so much. And our next presentation is on the sharks, rays and sea turtles, monitoring and conservation of marine megafauna in India by Dr. Karthik Shankar from Indian Institute of Science. So over to you.
Thank you. Good morning, everyone, and thanks very much for the invitation. Very happy to be here. I was planning to be here to meet everybody yesterday, but I had back spasms and I had to sort of like go from vertical to horizontal for a while. So I'm afraid I'm booked to go back, and I'll try and spend a few minutes before we have lunch to chat with all of you. It's really great to see everyone over here. I wish I could have been here for longer. So my talk, like some of the others, is going to be a little bit different, and largely going to talk about the work that we've done with marine megafauna in India. But I just wanted to flag that much of the work, my two affiliations are with the Indian Institute of Science, where I run a lab with, part of 1/3 of my research is on marine ecosystems, half maybe. But a lot of the work that I do is through an NGO called Dakshin Foundation, which has both research as well as interventions. A lot of the work that we do in our Marine Flagships program and in our Sustainable Fisheries program are actually heavily research-based. I'll be talking about a small part of that. I wanted to flag something that we are doing with the Ministry of Environment and Forests called the Long-Term Ecological Observatories, as part of which Dakshin is the lead agency for monitoring for the marine theme in the Andaman Islands. So we've got monitoring on coral reefs, reef fish, biophysical parameters, seagrass and sea turtles as part of this national initiative. And I'd be happy to talk, with anyone who's interested in that over email or some other, any other platform beyond this meeting. And in the passing, I will also mention that as part of our intervention programs, we do solid waste management at a couple of our sites. So there is marine debris monitoring as well. So yes, with that, let me switch over to the topics that I'm going to talk about. Sea turtles get an inordinate amount of attention. There's just 7 species in the world, but there's 2,000 sea turtle biologists and 5,000 sea turtle conservationists, and sea turtle conservation programs in like 80 countries or something like that. It's ridiculous. Our annual conference gets between 500 and 1,000 people. So I call it the most per capita conserved taxon in the world. India has 5 of these species, and there's been research on these. There's been research and conservation programs in India on sea turtles since the 1970s, actually since the 1960s. So it goes back. Maybe tigers get more attention, but actually sea turtle conservation history goes back almost as long. I wrote an entire book about that. Be that as it may, the 4 species that we encounter most frequently on the Indian islands are the leatherback, the hawksbill, the green turtle, and the olive ridley. And from a marine debris and plastic perspective, these present very different challenges because they occupy different habitats. Ridleys and leatherbacks are pelagic, so they're more exposed to sort of open ocean plastics. And green turtles and hawksbills, inhabit coral reefs and seagrass beds, and so are more exposed to nearshore plastics. If you Google it, the first thing that you'll find is this very emotive video of someone removing a straw from a turtle's nose, and it's created all of this drama worldwide. Many sea turtle species have actually increased in the last 30 years. This soon to be delisted from being endangered, the green turtles in particular, and perhaps olive ridleys in the near future. And so some of the battles that we fight are actually trying to convince people that they're not as endangered as everybody thinks they are. Case in point, we've been counting, we have olive ridley aribadas on the east coast of India, which is the largest site outside of Pacific Latin America, so Costa Rica and Mexico. We also have a new site in the Andamans, which is the first sort of like aribada that popped up in a genetic population where it was never known before. But the one that we monitor is in Orissa. Historically, there were 3 beaches. There's been no nesting at one of them since the 90s, and sort of people thought of this as part of a long-term decline. In the 2 major sites that we monitor are Gahirmata in the north and Rushikulya in the south. These populations have been known for 300 years. We're coming up sort of to the 300-year anniversary because a ship's captain wrote about the scores of sea tortoises that resorted to lay their eggs in the site in Orissa back in the early 1700s, officially discovered by a Scottish herpetologist working in Australia and Queensland, passed through while he was doing a crocodile survey and discovered this, and sort of the rest of the research history is followed. In the early 2000s, we did an analysis where, using estimates from the Forest Department, we thought that the populations were on the verge of an imminent crash. This was because of directed take in the 70s, following which there was the Indian Wildlife Protection Act was enforced, some degree of protection, but the mortality that resulted from incidental catch became really high in the 90s, and many sea turtle biologists, including myself, suggested that the trends showed possibility of declines. There were many years where aribadas had failed. We considered those to be high levels of mortality. We'd documented a decline in the adult breeding size, and in a paper we said sharp decline in the population might be imminent. We started monitoring the southern site in Rushikulya in 2007. As you can see, despite the small aribadas, small mass nesting events in some years, no mass nesting events in other years, overall the trend has been one of an increase from, I'd say, roughly 50 to 100,000 in the 2000s to over 250,000 in the 2010s and beyond. In fact, this is a picture from an aribada in 2013. This is the latest one in 2015, where we documented in this particular mass nesting event, 500,000 turtles. Uh, yes, indeed. It makes my researchers very tired to count them. Moreover, we've also documented them in offshore waters. We conduct transects in the water. And what we found is even in the years where aribadas fail on the land, the populations in the water remain at about the same size. So the lack of the absence of an aribada doesn't indicate that there are no turtles. We don't know what they do actually though in those years, but nevertheless the turtles are there. So to summarize, in terms of a conservation perspective, aribadas have occurred at multiple sites. We think they're increasing at Rishikulia from all the evidence we have. Fishery-related mortality has remained constant. There's still probably about 10,000 dead turtles, but it doesn't seem to be affecting this population. If we were in Australia, and in the spirit of the use of wildlife that you have there, looking at these numbers, I would recommend sustainable use of this population, but no one in this country is going to listen, will take that seriously. I might get threats. So the latest evidence is that we had 3 aribadas this year, which adds up to about 1 million nests in total at this point in this population. The population of Ridleys is increasing despite what you read in the newspapers. And as conservationists, the immediate evidence is that this is a population that has bounced back from whatever numbers it had declined to in the 80s and early 90s. It's doing really well. The population of olive ridleys actually across the coast of India is increasing. In Chennai, there were newspaper articles about mortality of 1,000 plus turtles in January, but they also recorded the most nesting turtles this year. And in January, when some of us predicted that the high mortality might actually be because of more turtles and not more boats, well, that turned out to be true. There's also increases, as far as I know, less well documented on the West Coast. However, and so while the immediate, so the proximate news is good, if you look at other factors, the effects of climate change, for example, we've been documenting sex ratios for the last 15 years in sea turtle hashlings. Hashling sex is determined by temperature. Hashlings don't have morphological differences. So we have to collect dead hashlings, how many ever die, and sex them in the lab. And based on our primary data, we've estimated threshold pivotal temperatures predicted for the future. And as you can see, there's a very, very strong trend of feminization of hashling production at these beaches. And when you get these large aribadas, it doesn't matter how many nests are laid in January and February. The population is driven by what happens when those hundreds of thousands of nests are laid. So we've predicted for February and March and April, which is when aribadas occur. And as you can see, with increasing temperatures, those populations are going to be heavily feminized. So threat number 1, climate change. The more proximate threat is coastal development, which I haven't greatly talked about. But I will talk briefly about plastics, which is the theme of this conference. In last year, two of my master's students for the first time studied microplastics in beach sand, eggs, hatchlings, and adults across 2 beaches. Bravely conducted about 100 necropsies of dead turtles, and in short found MPs everywhere. In eggs, in hatchlings, and adults, and sand. As you might expect, fibers were most dominant, most likely from fishing gear. We did confirm maternal transfer, which was very cool. So we did confirm transfer from gravid females to embryos, but we didn't record transfer from the sand into the eggs. Neither of these is surprising because the eggs are not shelled, and so you would expect transfer from the mother to the eggs. And the reptilian eggs are permeable, so they do absorb moisture, but solids probably like less so. And as you can see on the left side, a fairly large number of macroplastics, hooks, and all kinds of other debris in turtle gut as well. And I think microplastics at least were found in every single turtle tissue that was examined. Other questions that they asked, no site or sex differences. So clearly the There's greater fishing at one of the sites than the other, so and greater industrial development. There was an expectation that there might be more microplastics at one site, but clearly these are with currents coming in from different locations. We don't know where. Some Raman spectroscopy results not conclusive. This very briefly are particle drift results from not for plastic or debris. We conducted this as part of a student of mine a few years ago was working on marine mollusks, and so we modeled this for the coast for looking at patterns of genetic connectivity of marine periwinkles, and this is published. I'm sorry, the figure is not great. I just sort of like pulled it out of the paper. This is published in Limnology and Oceanography in 2022, and I'd be happy to share that reference. I think it provides some early clues to what plastics that are thrown out from our coasts might do, just as a sort of a sweeping approximation. So that's it about Ridley's. The other major sea turtle population that we study are leatherback turtles in the Andaman Islands. This is we study them particularly on Little Andaman Island, south of the major Andaman group. We've been monitoring them again since 2007, and as you can see from the slide, from the yellow bars, that the population of leatherbacks on this island also since the 2004 tsunami appears to have been increasing. Or if you want to be cautious about the interpretation, they appear relatively stable. We couldn't continue our work in the Nicobar Islands because of the remoteness of the site and the potential, the camp that we had in Great Nicobar, was wiped out completely. All the field staff there perished in the tsunami. We lost a researcher, so we didn't want to set up camps over there. There is a remarkable story, if you want to read it online, of one of our field staff who survived for 10 days at sea without food or water after the tsunami. So that's pretty cool. But we do occasional monitoring there, and what we found again in much of the Nicobars is that populations recovered after the tsunami, the beaches reformed. And again, population-wise, these leatherbacks, like the olive ridleys, appear to be stable or increasing, and there are fewer threats to them from just the population dynamic perspective in the short term. We haven't done sexing, but we suspect that the patterns that we see with ridleys might reflect here as well. So there's probably a feminization of hashling's problem. We did track them, and one of the things, leatherbacks are particularly known for their diets on diet of jellyfish. They go to colder temperate waters to feed. So some of them do come across to Australia. And the joke about this is that the myth about what these turtles did for the last 40 years since they were discovered is that they foraged off the coast of that they came from Australia. And I've had people locally tell me that they say, "Oh, these turtles come from Australia, sir." I saw one. On the back, it was written, "Made in Australia." So there's a widespread myth of, widespread stories about how they come from Australia. And the other great story is that one of our mentors who worked on leatherbacks in all of these locations, when he tagged turtles, actually not in India, but in Papua, they were convinced that he was tagging them with these metal tags so that he could go back to his country and attract them all back with a giant magnet. And they're like, that's why there are no leatherbacks here anymore, because some strange guy came here and stole our turtles. So there's all of these myths around where these leatherbacks go, and as you can see, we found that some of them did go to Australia as we suspected, but the last two turtles that we tagged, the last three turtles sort of went westward and ended up off the coast of South Africa. So we don't actually, I show this slide to say that we don't know what threats they're encountering when they're away during their migration and foraging. We do have particle drift models again, to track the leatherback. So this was, where do leatherback hashlings go? This is just an approximation of sort of the summary of all of those particles. This is preliminary. It's a paper that's sort of in review, but I'm happy to share results if you write to me. Again, doesn't help us with identifying. I mean, to a certain extent, gives us a loose approximation where the garbage from the Andamans might go. But actually, in the Andamans, the bigger problem is where the garbage is coming from, and that's not something we've done yet. And so then to sort of come to the last part of what we do, we have worked on sea turtles for about 25 years now. Our long-term monitoring programs are about 20 years old. We started monitoring sharks and rays, again, primarily through the introduction in 2018 or so. They became formalized into long-term monitoring programs about 3 years back. So I think one of the reasons we have a fisheries programs that looks at sustainable fisheries, and while our flagships unit sort of looks at these long-term dynamics of sea turtles, and we found that these are stable or increasing, one of the things that we realized that even though the word flagships denotes that they're sort of really representative for the health of marine ecosystems, one generally finds it hard, both with the government as well as with the public, to sort of convey that we should defocus on sea turtles and focus on larger issues. And so we thought one of the ways of doing that was to actually start programs that explicitly focus on other components of the ecosystem, such as reefs and elasmobranchs. Sort of midway, they're also kind of flagshipy. As far as we knew from the evidence from many decades of data collection by the government, that many species have declined in terms of their catch, have declined in terms of the adult sizes, the sizes that are being caught, and so there is evidence that these may represent species and groups that are actually more immediately under threat. And the reasons, of course, are because they have long generation times, low fecundity, low reproductive output, and so on. This is reflected in global assessments, where 37% of elasmobranchs are threatened due to overfishing, habitat degradation, and pollution. In India, we have about 170 species. Most actually have been assessed. There's a large number of them that are vulnerable, endangered, and critically endangered. India is one of the top elasmobranch fishing nations. They caught in a variety of nets, actually, from artisanal to industrial fisheries. Used to be bycatch, but bycatch really is a misnomer now, because even if they're not targeted, they're sold as sold for the fish meal and other industries. Rapid assessments do show declines, and they're consumed for a variety of reasons. So we initiated the long-term monitoring program in 2022. Mainly to address overfishing and lack of systematic monitoring and species-specific data, to generate baseline information to support conservation and policy and local management. Dakshin's philosophy is founded very much on environmental and social justice. Our aim within the fisheries work is to build capacity for long-term monitoring and management. We also work with fishing communities on health and governance and livelihoods and education and so on. One of our mottos, which I will state first in Hindi because it sounds best in that language, is "Khane ke liye bachao," which is eat it, save it to eat it. Okay, so our message to fishermen is not conservation because they're pretty or scientists like them or they're wonderful or fascinating. Ours is like, you want to continue eating it, you gotta keep it, right? To eat it, you keep it to eat it, or however you want to. I think our English translation is "save it to savor it, fish for the future." But the Hindi version sounds best because it came spontaneously one evening from one of our students. He was like, why do we talk about conservation? We should just go to the fishermen and say "Khane ke liye bachao," which sounded perfect. So that has been initiated in multiple sites. Right now, we have one key location in each of these states, one in Maharashtra, two in Andhra, one in Tamil Nadu, and in the Andamans. And we do plan to continue expanding that. We're collecting data on catch, bycatch, fishing effort and gear, as well as biological measurements. Now, incidentally, as part of that, many folks here will recognize the challenges that we face in getting permits sometimes to work with endangered species like turtles. Fish that are caught are great because the fishermen have caught them and they're lying on the beach. So they make great subjects for masters and PhD dissertations. So in the last 4 or 5 years, there's been maybe about a dozen master's students that have worked on different aspects of genetics, diet, diet through stable isotopes, but also microplastics. And so across these sites, we've had students work on both sharks and rays, multiple demersal reef-associated and pelagic species. They've sampled gut tissue, muscle tissue, and one of them worked on gonads. That one paper is published. Again, the short summary simply is that microplastics were detected in over 95% of tissues. Again, the dominant type is fibers. The study that the student did on comparing gonads with other tissues found evidence of bioaccumulation with the highest concentration of female gonads, and again, a small amount of Raman spectroscopy to identify the polymers. Again, so far, perhaps unsurprisingly, no differences between sexes, habitats, or trophic levels. We're a little surprised not to see any effects between trophic levels, but we haven't found any at this point. We think this indicates fairly wide distribution across the water column because the benthic and the pelagics show the same levels, and perhaps highlights the pervasive nature of microplastic contamination in these environments. I will emphasize that all of this is preliminary. Each of these is a small piece of work done by a master's student over a few months, but we are accumulating evidence to this end now. One student has worked on rays. Same story, 100% of all the samples, fibers were dominant, highest concentration in the muscles in this particular case, and again, a small amount of evidence of bioaccumulation. All right. So the monitoring and conservation, the summaries for turtles is that olive ridley turtles appear to be increasing in Orissa and along both coasts of India. Leatherback turtles are increasing, and for all the global attention and for all all of the sometimes media and conservation sort of breastbeating about them being on the verge of extinction, these populations really seem to be doing well on the short term relative to fisheries related and other threats. This is what, when people see dead turtles on a beach, they get very upset, right? But that really doesn't seem to be the problem. The problem is from the more sort of like unseen threats such as climate change and coastal development, which are also harder to deal with, right? Because what does a conservationist sitting in Chennai or wherever do about this? Whereas you can go on the beach and you can be like, I'm saving a turtle. So we think there's a bit of a disjunct between what the threat is and the recognition of it, and also the empoweredness of people to engage with it, right? Like, how do I stop a big port from coming up? I can't, but I can go out and put some turtle nests in a hatchery and feel good about it. Which is fine. But we do need to recognize that the big threats are coming from elsewhere, not just to turtles, but to marine environments on the whole, which is reflected in I think the microplastics. I don't know, but my sense from the literature is right now there isn't clarity about the physiological effects, the long-term physiological effects that they have. They are inert compounds, so it's probably better to have a microplastic than some heavy metal, perhaps, I don't know. But right now the evidence is not clear. But to me, they're an indication that there's pollution effects and there's other effects out in the ocean that are affecting every single organism that we pick up and study. So even if even if it's not the physiological effect of the microplastic itself, what we're seeing on the Indian coast is this really pervasive, widespread impact of anthropogenic activities in the ocean. And with sharks, that's sort of even more more of an immediate concern, because while we don't want to have any policies or laws that have immediate and negative effects on marginalized fishing communities, and I as a scientist and many of us as an organization would actually oppose that. Nevertheless, we do need to think in the medium term of how we mitigate declines for particular species. And the story is even more sort of stark, if you will, looking at sharks and rays as a community as it is with turtles. So with that with that bit of optimism and that substantial caution, I will sort of end with acknowledging actually dozens of researchers that have worked on our sea turtle program, just some of the key ones there, and a rapidly sort of growing shark and ray program that is mostly the first. Garima sort of managed the program, a master's student from a few years ago. The rest of them are all master's students. and we've got a few recent papers on these topics, but I'd be happy to share more with anyone who's interested. Thank you so much.
Time for questions.
I have.
Yes, please. We have more questions for the session. Yes,
I know Dr.
please.
Karthik for the last maybe 20 years back, going back. So, thing is, just one question. What I wanted to know that people usually, there is a myth. I don't know how far it is correct. The myth is that the hatchlings, once they return to the natal beaches.
Correct.
Is it true, or how? What is the study on that?
When I started working on turtles, it was a loose hypothesis, right? It was a rumor amongst turtle biologists that they come back because they'd seen some evidence of adults coming back to the same beaches, and because they grow from this size to a giant, 3 feet or 6 feet in length, one wasn't sure then. From the mid-90s, when people started using genetic tools, the genetic analysis has shown without any doubt at all that at least all the populations that have been studied, that without natal homing, you cannot see the patterns of genetic structuring that you see. The hatchlings have to be coming back to exactly the same beaches, to the same beaches where they nest. Now, the question is that there is still a misunderstanding of what this natal beach is, right? In the sense that it could be one island. For example, there's the very famous green turtle population in Ascension Island in the middle of the Atlantic, and in that case, the natal beach are the beaches on that island, because when they came back, if they missed it, there was nowhere else to go, right? However, an error made on the east coast of India does not have such a consequence. So our genetic analysis shows that all of the turtles on the east coast of India are genetically identical, and in fact even to the west coast. So a natal beach for a turtle nest born in Orissa or in Chennai could be just the east coast. Okay. And this year, for the first time, there was a tagged turtle that was recorded, that had been tagged in Orissa, that was recorded nesting in Maharashtra, which you may have seen in the newspaper. And if you had asked me last month, I would have said, I stake my reputation, this won't happen, right? They may go somewhere else on the east coast, but actually we were wrong. The natal beaches appear to be even, perhaps at a broader spatial scale. But on the average, I would say that it would happen within the broad zone of where they are using magnetic imprinting to come back to a particular location that is guided also by the currents. Now, if two locations have a similar magnetic signature, there is a possibility that they're going to make an error, right? So, and errors is how they also disperse evolutionarily. That's how they went from the Pacific to the Atlantic and to the Indian Ocean and the Atlantic. But within generations, for the most part, individual turtle hatchlings are using magnetic orientation, navigation to find what is approximately the beach where they were born. Yes.
Yeah, I have another question. Just, I have another question. That how many, because these are all endangered species, how many samples you have taken for microplastic studies? 100% you said. How many sharks you have?
Oh, so because they're endangered, we can only sample dead animals. So we sample dead hatchlings and we sample dead adults.
Yeah.
So we got about 100. We did about 100 adults.
Yeah,
100 adults.
That's what I.
Yeah, there was so these are the only students of mine who were happy to see dead turtles. They were like, oh, one more sample.
One last question. Others, please can discuss during lunch. We'll take this one first. May please speak in the mic, please.
South Indian coast, we have monitored so much of mortality of sea turtle. What is the main reason, especially from January to March? What is the reason? Maybe water quality variation?
No, fishing.
Harmful algal?
No, fishing. Fish. 90% of all mortality, 95% of all mortality is death in fishing nets. 99% maybe even is death in fishing nets. But my point to the conservationists is that this level of mortality does not seem to be affecting the increasing trend of the population. that is because they die of asphyxiation, there is bloating of different sort of parts of the body. So no. So as far as has been recorded up to this point, it's over 90% is fishery-related asphyxiation. There is no evidence actually that it is caused for any other reason, from the simple fact that you don't get that mortality in the foraging areas, right? If you had a disease, you should get the same kind of mortality both in the foraging and in the breeding areas. When they are breeding, they come within 5 kilometers of the shore. There is illegal fishing by trawlers in violation of the Marine Fisheries Regulation Act in nearshore areas. That is like at least in Orissa where we've studied it, that's the cause of about 90+% of fishing mortality. To the best of our knowledge now.
Thank you, sir. My sincere apologies. Other people can interact with him during the lunch session. Now, let's take a moment to felicitate our speaker. Online, there are no questions, sir. Now, I kindly invite Dr. Ronan to kindly felicitate Dr. Karthik Shankar as a token of our heartfelt appreciation for his insightful presentation.
As Dr. Usha said, I feel like we are the hosts here.
Thank you, Dr. Ronan. We now break for lunch and we'll reconvene here at 2 o'clock. Happy lunch. of minutes.
Can I try to do screen sharing?
Good afternoon, everyone.
Good afternoon, everyone.
Let's dive right into the next presentation. Our first speaker is Dr. Indan Suzy Nurhati from National Agency for Research and Innovation. We welcome you, madam. You may start your presentation.
All right. Okay, thank you. Hi, everyone. Good afternoon, I believe. Sorry I cannot join with you this week. I hope you've been having a great week. Let me try to share my presentation first. Okay. Hold on. I usually have issue with Microsoft. 1 second. Okay.
Just a small reminder, you have 15 minutes and try to stick with the time.
Okay, hold on. I'm trying to share my screen. It's not letting me. I think I'm having technical problems with it. It won't let me share my screen. Can I just log off first and come back? All right. Let's try again. Okay. Can you see my?
Yes.
Can you? Okay. So okay. Sorry about that. All right. I'll go fast. All right. Hi everyone. So I'll go straight. Can you hear me well?
Yes, yes.
Can you hear my voice?
Yes, we can hear you, ma'am.
Okay, good. All right. So my name is Intan. I'm from the Research Center for Deep Sea. I'm a paleoceanographer by training. So I guess in these presentations, I'm going to present how corals can be very useful to understand past climate as well as marine environmental changes. So I think many of you in the room might be marine biologists who work a lot with corals, but I'm a marine geologist by training, so I use corals as a natural archive to understand past climate. So by drilling the corals and take them to the X-ray in the hospital, I can see their ages, so such as similar to tree rings, as well as similar to sediment or stalagmites or ice core. But what's really nice about corals is it gives you annual resolutions of data. So you can basically go monthly with corals, and it's continuous if the corals didn't die in the middle of the lifetime. So it really rivals the instrumental data. So in times and places where we don't have instrumental data, this could be very, very useful. So I just want to share sort of like different chapters of corals. So if corals as a natural archive is a history book, so they can have different chapters to study ocean and climate, as well as marine pollutions, as well as looking at the health of the coral itself, such as coral classifications. And the way we do that is by measuring the geochemistry in corals, such as strontium, calcium, oxygen isotopes, boron isotopes, that serve as proxies to ocean and climate parameters. So let me give you one example. This is from Indonesia in South China Sea in an island called Natuna, where we have these nice long corals and we can reconstruct temperature, salinity, as well as we are attempting to reconstruct ocean pH, which is a nice proxy to study ocean acidification. So on the top, so the red line is actually the reconstructions of sea surface temperature using corals from 1920s to 2010. So you can see that if you look at the spectrum analysis on the right, it has a nice annual variations, but it's also have a trend of warming of our ocean in the South China Sea. But below, which is the green line, is the reconstructions of salinity, which is very rare. What I mean is, for temperature, we can actually have some ideas from satellite, but for salinity, it's very difficult to have high fidelity salinity data. So the green one is what we can reconstruct using corals. And as you can see on the right side, if you look at the spectrum, it has a nice annual variations as well as interannual and perhaps decadal variations. So this is something that is very valuable from coral records. Now, I just want to give you a glimpse of what if we reconstruct ocean pH. So it's more difficult to do. So the red line is actually the reconstructions of ocean pH underlying the salinity data, which is the green line. But I didn't have enough time to do the whole data, so I only did it in the beginning of the record, the middle, and the end of the record. So, but what you can see here, we can't really jump right away, to the story of ocean acidification without understanding the whole oceanography. So what you can see here is that the ocean pH, the variations of ocean pH vary with ocean salinity, or they closely associate with salinity. Sorry, did I?
No, no, ma'am. You
okay.
can continue, please.
All right. So this is what I'm going to show in this slide is that by having a multi-proxy strontium, calcium, oxygen isotopes, as well as boron isotope, we can have a good understanding of past temperature, past salinity, which can infer rainfall, as well as ocean pH, which is such a big issue right now in terms of understanding ocean acidifications. Well, I did mention that you can have different chapters in the history book of corals. What I also want to show you is corals as a history book of marine pollutions. Again, this depends on your research question. For example, you can look at you can reconstruct heavy metals such as lead, and if you measure lead isotopes, you can actually try to figure out where the lead's coming from. And also, if we measure barium calcium, for example, this is a work that AIMS actually champions the whole thing. Actually, you can also reconstruct sedimentation, which is very useful for many coral ecologists. Sorry. So this is an example of a study in Gulf of Thailand. So we did reconstruct coral barium calcium in the upper Gulf of Thailand, which is very highly sedimented area. So what you can see on the top, which is the green and the orange dots, these are the reconstructions of coral barium calcium, which is a proxy for sedimentation, or theoretically. And then we did it by different season, so southwest monsoon or rainy monsoon, and also dry monsoon. And then we tried to figure out what has been driving this pattern. Short stories, I think what's the story behind this coral barium calcium is that near our site, near our coral, where our coral used to grow, there has been a development of ports. So you can see there has been a higher coral barium calciums around 90s, between 90s to 2000. And that coincides with a period when they start expanding the port of Layam Chabang ports. And there's also another sort of second development around 2010, which also coincides with the higher barium calciums. But you can also see that some flooding events, such as in 2002 and 2010, really reflects on the coral barium. All right, another story, another chapter is also looking at the coral classification. I guess the past chapters has been kind of geologists using corals, but what about the corals itself? So we can also try to understand the health of the coral by looking at the coral classifications, which is a product of annual extinction rate and skeletal density. This is a case for Seribu Islands, Indonesia. It's a really interesting place because it's a marine parks, but it's right adjacent to or next to Jakarta. So Seribu Islands is very close to Jakarta, very high terrestrial input, many rivers, although it's been designated as marine reserve, but what can you do? You know, you're facing a big city. So there has been a loss of biodiversity, a huge loss of biodiversity documented since 1920s to now. And also it's an area that is known to be affected by ENSO by having coral bleaching. And what I want to show you is actually data using 3D CT scan. In many places, there are many studies using sort of like two-dimension X-ray, but there's an issue with 2 dimensions because X-ray only have one source of light, and you have to do many correction with 2 dimensions. But if you do a 3 dimension with CT scan, it's more expensive, but you can see the whole core to understand coral. Yeah. Okay. So let me go quick. I don't know how much time I have, but basically in Jakarta, in Seribu Islands, which is close to Jakarta, we see that coral classifications has been increasing. There's a trend of higher coral classification, which is very surprising, knowing that this is not such a happy place for corals. But what we then try to see and understand is that this is because the coral growth rate over the last 30 years has been increasing. So the corals are basically growing taller. If it's a person, the corals are growing taller, but if you look at the density, they less dense. So it's like a tall person with osteoporosis problem. So that's what's happening in the Seribu Island just offshore of Indonesia. So this is a very interesting finding that we can see, but again, you need a lot of replication for this kind of study. And we try to understand why these patterns. We have some nutrient data which might explain that the increase of coral growth might be driven by higher nutrient, but again, the data is quite sparse. We also look at the correlation with ENSO and as well as the IOD, the Indian Ocean Dipole. So what really the roles of nutrient versus climate. What we can see in climate is that yes, ENSO does influence coral calcification, but when ENSO is too strong, the corals just die. So only moderate events of ENSO actually correlates with coral calcifications and similar with IOD. But the question really is, we think they have reached their limit because the nutrient in Jakarta Bay is really high, as well as the temperature is really high. This is probably the limit of corals that what we see in the past 30 years, which is increase of coral calcification, may not be the case for the next 30 years. So there's a limit of for everything there. All right, take-home message. I hope I can give a showcase that coral skeletal geochemistry can provide records of climate and marine environmental changes. As the case for climate story in Natuna, well, I want to show the result, but I also want to give you some cautions. I mean, it's a great tool, but there's so many things that you have to pay attention to. That, of course, you have to understand the complexity of the oceanography. For example, if you want to derive the trend of ocean acidification, of course, you have to understand the annual, interannual, and decadal first before saying anything about long-term anthropogenic trend. And also with paleoclimate in our region, especially in Indonesia, I have to be very careful for choosing the site because, for example, coral strontium calcium would not work really well in near-shore area. So you have to choose your site wisely. Otherwise, the proxy will be useless. And also, you have to really pay attention to the analytical methods. There are wet chemistry, which is the best, the golden standard. But there's also laser ablation, which is faster, but they have limitations and so on. As for corals as a history book of marine pollutions, we see one of the examples in the upper Gulf of Thailand that may be associated with port development and flooding events. But again, the cautions is that we have to understand the local variations. You have to be very careful when you're calibrating your coral data with satellite data or in situ data. For example, if you want to calibrate with temperature, satellite data is really good. But if you want to calibrate with rainfall data, I would suggest looking at local met data. And in terms of coral health, coral classification in Jakarta, we see that temperature and nutrients have impacts, but we think they might have hit their threshold. So the story might be different in the next coming years. But again, the cautions here, because this is coral classification, is very biology. You have to have many samples so that your signal to noise ratio will be high enough. So I hope that a quick overview of what paleoclimate can offer, and hopefully in this forum, in the next coming collaboration, that this forum will be built. Thank you for your attention. Again, sorry I can't join with all of you, and hopefully to see you in person next time. Bye-bye.
Thank you, Dr. Intan, for a wonderful presentation and giving us the valuable insights on paleoclimatic reconstructs. Now we will move on to next presentation, which will be given by Dr. Corey. Oh, sorry, we'll have a quick 1 or 2 questions from the audience.
Okay.
Please. Sorry for missing out that part. Yeah.
Right.
Please, online also, please check it. Oh, no questions.
No questions.
No questions. Okay,
Thank
thank
you.
you. Thank you so much. Then we'll move on to next presentation by Dr. Corey, who is also from PRIN, on the topic marine plastic debris in the deep sea and small islands.
Hello, may I check? Because I don't think that the audio is possible for us.
Okay. Can we start? Can we start? Online somebody said cannot finish. Okay, thank you. Uh, Good afternoon, everyone. My name is Kori Yanti Manulang and come from Research Center for Deep Sea, the National Research and Innovation Agency, BRIN in Indonesia. Today I will talk about our study, plastic pollution from small islands to the deep sea and insight from Ambon Islands and Indonesian through pathways. So why I'm passionate to talk about small islands and deep sea because like small islands are vulnerable to the marine plastic because it's due to their limited waste, limited infrastructure and the lack of the landfill and everything, and also the deep sea. As we know, deep sea is known as like a sink for marine plastic or microplastic, and both ecosystem are risk to biodiversity loss and food chain disruption. Now we jump to our findings from small islands, Ambon Island. So Ambon Island is a small island but situated in the deep sea area. So and in distributed as well in the center of Coral Triangle, one of the Indonesian most biodiverse marine environment. And Ambon Island also the small islands, the dense populated small islands in Indonesia, the average is significantly more than the national average, and due to the limited resources, inadequate waste infrastructure, and low public awareness, Ambon Island face the greater challenges in managing marine plastic compared to the mainland regions. And from our monitoring 2 years, we found that the marine litter monitoring, we found that over than 80% marine litter found in the beaches in the Ambon Island was plastic. What is the most remarkable from our findings that plastic waste has a major impact on mangrove health. We do a study in the several mangrove zone in Ambon Island. We do survey conducted in mangrove zone, and we divided the mangrove zone into three different zones. That is landward zone, middle zone, and seaward zone. And then in the same time, we measure the mangrove tree, the vegetation and the health, and we measure the seedling as well, and also microplastic and mesoplastic. And we do analysis correlation about the relationship between the plastic abundance and the vegetation health of the mangrove. And what we found that a lot of plastic we found in the mangrove area is about 66 plastic per meters. It's quite a lot. And then we found the landward zone is the most populated and most plastic we found there, a bottle plastic, a bottle cup, and a plastic bag, and that is indicating that strong anthropogenic influence to the mangrove area. And we do analysis that the plastic has a negative impact on the mangrove vegetation due to the tree density, survival, and tree size. And another study we found in Ambon that the plastic that covers the surface of coral reefs to the coral death. We do sampling in 3 different locations in Ambon Bay, in the moderate area and populated area. In the populated area, we found a lot of
plastic covered the coral reef, and the coral reef mostly dead. And we found also in the moderate, but they still survive. Now let's jump to the deep sea area, where the Indonesian seas provide the only pathway from the low latitude Pacific water to the flow into the Indian Ocean. The phenomenon was known as Indonesian through flow. And the main gate of the ITF, Indonesian through flow, was is Makassar Strait. Then there is a deep sea area, more than 200 the depth, and as we know that microplastic can be carried by ocean current. From our study, we do sampling the water column along the Indonesian through flow. We sampling in 11 station, and we took the water sample from the water column using a bottle rosette that attached to the CTD. And each station we took 8 to 10 station, and we took the water sample from like the sea surface and the DO maximum, thermocline, upper thermocline, bottom thermocline, and near the bottom. And the depth our station is reached to 2,450 meters. And along when we collect the water, we also measure the physical parameter of the water column, that is salinity, density, and temperature, to know the relationship about the distribution of microplastic and also the physical parameters. And what we found that microplastic were found to be widely distributed throughout the water column. We found microplastic in all the station, and the concentration quite a lot. It's 1.06 item per liters. And when we do analysis, when we plot when we plot all the physical parameters and also the microplastic concentration in one plot, and we found that microplastic accumulated in the thermocline area and also in the bottom of the thermocline. And we also analysis with the statistic that we found that temperature and density has a significant impact to the number of microplastic present in the water column. And next and then we do analysis section of the north to south, the section of microplastic, and we found that the basin areas along the Makassar Strait seems to be susceptible to trapping the microplastic. And when we do analysis the concentration of microplastic from each depth, and we found like in the depth of 100 and 300, we found a lot of microplastic, which is the thermocline layer. And especially we found in the gate of in the north, we found a lot of plastic in the thermocline layer. That's why we hypothesize that the microplastic may be coming from the Pacific Ocean. Another study, we also found that microplastic suspended in the water column can be mistakenly as a food by biota. In the same station with the previous study, we took the zooplankton. We collected the zooplankton from the depth 200 meters to the surface, and then we collected the copepods from the samples. And for the analysis, we try to know how much the microplastic in the different group size of the copepods, and we do three size of copepods, and we analyzed in how much microplastic inside the body of the copepods. And for each group, we analyzed about 200 copepods. And what we found that microplastic, we found mistakenly as a food as the biota. The color is blue and transparent. It's quite similar with their natural food in the water body. And the most type was fiber. And interestingly, that we found more plastic when the bigger copepods and the bigger microplastic we found. Maybe because when the bigger of the copepods, the more he needs food, and then he maybe like the smaller one they only eat 3 times, and then the smaller one they eat 5 times. So the more possibilities they can mistakenly the microplastic as a food. And for the concentration, we found was 0.02 items per individual. It's comparable to one microplastic we found in every 45 copepods. So the conclusion that plastic pollution threatens small islands and ecosystem. Based on our study, found that like coral reef and mangrove health is really suffer from the marine plastic pollution. And microplastic are widely distributed throughout the deep sea water column, and maybe and the temperature and density significantly influence vertical distribution of microplastic. That maybe the same pattern also happen in the major current system like ITF. And deep sea organisms, including zooplankton, are raised to ingestion the microplastic, and this is alarming from the food chain. Yeah, that's all. Thank you.
Thank you. Any questions from the audience?
It's an ignorant question, but did you check what you just said, that the big animals, they eat less than the small animals? Being a big animal, I can tell you they eat much more than the small animals. I mean, could you check it, or it's just an assumption?
Based on the literature, that the bigger biota, they eat more food, so that's why it's possibility of they taken the plastic for food is more higher.
As you said, that the vertical distribution of this plastic, microplastics, in which that 5 meter to 100 meter, so like that you have been mentioned. So in which that what I want to say is that you correct me if I'm wrong, might be. So what is your viewpoint on that? So when you are going to vertical distribution, so surface to even something like 60 to 70 meters, so subsurface chlorophyll maxima, so there might be more possibility of these particles association might be. I'm thinking is it may be true. Have you seen anything this 5 meter depth what you got the particles, something like you said that average values are 1 particle, right, for a later or something. And coming to that 60 or 70 meters depth now, have you noticed anything much more, since the density aspect or more amount of organic matter degradation at that depth, more chlorophyll, there is a possibility to that, some kind of possibility of that film, something like that. Have you noticed anything like that when you are collecting through that Rogetti, the samples?
the distance is not really the distance.
Yeah, I understood. As you mentioned the thermocline, where you are speaking about something like 100-meter depth, which are the more concentrations, both south and north, as you mentioned, right?
Yeah.
Okay. Yeah, thank you.
So one simple question, ma'am. So how do you differentiate the exoskeleton of these copepods with the plastic particles? How to differentiate exoskeleton? The copepods are having exoskeleton,
Yeah.
chitinous. Okay, that also looks similar to your plastic.
Yeah.
So how you are going to differentiate whether it is a exoskeleton or a microplastic or plastic?
We do the polymer identification with Raman. So
All the particles, all the microplastic data.
not about the 20%.
You have to do the entire, then only you can come. Just it may resemble same. So suppose you have collected so many particles. Let us say 20 particles you have collected. All the 20 particles you have characterized.
No.
So that's what that's the question.
Yeah.
So maybe the data. Then in that case the data will be wrong.
Yeah.
Because you may it may mislead that you are being means it may be the particles coming from the zooplankton. Okay.
But we already anticipated about the skeleton and the plastic and then
Have you published the data?
yes. And then we check the plastic films and this is the plastic, not the skeleton.
But we work with Japanese guys. They told no, everything has to be analyzed. You have 1,000 particles, you must see 1,000 particles to analyze. Then only you will confirm. Okay.
Yeah.
That's all.
Really good work. Thanks for the presentation. I was wondering if you have seen any difference in polymer type as you went deeper in the water, like considering your vertical sampling. Did you see denser polymers the deeper you went or the deeper you sampled, or there was not much of a difference?
If I'm not mistaken, not really difference of the all the water column, but we found like the more the density is more higher in the when in the deeper waters. Yeah.
But you just said that something around the 600 people per square kilometer in that island.
Yeah.
So you have, what is the management system there? You are telling if it is from the through flow, it is going leakage is through flow, and from that island mostly from that island the leakage coming or
from the through flow.
So through flow from where it is coming. If you
From
have
the-
a better management system, can it be curtailed the amount of plastic that is going inside through flow? What is the management for that? Any solution you have?
So the ITF, the Indonesian through flow in the Sulawesi, and Ambon Island is the west. And but the Indonesian through flow go to the Maluku as well, the Ambon Island as well.
We have one question from online. Jaya, can you please raise the question?
I cannot read.
Okay, I'll just read it out. Excellent work, ma'am. Provided I do time series mapping of floating debris and mangrove, extent mapping. How do I relate the little sediment is affecting the mangrove growth? What are the parameters to be considered?
Okay, based on our study, and we collect the mesoplastic from the sediment, and we found that the plastic cover the soil, and then the photosynthesis in the mangrove is not really it's disruptive, and for like what is to be considered? The you can check the parameters or the chemical and the physical of the physical and chemical parameters, and if you can do the the others, you can take the other pollutants. It can be good. And
thank you so much. Now we'll move on to the next presenter. I invite Dr. George Benesso from AIMS to present a topic on a focus on the marine debris and biodiversity mapping for conservation, focused on Indian Ocean bioregion.
Thank you. Can everyone hear me okay? Wonderful. Okay, so I'm going to provide a really large holistic scale approach to looking at the influence of ocean-based debris, in particular focusing on ghost net pollution or other marine-derived sources, and also integrating that with different biodiversity metrics to feed into more practical management strategies for conservation. So we know that it's not only human livelihoods at stake here, it's also these fragile marine ecosystems as well. So just a very brief kind of note, if you haven't already, please log your registration. We're collecting some really cool stats on the attendance of this workshop, and anything would be greatly appreciated. So I'll give you about a couple of seconds to kind of hit that QR code and we'll continue. Excellent. I might continue. Just a brief background about who I am if you haven't come up and had a chat already. I'm Dr. Josh Benesso. I'm currently a research fellow in the area of climate change impacts at the Australian Institute of Marine Science. I have a really diverse background that spans both coral reef ecology, GIS and remote sensing of coastal landforms and benthic habitats, understanding the coral reef geomorphology and geomorphology of coastal landforms like coral cays, and also the biogeochemical fluxes on coral reefs as well, and also recently dabbling in a bit of molecular ecology. So I come with a bit of a wealth of biodiversity background experience from both cells to organisms to ecosystem levels. So please feel free to reach out if you have any questions with regards to these other disciplines. So a bit of a brief introduction about the context of this study. So I'm going to deal with mainly ocean-based marine debris sources. And so we've had a lot of really amazing talks which have already addressed some of these pressing debris sources already. One of them being this abandoned, lost, discarded fishing gear called ALDRF. And you can see here a number of really provocative pictures of how these actually affect benthic marine habitats or these pelagic systems in the case of that free-floating debris. So the Indian Ocean rim, we're surrounded by 34 countries, and that constitutes with a population density of on average 100 people per squared kilometre. Now, putting this into the context of our two nations here, Australia is the least densely populated country. We have about 3 people per square kilometre on average, and India being the largest or the most dense of the Indian Ocean rim countries at approximately 400 people per square kilometre on average. Of course, that's scaled up across your nation. So this ALDRF gear is mainly generated by fisheries. So this can be produced in very large quantities, producing large particulate matter of plastic debris. And this includes these monofilamentous lines and nets that are predominantly made of synthetic, non-biodegradable materials. So since about the year 2000, so we're talking on the order of 25 years ago, around 13% of the global marine captures of marine fishes have come from the Indian Ocean bioregion. So that's a really large percentage of the global amount of fisheries activity in this region. So it is therefore most likely that this marine debris is getting produced by this abandoned, lost, discarded fishing gear. So it's one of the main proxies that we can look for if we're trying to track these through space and time, through spatial and temporal time frames. So estimates of plastic waste entering the ocean from fisheries vessels or ghost nets can actually originate from a variety of different source areas. So what are these sources? So we know there's several different ocean-based sources of this type of marine debris. We have our commercial shipping traffic. That might actually constitute a very minor component when we take this into the scalable effect that commercial and artisanal fisheries have in this region of the Indian Ocean. So commercial being anything that registers a large these are registered fisheries vessels, where we have our more localized artisanal vessels, your local fishermen that are actually utilizing their own gear and their own vessels to fish more locally around the coast and offshore coastal regions. We then also have a very minor component that's generated by offshore platforms as well. We know that there's a lot of oil and gas exploration. We have a really large footprint also in the eastern Indian Ocean, and that also might be generating a lot of this marine debris. So let's circle this around to what the extrinsic threats are to biodiversity. So we live in one of the most biodiverse regions on the planet. We are so lucky to have a myriad of very important coastal and pelagic habitats. So our seagrass meadows, the Indian Ocean, the extent of coverage is still undetermined for seagrass. If we look at this in terms of the figures, about 500,000 approximately square kilometres or 0.02% of the Indian Ocean basin is seagrass meadow. If we scale this up to our mangroves or one of our most important blue carbon systems, here's a beautiful picture from the northern part of India. We actually also have an undetermined coverage of this habitat type. Approximately around about 4,991 square kilometres of mangroves, constituting around about 0.15% of the geographic area of the Indian Ocean. Now, coral reefs, this is a very large and very highly resolved group in terms of benthic habitats, constituting around about 28,000 square kilometres of our Indian Ocean basin. And India itself has a staggering 2,379 square kilometres of coral reef. The Andaman and Nicobar Islands, the Gulf of Mannar, and the Lakshadweep archipelago as well. You're very lucky to have some really beautiful coral reef systems and neighbours also. So neighbouring countries such as the Maldives archipelago and Chagos also are your second most extensive reef systems. But it's not only the benthic fauna that's at threat here, it's actually also your pelagic megafauna. And we had an amazing talk earlier about the importance on marine sea turtles, sharks and rays. We cannot forget about the actual organisms, the mobile organisms that utilize these habitats also. So entanglement and caught fauna in this discarded fishing or ghost gear are initially capturing these much more fragile migratory species, your sea turtles, your marine mammals, your sharks, and larger predators in the first few months of post-discard. And then later on, that actual material then starts to attract your much more cryptic organisms, your crustaceans and other free-floating pelagic organisms that constitute smaller parts of the food web. So it's actually having a really scaled-up effect in terms of the inputs on biodiversity. So this is a really important asset that we all share, including in Australia, about why it's important and pivotal that we actually monitor these effects going forward. So I'm going to give a really detailed case study locally for all of you. And we've heard about the Gulf of Mannar. We discussed about it a bit at yesterday's panel session. It's one of your most highly diverse coral reef systems, which has been under threat since around about 2016, being battered by consecutive coral bleaching events, which is an extrinsic climate-driven stress on these reef systems. So the Gulf of Mannar, it constitutes roughly about 560 square kilometres between Sri Lanka and India, as you can see in the map below. And it was designated a marine park in 1986 to protect the ecological assets of those coral reefs. Now, the preliminary surveys of the Gulf of Mannar reef systems actually found that about 110 square kilometres of this marine park was coral reef. However, extensive disturbance event from coral bleaching and destructive fishing efforts has dwindled this down to approximately about 80 square kilometres. So you're losing a large proportion of that really important coral reef asset, which actually provides really important protection zones or nurseries for many of your critically important commercial fish species as well. So it was actually, ghost nets have already affected up to 12% of branching corals in the Gulf of Mannar, and damaged around 7.2 hectares of the site since destructive fishing practices have started in the region. But since 2018, an actual dedicated group of scientists have actually been involved in what's known as ghost net busting to try and retrieve any residual ghost nets which are entrained on these reefs. So providing a really positive incentive to fishermen to say, if we discard these nets, if we remove them, this is going to help to protect your actual commercially important fisheries. So it's going to benefit the community if you provide a suitable habitat that can be important in nourishing fisheries through the long term. So just some really stark images. I found these recently, and it was really important that we actually just show these images. So let's bring back to the overall aims and rationale of this study. So what we wanted to do is we wanted to map, and as Eric said in his presentation, using some real-world data sets, can we actually map hotspots of high-intensity fishing activity or commercial traffic in the northern Indian Ocean to act as a proxy of where marine source debris might actually come from, such as ghost nets. From this, our oceanographic team will take the geospatial data and then we'll upscale this to model debris accumulation patterns using the biophysical models that Eric has mentioned, those exceptionally detailed models, to understand the sources of these marine debris and their potential movement patterns to these sink sites or our habitats using that complex network analyses that we mentioned earlier. Now, all of this needs to be then overlaid to understand the accumulation through space and time to assess vulnerable marine habitats and associated marine biota, which can then feed into appropriate management and policy strategies across the Indian Ocean bioregion. So we've done some preliminary analysis into how we go about understanding where to map these hotspots across the Indian Ocean. So the first port of call was to try and find a really important and freely accessible data source which has a wealth of information that we can extract. Now, I highly encourage you to visit the Global Fishing Watch Index. It actually shows in real time across a multi-decadal time frame the actual presence of different fisheries vessels and their activity, whether it's artisanal or commercial, across the Indian Ocean and beyond. It's free and open source data, and it actually tracks the fishing or commercial vessels based on their apparent fishing effort data sets, which is actually registered through their unique GPS pinged locations. Now, it actually presents the data in a binned format, so it bins the actual fishing effort data into measurable grid cells of about 0.01 to 0.1 degrees. And then this is then further enhanced by actually giving a quantifiable vessel time in a particular area. So vessel time is measured in hours, accompanied by the vessel information to the 100th degree resolution yearly and about the 10th degree for the monthly resolution. And the key parameters that it actually gives you is it tells you what are the commercial vessel fisheries activity types. Are they gillnet fisheries? Are they purse net? Or are they long line fisheries? And that can tell us about the types of materials that might be entering a site from a particular location. It also gives the flag of the vessel, what's the country of origin, and also the dimensions of the vessel, so it can be scaled up. So, fishing hours, we want to use this as a relative proxy for understanding the residency of fisheries activity at a site and then the likelihood that that fisheries activity is contributing to ghost net pollution. So this is our target region. It's divided into a 2-degree grid cell or fishnet, and you see it targets the main areas of interest. We're targeting these tropical, very productive rich regions of the Indian Ocean rim. Now, we also included some of our offshore partners because they also are very important here in understanding fisheries activity. So we've got, of course, your local island, the Lakshadweep Islands, stunning atolls and coral cays. And then as we move south, we have the Maldivian archipelago, the Chagos archipelago. And then towards Australia, we have the Cocos Islands and Christmas Islands, as well as all of those coastal Southeast Asian nations, which also have really important and highly rich fisheries activity and data. So what we did was I extracted around about 10 years of data spanning 2014 or 2015 to December 2024 at a monthly resolution, and I wanted to capture the scale of fisheries activity across a 10-year time frame. I then wanted to see how this varied across the seasonal cycles of the Indian Ocean, particularly targeting the Northern Indian Ocean monsoonal variation, or those monsoonal reversals that we have heard so much about in the first day of the workshop. And then conduct some preliminary hotspot analysis. How can we go about understanding where we have highly intense...
Sorry to interrupt, but may you wrap up quickly in 2 minutes?
I won't be able to in 2 minutes, but I'll try. And then highly intense fishing zones. Okay, so the monsoonal reversals, we know very clearly that we have a really strong southwesterly monsoon that predominates and causing these really strong atmospheric and oceanographic forcing from the southwest. And of course, in the northeast, it's quite much more weaker, lower atmospheric and oceanographic forcing, and northeasterly winds predominate. So we want to see how that actually varies. So what do we find? So if we look at the pre-monsoonal seasons, we see that in April to May, a lot of the fishing activity actually occurs offshore in the Arabian Sea, just west of India, and is contracted around Malaysia, Singapore, and Indonesia, and coastal India. And most of that coastal India hotspot is driven by your trawling activities. As we enter the southwest monsoon, which is your heavy monsoon season, most of that offshore fishing activity actually then contracts mostly to the Indian subcontinent. So you see all the fishing vessels move inland and concentrate towards the coast. Now, as we shift into our next season, the post-monsoon, which is a bit more weaker, once again, you can see how that fishing activity then expands back out into the Arabian Sea, and then also contracts around Chagos at the bottom of the map. Once again, as we re-enter a highly atmospheric forced monsoonal season, the northeast monsoon, you then see that contraction of fishing activity occurring close to the shore again. So you have these reverse cycles of fishing activity from offshore to inshore regions. Okay, so this is actually found to correspond remarkably with the average yearly catch in tonnes between that exact decade. So you can see in those darker red or maroon patches, that was where we were finding all that highly intense fishing activity aggregate. So south of India, near Sri Lanka and the Gulf of Mannar, just west of Singapore and Malaysia, and of course up in the Arabian Sea. So it's actually a mirror image of what we're seeing. So it's validating this as a particular hotspot. Now this is based on your key commercial fisheries, so your pelagic sharks, your billfish, and your open ocean or neritic tunas and seerfish. So you see this really strong correspondence. What you don't see, however, is that you actually have an unaccounted for fisheries activity in the western part of India, which is driven by the trawling, so prawn fisheries in particular, which is not captured in that Global Fishing Watch data set that I showed earlier. And of course, these are some examples of those fisheries activity. And lastly, I'm sorry to take up any more time, but I'll try and wrap this up really quickly. How we plan to then model this is by using a really high-resolution, spatially explicit model. So running some pilot simulations, we've actually used a model ocean current from hydrodynamic model CMEMS, available from 1994, with daily 3D regional surface current velocities at 0.083 degree horizontal resolution, or eddy resolving. Now, debris will be simulated as buoyant particles using an ocean parcel repository to track and model to simulate virtual plastic trajectories across this part of the northern Indian Ocean. And this is one such example of an ocean particle distribution pattern. And then run, of course, really high-resolution network analysis to identify major source and sinks of those floating debris. So just some very quick simulated results, just to show what we're trying to do here. So particles will be released regularly from a 2-degree resolution daily across the northern Indian Ocean seascape. And you can just see by just running it across a southwest monsoon, just how those particles actually distribute over the duration of that simulation. It actually is a video as well, so I can't really control it from my end, I don't think. And lastly, we need to understand how we can map coastal habitats to use this as an understanding of where these sink environments I mentioned earlier are. Okay, so where are these sinks that we want to model those plastic trajectories are through the oceanographic modeling? So we want to collate spatially explicit data and derive new maps of marine habitats and critically important megafauna. So we know that we actually have a large repository of available benthic habitat maps, and we are seeking, if anyone here wants to contribute to understanding where to source some really high resolution maps around India and Southeast Asia in particular. But here are some examples. We have some really high resolution coral reef mapping and mangroves from the Andaman Islands and the Maldives, which shows some sort of already preliminary data sets that we can tap into to understand where we can go about identifying particular hotspots or highly important benthic habitats. What we don't have, however, is really high resolution data, or tracking data on the migratory megafauna, our sharks, our rays, our important sea turtles and their habitats that they're utilizing. So if anyone has really important suggestions about how we can advance this data set, that would be highly involved, and I'm really excited to collaborate with more people to advance this data set. So of course, holistically, what I intend to achieve here is ultimately feed all of this data to understand, firstly, the hotspots of marine-generated debris with validation from real-world data sets, the Global Fishing Watch data, feed the data into a spatially explicit model and network analysis to strengthen our understanding of the really strong source environments of this potential marine debris, and the spatial link to sink environments, the actual marine habitats and the associated megafauna or pelagic fauna that rely on them. This will then create important discussions or mechanisms to feed back into policy and conservation management to actually start to conserve these important habitats and, of course, all the important human livelihoods that rely on them going forth into the 21st century. Thank you, and sorry to take up the time, but look forward to having some more productive discussions post-presentation. Thank you.
Thank you, Dr. Josh. We will skip the questions since we are running a little late of time. So we will directly move on to the next speaker. We have a joint presentation online from Dr. Yulu and...
Okay. Online something is there.
Okay. Combined presentation from Dr. Yulu and Dr. Niome from National University of Singapore on the topic Southeast Asia Marine Plastic Database. You may kindly proceed with the presentation.
Thank you. So good day, everyone. I'm Liu Yulu. I'm a research fellow from the Center for International Law, National University of Singapore. So first of all, of course, I would like to join other speakers in thanking the organizers for this very kind invitation to the regional workshop and to share our work on building a regional database on marine plastic research. And I'm here today also representing my other colleagues who have championed this project from conception to completion. And they're Dr. Neo Mei Lin from the Tropical Marine Science Institute at the National University of Singapore, and also two other former colleagues, Dr. Yona Lyons and Ms. Lim Cheng Ling, also from the Center for International Law. And of course, as the presentation goes, you'll realize this project, this database, owes a lot to our regional experts, and the detailed acknowledgement will be displayed later in this presentation. So today in my presentation, I wish to take you through our database on marine plastic research in ASEAN plus 3 countries, which is the first attempt to set up such a database in the Southeast Asian region. So this is the outline of my presentation. First, we'll have a look at the project itself to know how do we get to the conceptualization and also the development of the database. And second, we'll have a look at the database itself. How does it work and what does it include? And then third, I will try to provide some findings from the data. So before the beginning of building this database, Yona and Mei Lin, together with other colleagues from the Center for International Law and also the Tropical Marine Science Institute, they worked on 2 reports as shown on the screen. So this 2 reports look at what is the research landscape for marine plastics in Southeast Asia. Later extended to ASEAN plus 3, so including China, South Korea, and also Japan. So regional research institutes and also intergovernmental bodies funded these 2 projects. In the writing up of these 2 reports, several key issues or gaps in marine plastic research are identified. So first of all, this region enjoys a high diversity of regional languages. But there is limited access to research, including language barriers and also the paywalls between researchers and also the publications themselves. And there's no centralized repository of relevant data in this regard. And also, so all these issues lead to policy gaps in decision making, and also as we know that science-based decision-making is quite significant. Therefore, this idea kind of began to form. And also it's also during these 2 reports, during these 2 previous projects that Yona and Mei Lin are able to create the foundation for a regional research network of academics and also of research institutes. So all this motivate us to build a regional research inventory database. Here, so this database features over 700 publications from 2015 to 2021, and the subject matters of these publications cover marine plastic pollution, relevant topics in ASEAN plus 3 countries for both science and humanity research. And this database includes non-English publications, including Chinese, Bahasa Indonesia, Korean, Thai, and also Vietnamese. And this database is a true teamwork, as it is curated by more than 30 regional experts from more than 10 research institutes across the region. So when we do the data collection, we search both in global database and also in regional database, including this one in Indonesia. And so the metadata framework includes 82 data fields. So we categorize them into different groups like research scope, research methodology, and research findings, together with the article information, of course. So let's have a look at the database. I think I have it open here. I think I need to share again. One sec. So here. So this will be how the master list look like. So the first set of data will be article information, and then research scope, then research methodology, and then research findings. Let me go back to my slides. And then a snapshot of the data. So we witnessed a rapid growth in publication during this time period, peaking in 2020. And the top research topics that have been studied are pollution monitoring and ecological impacts from plastic pollution, and also policy responses. We observed that policy responses, this topic has gained increasing focus. And also there are some gaps in the data that we can observe. For instance, there is limited, or there are few studies on seagrass and coral reefs as sample biota. This is worth mentioning because, as we know, that this region enjoys a very high level of biodiversity in seagrass and also in coral reefs. As introduced before in this panel as well, that the coral triangle is actually in Southeast Asia, share with other three states from the Pacific. And also there is limited research on social science topics, certain social science topics. For instance, cultural barriers, which might discuss barriers to accessibility of education and also outreach on marine plastic pollution and response strategies, including how to engage with local communities and ethnic minorities. And if we continue to have a look at the analysis of the data, so most sampling happened along the shoreline, in shoreline sediment, from water surface and also from biota. So the most commonly sampled biota are fish and also mollusks. Of course, it's because they are highly relevant to food security, food safety, so which can attract more research attention for research, and also the samples are more accessible. And like mentioned before, seagrass, coral reefs, and also deep sea sediments are understudied. So from the master list, we have also built this website. So on this website, you can custom made data search, and also we provided charts generated from the master list for researchers and also for policymakers to have a look. For instance, this one illustrates commonly reported macro debris items like plastic bottles, fishing gear, food packaging in regional waters, in all the sub-regional waters studied in all these publications. And another example would be research topics in water bodies. So like monitoring sources of plastics, environmental impacts, contaminants are more commonly studied in the region. And And we also try to analyze from the data, try to give some policy relevant insights. For instance, fisheries, agriculture, and also as well as coastal activities. These are major contributors to marine plastic pollution in the region. And non-English papers, they are actually able to review local knowledge or regional knowledge, and therefore they can be taken into consideration in the context of policymaking. And again, for policymaking, we identify gaps in transboundary plastic flow because this is quite important for regional collaboration or transboundary collaboration between neighboring countries. And also socio-economic impacts. This might also require more attention from researchers. Another example of our website is, so alongside with the charts based on science studies, we also have charts based on our research in humanities. So for instance, these are the most commonly studied humanities topics like policy response, sources and pathways, surveys, monitoring, and also capacity building, for instance. And more specifically, like fishery-related fishing gear, legal and regulatory analysis, economic loss and cost. So these are the charts that we generate from the master list from the humanity side of the research. So in summary, this regional research inventory database is, we try to build a regional tool for countries to gather information about marine plastics and also to facilitate evidence-based decision-making for policymakers and for researchers to identify gaps of understudied topics, and for the public, because this is collaboration between National University of Singapore and also the COPSEA, coordinating body for the Seas of East Asia, which is a regional body under United Nations Environment Program, UNEP. So this database is actually embedded into the Global Partnership on Plastic Pollution and Marine Litter Regional Node, or we also call it GPML. So this will be, like if you try to search for GPML, this can also direct you to our master list and also to the database. So for the future development of this database, funding is a key difficulty for the continuance of this project because it requires a huge amount of human resources in the updating of the database. But we hope this current version can still exist the region in the context of identifying priorities of action, understudy topics, and also to continue the conversation among the researchers in the region. So my presentation today is just a snapshot of what we have done in multiple projects. And in this open source publication led by my colleagues Chenling, Yona, and Meilin, more detailed information and analysis are available. So for instance, the methodology of the database, the more analysis of the data and how can it inform policymaking are also discussed in this paper. So you're welcome to scan the QR code for the information page and to download this article to know more about our work. And this is the end of my presentation, and I thank all the colleagues involved in this work and whose information you can find on this page. Thank you very much.
Any questions from the audience?
Thank you for your presentation, Dr. Liu. Really interesting. I was just wondering if you could give us some examples on the type of criteria that you have used to include the papers in the database. And because it's such a wide database, maybe if you could just focus on the environmental type of studies. So, studies looking at abundance, presence, abundance, distribution of plastics.
So the criteria at the beginning was quite broad. So we only have, it has to be region related. It has to be in Southeast Asia, but later extended to China, South Korea, and Japan. And it has to be under the very broad theme of marine plastic. So, yeah. So if you have a look in the here. So for instance, they're sampling the publications about sampling, also publications for different biota. So I would say it's quite a wide catch. Thank you. And we also have a methodology page here for a more detailed introduction of the information plus the selection.
Awesome, thank you.
I think I do have a previous slide here. Sorry. Yeah. So concerns plastic debris in the marine environment and refers to at least one of ASEAN plus 3 countries. And we try to cast a net to catch other languages. And also we prefer, we pay more attention to peer review articles. But we also review some reports from international organizations like World Bank reports. Yeah. Thank you. Thank you for your question.
Great, thank you.
Hello. Yeah, I think Dinaka, you can comment, because recently we had made the same attempt to make a database for we try to make for South Asian seas, means South Asian countries, that is India, Pakistan, Bangladesh, and Sri Lanka. So we have preliminary work we have done. So I think we can follow the same methodology, and we can also make for this region also we can make, so later we can integrate. Yeah.
Of course.
Yeah. And another point, as you said, that it is requires, we can after once you make the database, we can we make it automatic? That means automatically can we get from the data, publication data, and put it in the system? Something like in the present context of AI, we can make it. I think it is not that much. You said that the limitations are government funding, government. Means it is very important. So many manpower is required, but I don't think you can later on. We can you can put it automatic way. You can auto populated. Yeah, exactly. So. Yeah,
thank you for your comment. And we're also happy to see the development in South Asia. But when we were building the database, we did read through every publication. So that was why human resource is such a big concern for us for the update. And that was also why the database is only updated until 2021. Yeah. Thank you.
Thank you, Dr. Yulu, for those valuable regional insights on marine plastic databases. Now we will move on to another presentation by Dr. Vinu Valsala from IITM on the topic Indian Ocean Dynamics under Climate Change. Over to you, sir.
Okay, thank you. Very good evening to all of you. So I'm going to, okay, so the slides are being loaded.
Dr. Vinu,
yep.
You need to give yourself at least introduction. I think you should have given some introduction.
No, it's okay. I'll just say. So I am scientist from IITM Pune. So we do
research on weather and climate. So we are part of Ministry of Earth Science. Our NCCR is our sister organization. So we are situated in Pune, which is south of Mumbai, around 150-200 kilometers. So that's the short introduction. So I'll just introduce my talk. I'm going to talk today. I was given a task to introduce the climate change and changes in the ocean dynamics, because that is ultimately important for the community here who extensively work on marine litters, debris, dispersion, etc. So how the ocean dynamics is going to change over the next. Oh, this is not the talk. No, this is not the talk. I'm sorry. I think they copied the wrong. Please go to NCCR folder. Yes, that one. So, so I will introduce how the ocean dynamics is changing under the climate change. Okay, so it's the title of my talk. So, I'll go to the next slide. So, Indian Ocean dynamics under climate change and linkage to biogeochemical and ecosystem diversity. So, we all know that the climate is changing today because of anthropogenic carbon input to the atmosphere. So, the top one is a well-known diagram called Keeling curve, or the Mauna Loa observations of the atmospheric CO2. It is quite non-linearly building up due to the fossil fuel burning, biomass emissions and industrial emissions, cement production, etc. So, the IPCC has summarized how much warming we have already contributed to the atmosphere in terms of watts per meter square. It's carbon dioxide is the major contributor next to methane, and then ozone. And however, there is a cooling impact added by the aerosol, which is going opposite of the warming, and then ultimately we are warming the climate about 2 watts per meter square. That is as the potential warming we are doing since 1750 to 2019 today. So, what is happening to this extra carbon we are pumping into the atmosphere? These are being distributed among the various components. Say, for example, the terrestrial biosphere takes up the 30% of burden, ocean takes up another 30% burden, and that's why the ocean's climate is changing, not just at the physics alone, but on the biology, chemistry, fishery, and other marine living resources aspect as well. So that's what we need to work on, how to understand the man-induced changes in climate and its impact and feedback on such systems. So again, coming back to this carbon emissions, what is shown here on the right hand side is the what is shown on the right hand side is the warming observed in the atmosphere from 1860 to today. So the red thick line shows the observed change in the global mean surface temperature, and the red color shows the model reproduction of that, including anthropogenic and natural forcing. But if you only consider the greenhouse gases forcing, you will see the gray color, which is much more warming, but the aerosol, which is opposite, you can see the blue color, which is actually nullifying some of the effect of the anthropogenic warming. So ultimately, the impact of natural aerosols and greenhouse gases will contribute to the warming, as what we are seeing today, roughly around 1 to 1.5 Kelvin in the last 100 years. So then going to the next, if you look at the state of the climate in 2024, 2024 was the warmest year in 175 years. So there is no way of we can deny this fact. Our global climate is warming, and the past 10 years we have all been among the warmest on record, and global mean temperature is around 1.5 degree above the mean considering 1850, the pre-industrial era. So the extreme weathers and climate events and massive economic to human losses are the penalty side of this global warming happening today. So the right hand side shows the global mean surface temperature integrated. You can see they're warming in a quite alarming rate. And if you look at the ocean mean global mean ocean temperature, that is also warming. Ocean temperature warmed up to around 1 degree per the last 100 years global mean, and they are not monotonic warming. In some place warmings are much more concentrated, some other place warmings are less. So why the ocean is warming, you can see the bottom panel that ocean heat content anomaly is building up since 1860. It is considerably increased from the pre-industrial era, and because of that ocean heat content, ocean is warming, and this ocean warming is also feeding back to the biogeochemistry and ecosystem of the model, and this is the ecosystem of the system of the earth system. So now if you look at this is a nice picture I collected from one of the published articles saying how much is the delta CO2, that means the anthropogenic carbon dioxide, where are they hidden in the ocean today. So this is a vertically integrated carbon dioxide on the left hand side top. You can see they are mostly hidden in the southern mid latitude and the northern mid latitude areas, and if you take simultaneously the delta heat, that means the heat injected to the ocean by anthropogenic means, they are also having sharing a common pattern. That doesn't mean that this is the gas is warming the ocean inside. This is meaning that the inventories of the anthropogenic carbon and the heat are being built up by the same mechanism, which is what shown as an integral, zonal integral from 180 east to 180 west, delta C. If you integrate in the middle panel, you can see that's the vertical distribution how the anthropogenic carbon is today distributed. And on the right hand side, you see that vertical distribution of anthropogenic heating today got introduced into the global ocean. So they share a common pattern, and the reason is being that it has summarized in Gruber's paper in Science that there is a subduction zones where this anthropogenic information goes into the ocean, say it be heating or be anthropogenic carbon. They go in various oceans, say Pacific, Indian and Atlantic are shown as 3 curtains here. You can see that they nicely go along to the interior of the ocean through the mid latitude to the higher latitude where the subduction processes are active. So this is a nice way of looking at how the ocean is helping or mitigating the ongoing climate change at least to 30% as much as it can. So going to the next, to the Indian Ocean context. So this is the warming published by National Climate Change Report published from Ministry. You can see that Indian Ocean warming is warming quite alarmingly. If you look at the ERSST observed data, the warming is localized more on the central equatorial Indian Ocean. And model simulations are quite reproducing well, which is on the right hand top panel. And the bottom panel shows the trend, so which is warming in 1951 to 2011 from various observations and models. So the Indian Ocean is also warming quite considerably around 0.5 degree to 1 degree per 100 years. So now what is the consequence of the ocean warming? The ocean warming will contribute to the sea level rise. Why? Because the warm water is expanded water. Expanded water will contribute to the sea level rise. So you can see that the global mean sea level from the observed satellite records 96 to 2024, there is a linear increase of sea level in millimeter from 0 to 120 today. So that is quite alarming, and the right hand side shows the spatial pattern of trend of sea level rise from 1993 to 2022. You can see again that it's not monotonic. At some places sea level is extremely rising, some other places sea level is not rising. So this has severe impacts in the marine ecosystems and marine diversity definitely. If you look at the Indian Ocean part, the box 1, 2 and 3, you can see that the sea level increase is quite alarming, and next to the Western Pacific. So mean sea level rise in the global ocean is around 1.7 millimeter per year, while the Arabian Sea is around 3.8 millimeter per year, and Bay of Bengal is 4.1 millimeter per year, much larger than the global mean sea level rise. Now coming to the sea level rise projection by the IPCC by 2100, you can see for the realistic scenario of SSP 1.1 to 1.9, a median sea level change would be around 0.8 meter in the next 100 years, and if you go to SSP 2.2 to 4.5 scenario, that will go up to 1 to 1.5 meter global mean, and the extreme scenario SSP 8.5, you may expect a sea level rise of 2 meters or above in the global mean, which is quite dangerous. So now if you look at the 2050 and 2100 median amplification factor of sea level, then there are several hotspots where the amplification is quite significant and alarming, especially along the coasts of Australia and the coasts of India and Central Indian Ocean. So now coming to the next, what happens if the sea level rise and climate change happens? We have noticed that the tropical cyclones are being intensified, and these intensified cyclones and other weather events can add extra burden to the sea level. We call it extreme sea level. So this is a research done in our institute saying that the recent cyclone, when they passed the Tutkar cyclone passed, and then they measured the extreme sea level rise in the western coast. They have identified because of this passing of this storm itself, sea level will increase for a few days, and that is will become extreme sea level rise. So what are the factors contributing to the extreme sea level rise is that the tide, mean sea level, waves and storm surge will all contribute to the extreme sea level rise. So if you look at the right panel, the bottom, the dots shows the amount of sea level rise per year, and the more red the dot means it's more alarmingly high sea level rise that we should expect. We are seeing in the Indian Ocean. This is from the historical record, observed record, and the histogram tells in the 1960 to 2021 the average bell curve has moved to the right. That means the tail end has gone to the extreme level. So there is a highly likelihood that extreme sea level may happen episodically at this coast at any time with a small perturbation from the weather systems. So now going to the next. This is the projected sea level extreme rise in the Indian Ocean. for the various coasts along the India. By 2050, you see projected sea level is around extreme sea level will be happening around 3 meter sea level, extreme sea level can happen, and that can go to 4 to 5 meters in 2100. So these are the records published from IITM in our research. So projected extreme sea level rise in the ocean, Indian Ocean, is a quite big concern, which going to affect our marine diversity obviously. Now coming to the circulation, what changes in the Indian Ocean circulation are we seeing due to climate change? So the left panel shows the most popular diagram of Indian Ocean means currents in the summer, northern summer, and the right panel shows the Indian Ocean mean currents in the northern winter. So in the shaded area shows where the currents may reverse or modify its route according to season, but the non-shaded area shows quite consistent current which seasonally doesn't change much. Why? Because North Indian Ocean having a reversing monsoon produce seasonally reversing currents. So what happens to these dynamics under climate change? That's what I'm going to give some glimpses in the next few slides. So what happens is that in one of the studies conducted for the Arabian Sea, by downscaling the large scale climate model into regional scales, they have found that the upwelling intensity is going to increase by 2100. This is quite surprising because what will happen is that by 2030 to 50, the aerosol loading is going to decline as per the projection. Once the aerosol loading is declining, the monsoon wind intensity will pick up. Accordingly, the Arabian Sea mixing and Arabian Sea upwelling is going to intensify in the next 2100 by the end of 2100. So what will happen? So the right panel on the top shows that the difference between present day and future, future minus present of the color shows the zonal transport and their difference. That means the more water is going to drift away from the Arabia coast and more upwelling will happen by end of 2100, which is shown as the vertical transport on the bottom right panel. So these are some changes that in the Western Arabian Sea may experience under the climate change, which also will have consequences in the ocean currents and further the drifting of the marine debris, etc. And the resilience of the Arabian Sea primary production is to the climate change has to be looked into more in such downscaling experiments, because the scenario may be quite different from what we see today. And another paper suggests what are the circulation change going to happen in 2100 in the Bay of Bengal. It is quite interesting. They have summarized that the two gyres of opposite rotation may be being developed by the end of 2100. What is shown here is the annual mean future minus past and summer mean future minus past. That means this type of additional circulation is going to set up. And they also say their combined effect would be to lead the local circulation that to some degree it may trap the waters that are freshened by river runoff at the top of the Bay of Bengal. Or the other way of saying that the whatever debris that we're finding transporting today may significantly change in future because of the dynamical changes due to the climate change. So such reports are also recently being published. Now next, what will happen to the much larger domain? So this is another paper we published from IITM saying that the mean monsoon at least is going to be weakened in the near future. That is because of more and more aerosol loading will continue until 2030. What will happen? Those schematic blue diagram, blue line shows that that will reduce the southward transport of water from north to south. And that means the more warm water will accumulate in the North Indian Ocean, that will contribute more to the sea level rise, which is what happening and may continue until next 30-40 years until the aerosol loading going to get reduced. So this is a very important consequence to the marine diversity if the sea level rises and heat content is keep on building up, because I come to the chemistry to appreciate that factor. Coming to the large scale circulation, this is kind of understood mean state circulation of the Indian Ocean as a schematic shown. So what is happening to the mean state circulation of the Indian Ocean? If you look at the 1960 to 1980, the south equatorial current was more straight west, but by 1980 to 2000, the south equatorial current is tilting. So this is another evidence that Indian Ocean dynamics is basically changing over the climate due to the climate change. So that is something that we need to look up, and how what are the consequences of this in the marine life to such large scale changes in the circulation we need to understand. Then coming to the next, the primary productivity. This is another paper published by Roxy et al. Suggesting that the primary productivity is declining presently in the Western Arabian Sea, and the decline is consistent with the declining of the nitrate and phosphate as per the model projections. And why phosphate and nitrate declining? Due to the warming, the stratification increasing, so the less mixing and entrainment process which which shut down, bringing the more nitrate or nutrient from the subsurface. So this is another area that marine diversity may change by the global ocean dynamics change due to the climate change. And the bottom panel, Sharma summarized a paper saying, however, there are aerosol input of nitrogen may contribute to help the marine primary production, at least until next 30 years when the aerosol is still uprising from the Indian and South Asian continent. So this is the amount of, the bottom panel shows the nitrogen flux in terms of nitrate and ammonia through aerosol to the ocean. So these are also may kind of counteract the changes in the primary production induced by climate change in the Indian Ocean. Next, coming to the another topic called oxygen limitation. We all know that this is the oxygen minima water around 200 meter. Indian Ocean and Pacific are the best known oxygen minima water. Why oxygen minima is important? Because here is the place denitrification happens where the bacterial cannot function. The aerobic system will shut down and the anaerobic system will kick in. So this will affect the nitrogen cycling unless it get fixed. And what will happen to this in the next climate change scenario? We need to look into this because marine ecosystem also depends upon the available oxygen as well as the nutrients in terms of primary and secondary production. So if you look at the nitrogen depleting rates of the Arabian Sea is getting quite alarming. That in the the nitrite concentration NO2 is being built up so much in the subsurface of the Arabian Sea, and we have studied about the and we estimated that the denitrification rate is about 25 teragram nitrogen per year as of 2009 CMLRE observation. So this is also one thing that alarmingly changing in the modern day in the marine ecosystem. So now if you look at the denitrification, what are the problems? So here shown the nitrous oxide production. This is the byproduct of denitrification. So this is Bengay's paper suggested that seasonally Indian Ocean is having a nitrous oxide production, especially in the June, July, August in the western coast there where the nitrogen is being consumed and nitrate is being consumed and nitrous oxide is being produced by irreversible nitrogen production N2. So what will happen is that nitrous oxide, as we know, is a greenhouse gas that will again further amplify the global warming, and global warming will increase stratification. Again it will decrease oxygen and it will again go to denitrification, again it will go to nitrous oxide production. So this is like a positive feedback loop is going to happen perhaps in the vicinity of the northern Indian Ocean is what expected by the current day observations. Now coming to the resilience factor of the prey-predatory relations in the North Indian Ocean, this is a schematic showing that if you have a control environment of availability of planktons in terms of phyto and zoo, if you have a control environment, if you reduce the availability of nitrate, this is what going to happen to the community of phytoplankton. At least for theoretical modeling consideration, they may tend to reduce. But if you change the availability of ammonium, that you are not allowing to regenerate the nutrients within the euphotic zone, some of the species may benefit from it, some may not. So these are called the resilience nature of the species by a prey-predation relation. So this we need to understand as well. If you shut down the silicate population, silicate availability, some of the populations are extremely growing, consuming on the lower trophic level. So these trophic level interactions and nutrient limitations in the North Indian Ocean under climate change needs to be looked up, and that is becoming a gap area as well. So the summary of that is that nitrate offers a fundamental limitation in the Arabian Sea, but multi-species dependent higher trophic organism withstand the nutrient limitation as compared to the single species lower trophic organism. So there is a competition in the community structure may happen if you stress the ocean with more anthropogenic perturbations. Coming to the fishery, that's perhaps my last topic. Fishery also changing in the Indian coast. So for example, the pelagic fisheries is one of the major economic source for the coastal livelihood. Then you can look at that, see that Indian oil sardine is a small pelagic fish, and this is the single largest contributor to the total marine fish production from India. So we can see that this is also experiencing a climate change. If you look at the variability of the fish data in the last 50 years, there are systematic oscillations in the abundance and non-abundance. Then you can see that either in the decadal scale or interannual scale, the such variabilities are reported. So climate impacts on the landing of small pelagic fishes over the Indian coast is a long addressed topic, yet an area where more understanding is required. Now going further, we have come up with some idea how climate change and ocean dynamical change is going to affect the pelagic fishery. This is a summary of that. What we observed is that during surplus sardine catch, this is what happening in the west coast of India. There are more wind which is favorable for stronger upwelling and shallow mixed layer and less saline water. But during the year when there is a sardine catch is weaker, we are finding wind which is favorable for downwelling, deep mixing and hard saline water. So these dynamical changes in the ocean due to the changes in the atmospheric circulation due to climate change can have impact in the marine diversity of the Indian coast. So this is also something that we need to understand. Now if you look at the other species such as anchovy, which is much smaller fish compared to sardine, they have an inverse fishery with sardines, and it is quite interesting because they are all controlled by the environmental parameter. There is no prey-predatory relation among them because sardines eat more on diatom, feed on more on diatom, so it is a herbivorous, so they don't have any prey-predatory stress across each other, but still they have an inverse fishery, and it is mostly controlled by the climate and environment such as temperature, salinity, availability of food, etc. And this relation is quite explored in our research. I am not going to the details due to the lack of time, but what we found is that in the abundant sardine period or abundant anchovy period, the atmospheric circulation surrounding the Indian continent is totally different. That means there is a climate impact on these small pelagic fishes, and that is going to change under the climate change in the future. We can see that so many upwelling index changing and abundance changing, winds are changing for each of these species when they are abundant in the landing data. Now going to the next, if you look at the multi-species, that is mean this, we have studied what climate index or imprints are there in the landing of the multi-species fishery. Before we examined around 40 years of data. Data is scarce, much scarce in India to get all this data, but we figured it out from the CMFRA reports, etc. Then what we found is that all of them have some decadal cycle, whether it is a small pelagic fishes or large pelagic fishes or demersal fishes. Their landing has some systematic oscillations, and that oscillations go well along with the climate. If you regress those oscillations with climate, surprisingly you will notice small pelagics go along with the Pacific decadal type of oscillations, and large pelagic goes more with El Nino type of oscillation. It quite puzzling to answer why each size class fishery go to the different climate sensitivity. And demersal fishery, there is a mixed response, there is no clear response, but these climates are therefore controlling the biomass and landing of this fishery, which on a modeling perspective is a good thing because we can use them as predictors. Now we have seen that the ocean warming, these are the consequences. The physiological activities of the fish may change after growth, and it alter the recruitment and reproductive maturity and spawning situations. Warming may also change the migration pattern and also change the growth of and survival of the larvae to the juvenile. So these are the consequences going to happen due to the ocean warming in the marine diversity of the Indian Ocean. So now coming to the next topic. So we have recently adopted the Nemro fish population model to study the climate sensitivity of small pelagic fisheries. Then this is a system we are using which starts with a Nemro model and then coupled it to bioenergy statistical model to growth of fisheries, and then coupled it to the population of the fishery. What this model gives you is the total biomass over the years. So when we study the sensitivity with this model, we saw that the model is faithful in reproducing the weight of the small pelagics. This is the growth rate of a single sardine fish from June of first month to the end of second year, 2-year life cycle, and they have some confirmation with the observation, and even their sizes are increasing from southern coast to the northern coast. Now in the east coast we simulated same, and they are also giving some interesting growth rate of the fish weight from the model, and they are quite agreeing with the observation. So what is important is that when we translate this into total biomass, this is the abundance of total biomass sardine fishes from the west coast. You can see the most abundant is in around January to February, which agrees with the observation. So the model is capable of reproducing such data. So that means the model is learning from various relation between the bioenergy and the behavior of the fish and reproducing data. And then if you have a model which can reproduce the growth rate of total biomass, we can study the climate change impact on such fisheries as well. So what we have looked at is we tried to use the model. You see, we use the model to reproduce the total biomass of fish from 1965 to 2019, and the model successfully reproduced the total landing biomass. You can see the blue line is observation, and the black and the shaded areas are the various model ensembles. So the model without any preconditionary conditions or a priori conditions is able to capture the climate handles on the biomass growth and then reproduce it in the model and give us the simulation output. So this is quite encouraging. So using such tool we can project what in the next 100 years what will happen to the Indian Ocean fishery, especially in the small pelagic. So that is one thing we need to look at. And such efforts can also use to study the sustainability of fishery by tuning, by changing the mortality, whether it is natural or fishing mortality. We have seen that the fishery is sustainable up to plus or minus 10% change in the mortality deviation, but if you change the mortality by 40% overfish, then it is there's a detrimental effect you will see in the sardine fishery of the Indian coast. And then comes to the last topic is the ocean acidification, which is another threat by climate change affecting the marine fisheries and other aspects. So this is the summary of Indian Ocean climate acidification today. So the analysis shows that the Arabian Sea and Bay of Bengal and Central Indian Ocean are acidified by quite a big amount, considerably alarming amount, and most of this acidification is happening by the red bar, which is due to the dissolved carbon from the atmosphere. So this is also need to look at, and what happens if acidifies, the calcifying organism will decay and they will sink, and this is one aspect. Another aspect is in the fishery. Fishery will also get affected because fishes are sensitive to the local ambient pH values, especially in stages of developmental process, metabolic activities, behavioral process, etc. So these are also changing in the Indian Ocean due to the climate change. This we need to consider. So these are the net effect of ocean acidification. Olfactory cues, there is the smell related signature may change in a larval settlement stages, and auditory response about the sound, because sound propagation is affected by the free H+ ion in the water, and it may affect the it may lead to acidosis condition, increase in the carbonic acid in the fluid bodies, and also it affect the sound propagation. So predation may get influenced by creating a noisier environment in a high acidified water. So the predation may get affect, food may get affect. So a lot of consequences are there by the ocean acidification. So this is my last slide. So that are the potential challenges and open questions. So what actually we can see that there is still many gaps in the current understanding of Indian Ocean dynamics, and biogeochemical cycles and fishery under climate change especially, and there are still large uncertainties in the air-sea fluxes of various physical and chemical species, and Indian Ocean dynamics and their fine-scale changes may have implications in the marine dispersals of larvae, debris, etc. in future, and changes in the ocean dynamics across scale, some mesoscale to interannual, has implication in debris dispersal. So this we need to understand it. And migratory pattern of marine life under climate change is a gap area. We have no clear idea how small pelagic migrate from east coast to west coast. So these are the potential challenges and open questions, but we, with a consistent effort between observations and modeling group, we can develop theories and predictions to develop policies for mitigation, etc. So that's what our whole effort is about. And I am thankful to the organizers to place this talk at this community. Hopefully, I hope it was useful. Thank you.
We will take 2 questions.
Thank you, Vinay sir. It is an excellent presentation. So I have a small doubt regarding that. You correct me. So as we are hypothesizing, even practically, even well proved by these either Roxy 1952 2015 data, as you mentioned, and Swapna 2017 other so all. So one of the slide, as you have been mentioned, the CO2 as well as the heat, particularly heat flux, where it is trapping more heat in this northern Indian Ocean, particularly in the Arabian Sea side, rather than Bay of Bengal. So what I am thinking is that, you correct me, then recently this intensification of the cyclones are changing, the monsoonal also changing. Earlier we may thought that most of the things cyclones in this Bay of Bengal, but now it is the shifting is changing to this Arabian Sea. That may be the any consequences in future. It may be reduce the heat flux, because the most frequent physical processes can happen, and more amount of even hundreds, at least top 100 meter of the water column, it may be mixed up properly because of these cyclonic events. So what your view?
I don't think that will add up any much into the system, because they are short-lived synoptic scales of 7 to 10 day duration, and
Okay.
even just disappear immediately after that. So on the long-term climate change, such impact, such a mechanism may not be much important, I guess.
Yeah, second my point is that, as you mentioned, that intensification of these upwelling zones, as is Somali or these Oman currents as well, the
Yeah.
deep ocean upwelling is taking place toward the coastal regions, which
Correct.
brings the huge, colder waters. Even it is spreaded
That is
may
right,
be-
but that is more after 2050. You are right. After 2050, more upwelling can happen, because by 2030 we are going to reduce the global aerosol loading, 2030, 2050, for example. Then the greenhouse we emitted is already there, and that is going to strengthen the monsoon wind.
Okay.
Which will increase the upwelling and cool the ocean, but to some extent, not guaranteeingly at the extent that we warmed already. Some warming may offset by such things.
Okay.
Yeah, some warming. I don't quantify it.
Yeah. Thank you, sir.
Yeah.
Yeah.
I have a small question.
Yes, sir.
The thing is, this is microplastic.
Uh-huh.
So there are some publications that it is going to also impact the climate change, in the sense that if the number of microplastic is increasing, then the in the water column, so photosynthetic effect will decrease, and ultimately it has also climate change effect also. So what do you think, whether any prediction still now, people
no.
including
No.
microplastic scenario?
That's a very good question, and that is doable also. For example, when you do a downscaling experiment for future climate, in the model we can give some light parameterization with some shading effect, and see what can be the consequence of these plastics, microplastics in the rest of the things. We can do that, and it is a very good point.
Yeah,
I don't think anybody has done, at least in the Indian
there
context.
is one or two paper that has come
Oh.
regarding the effect of microplastic in the climate change.
I see.
Okay. So maybe I think IITM can.
Yeah,
take
well,
up
we can do.
maybe
It's
your
actually
group.
easily doable, because just need to tweak the light parameterization, because that's what eventually going to happen by suspending microplastics. I understand. It cut the light, right?
Yeah.
Yes, it can be done. So we
Cut the
never
light,
did
yes,
that, but
exactly. That also.
that's a good point. Yeah.
Thank you so much, Dr. Venu, for bringing us your valuable perspective on Indian ocean dynamics and climate change. Now, I want to request Dr. Prabhakar Mishra to felicitate Dr. Corey and Dr. Venu as a token of appreciation for sharing your insights and expertise with us. Okay, now we will have a short tea break. Tea will be served at Mandan Hall, and please reassemble here by 2:15 p.m. 4:15. Sorry. 4:15. Yes. evening, everyone. Welcome back to the final session of today. First, we'll have a presentation from Sri Siddharth Hante from Kabadiwala Connect. He is a founder of Kabadiwala Connect and also a special data analyst and social entrepreneur who is passionate about urban planning and the circular economy. I welcome you, sir. You may start your presentation.
Check. Okay. Hi, everyone. Thank you. It's a pleasure to be here. I'm not a doctor. I don't have a PhD, so I have a master's from Monash, actually. So it's great to see you folks here. Welcome to Chennai. I'm a data scientist by training. My name is Siddharth Hande. I have a master's in environment and sustainability. Did a lot of work with GIS and remote sensing. But I run a company. It's a for-profit social enterprise called Kabadiwala Connect, where we look at the issue of waste collection and the potential of the informal recycling supply chain in integrating them into the formal system to reduce waste sent to the landfill, to waterways, things like that. I think I want to start off by just saying I feel that the relevance of the work we do to this workshop is talking about the issue of waste collection and how it's quite critical in the global south, but somewhat under-emphasized pillar, I think, in marine litter policy. And so I just want to highlight that big issue that we have. Especially in India, as our cities and towns on the coast get wealthier, there's going to be a lot more waste being generated. Chennai right now creates 6,000 tons of municipal solid waste every day. The formal sector collects that and sends that to the landfill. We passed one. They're not really landfills. They are kind of dump sites. Paleoclimatology is a marshland where we have been dumping our waste. Kudungyur similarly. So these are very eco-sensitive zones. And broadly, you can say, I think, that the waste collection system in the global south is in crisis. And because of that, there's a lot of material being, leaking into the rivers and finding it into the ocean. So I want to speak to that. If I can. Yeah. Serious problem with urban waste collection systems across Southeast Asia, Africa, Latin America. Most of the waste that gets collected by the formal sector is landfilled. This is a landfill with a code and the codes around it. They are quite poorly managed. And just a couple of things here, why waste collection is so complex. There's a World Bank study which says that for effective waste management or waste collection in the global south, a municipality would have to spend anywhere between 20 to 50% of its budget. And again, I think that just shows how critical this issue is. So we have a lot of waste being generated from small and medium waste generators, households, small shops, and all of this presents a humongous challenge to actually collect it efficiently and find it in the right way. We have these old paper ton models where basically waste collection companies go and dump, they get paid for every ton they send to the landfill. Plastic is a very lightweight substance, so it gets dumped on the way, in fact, of picking heavier materials. So it's really a big issue that we have. There's a study that says 8 million tons of plastic ends up into the ocean from land-based sources. I could be wrong with that number, but this is an Ocean Conservancy data point that we used to tell the story about waste collection. It's also something that we can manage if we get it to the right spot. A lot of our waste, 50 to 60% of our waste is organic waste that can be composted. 15-25% is dry waste that can be recycled. So Ocean Conservancy says that, again, when you look at the global south, most of the waste collection systems are in crisis, and so plastic being a fraction of the overall mismanaged municipal waste is a big problem. So I think an important point here is looking at plastic waste being generated on the land as part of a larger waste collection issue that we have to solve. Because there's so much valuable stuff that's being collected and sent to the landfill, since the 50s and 60s, you've had this rise of the quote-unquote informal recycling supply chain because there's a lot of value in this material that gets dumped. We know stakeholders in the informal sector. I think we all can agree we know the waste picker really well. We can all identify and we can visualize a waste picker. We know that they are really a key actor in the frontline collection of waste. But Kabadiwala Connect, we've also been showing a couple of other key stakeholders from mapping these informal supply chains, which I'd like to talk about. Another point of departure, so my first being waste collection systems are in crisis. in the global south. The second one is that the informal, we need to understand informality. It's not this kind of niche topic, but it really encompasses most supply chains in the global south. The recycling supply chain being one of them. There's millions of tons of PET being collected right now through these kind of supply chains, powering global systems. Like, you know, every time Adidas says that this shirt was made out of recycled waste, you can bet your dollar that there was a waste picker involved, that there was a small scrap shop involved. So I think for us, the topic of informality is of utmost interest. It's not just waste pickers, but it also encompasses businesses and really some really interesting actors that I'd like to talk about today. So Kabadiwala Connect, we're a social enterprise. Our goal is to positively affect waste collection by integrating the informal recycling supply chain holistically into the formal system. Our work started off in Chennai, where we were doing these beach cleanups. So I studied zoology here, and we were doing these cleanups where we realized that we were collecting all that waste, putting it to the municipal bin, and it was being sent to Paleoclimatology. And for us, we started using that as a point of departure of questioning the waste. And it's there that I saw waste pickers come in and very industrially pick up certain kinds of materials. And I got really fascinated into where does it go? What does it mean for overall recycling? What's the collection rates that we have through the means of waste pickers in the city and the overall informal sector? So I was always really interested in mapping the informal recycling supply chain all the way up to the processor. So figuring out what waste pickers were collecting, what the scrap shops were doing, and so on and so forth. Some data from secondary research before we started our mapping activity was that we know, all of us know, that there's a lot of waste pickers in India and indeed the global south. There are studies which show that this sector collects something like 20% of the recyclable materials our cities generate. That's a big number. That's millions of dollars worth of feedstock, actually. There's also studies that show that for every ton the informal sector collects, the municipality is actually saving money. So very, very interesting how for every ton, like again, when you think about the cost of waste collection being so high, the role of the informal sector here to offer a solution. And of course, multiple issues with health and safety. Waste pickers make very little money for the work that they do. One thing that we personally identified and we have been publishing about was that when we took the 30 most cited papers on the informal sector in India, and what we essentially created was wherever there was a mention of the stakeholder, waste picker, collector, we started mapping that. And what we came up with was, when you look at the count, when people talk about informality, they mainly talk about waste pickers. These aggregators get missed out. And when they talk about aggregators, there's also this kind of weird state of ambiguity with these aggregators. Who are they? Are they middlemen? Are they collectors? Middlemen has a very negative connotation, for example. It means they're not adding value in the supply chain, and they're trying to, like, you know, they're predatory, and there's a lot of misunderstanding about the aggregators. So my goal was to really start mapping these aggregators in Chennai and understanding what is their relationship with waste pickers, what's their relationship with these big recyclers, what's their capacity, and how much more can they contribute. We were lucky in 2017, we won a couple of grants. One from the big one was from the Global Partnership for Sustainable Development Data that was financed by the World Bank, where we essentially walked every street and kind of did the first ever census of these aggregators in Chennai. So deploying a bunch of field operatives, we walked across every street, across every ward, every zone in Chennai, and we were really focused on what materials were being collected, what was the pricing, what kind of valorization was happening to these materials, what was the relationships between these different stakeholders. And what we found, this supply chain was, apart from waste pickers, there were two other critical stakeholders. You know, one way to, we try to classify them as three levels of key aggregation points that happens across the collection supply chain. You have waste pickers picking up materials, scavenging for materials they sell, to then a small scrap shop. We call them level 1 aggregators. Small scrap shop, by the way, they're called Kailan Kades in Tamil. In Hindi, they're called Kabadiwalas. They're called lapaks in Indonesia. They're called corner recycling stores in Hong Kong. They actually have a local purchase in the vernacular, and they form a key circular economy function that's quite invisible right now. These small scrap shops were critical because they were not just buying material from waste pickers, they were also buying material from the local community, and they would then pass that on to these informal material recovery facilities who would do some critical pre-processing like baling or shredding before it was sent to a formal or informal processor. When we started mapping, PET was already part of a formal supply chain, but now more and more HDPE, a lot of the rigid plastics are becoming more formalized. There's still this big question of low value plastics, where theoretically it's possible to do a lot of collection. The technology is there, pyrolysis or whatever, but it's really the cost of financing that collection that everybody's discussing. And yeah, so our mapping, I think for us, this was when I felt that there was really something more in what we were doing. So on the left is a map of every shop, small scrap shop we found in Chennai. And I could be showing you a map of vegetable shops in the city or ATMs in the city. It's just amazing to see how many small scrap shops are available as infrastructure for collection in Chennai. The level 2s, if you notice, and again, maybe a heat map is better, but they're more clustered. There's a plastic cluster, there's a paper cluster, there's a metal cluster. And from these level 2s, they send it like long distances. So typically, level 1s, they're much smaller, about 100 square foot shops. Again, if you were driving around Chennai, if you're really keen, you could spot these shops. Whereas the MRFs are more like warehouses, 5,000 square foot. They need high tension lines for baling and things like that. And yeah, what we found, how much they were collecting in Chennai, overall we generate about 542,000 tons of recyclable waste every year. The informal sector collects 24% of that. Mostly paper and glass and metal, but recently a lot more plastic. PET is hyper collected because it's part of such a robust supply chain. And now we're seeing more types of materials also being a part of a globalized supply chain, like PP and HDPE and things like that. This is a visual we published with GIZ, the German International Development Institute for Chennai, where we looked at the wards across our two major rivers, Kuam and Adyar. And when you look at the scrap shops within these wards, this cluster of wards, and how much waste is theoretically generated, you're actually seeing something really fascinating. PET is super well collected. There's about 110 metric tons being generated on the Kuam River on top, and close to 100 tons being collected. At the bottom, there's actually like an excess of collection. Just shows there's 128 tons being generated, 188 being collected. So it just shows how much pull PET has into the formal recycling system, whereas there's a lot of work to be done with low-value plastics, with PP, PE, PVC, PS, and other types of grades. So the informal supply chain, I think, is really doing the heavy lifting when it comes to waste collection. And there's a lot of positive outcomes in integrating them holistically. The balers, especially with EPR solutions, and the recyclers, and the waste pickers and small scrap shops in the collection system, in the last mile or front mile, last mile collection system. And so KC has been operating in that level. We do a lot of mapping work. We do a lot of informal sector traceability stuff, procurement guarantees, where we invest in compliance and help big companies think of what compliance looks like when you work with the informal sector. A lot of our mapping work is grant funded and has implications in policy. So with the Tamil Nadu Pollution Control Board, we have a project to map the informal sector with them, helping them use that information to communicate effectively more localized solutions for waste collection. We are with Niti Aayog. I'm part of the expert committee on circular economy there. But then a lot of private sector actors are also looking at this supply chain, because there's a lot of pressure, especially in what we have seen personally with the EU. There's some really big moves happening where digitalization is being a key component of industrial development. And so it just means a lot of big companies have to figure out how to do compliant collection in the global south, and helping them with understanding the landscape, how do we maximize collection, essentially retrofit this ecosystem is something that we do. Yeah, I just want to highlight this point that even with the Global Plastics Treaty, waste collection needs to be more, it needs to be more front and center. And the role of the informal sector there needs to have a serious role. So yeah, I just wanted to put this perspective more on the land-based collection and how we need to address this if we are to have some sustainable solutions for marine plastic in the future in India and the global south. Thank you.
Questions, please.
Thanks. Love what you do. Definitely very cool story. I was wondering primarily my experience with some of those little small shops that known for collecting things is that at night when they close, people knowing that they collect and process stuff, people just come and dump stuff around there. And sometimes it's useful and sometimes it's just another rubbish dump basically. So I wonder if you have any type of experience or comments about this.
Yeah, I mean, broadly, the overarching perspective on health and safety, it's in a really bad place. Like right now, when you look at the stakeholders, it is completely unregulated. There is some tacit understanding with the informal sector. So the municipality, for example, in most cases, before they go to the landfill or the transfer station, stop at a local recycler and would sell their waste. I don't think it's too common at an ecosystem level where people use it as a dump site. It's quite a regulated space in that way, where it's clear what materials need to come in there and what materials go out. But still, health and safety, environmental compliance is a huge issue. So, you know, at the level 2 aggregator, like the MRF level, labels, if they don't have a way to sell it, they would burn it or dump it and things like that. So, yeah, there's a lot of issues to be tackled given the nature of how they work. But at the heart of it is it operates like a shop. And so people know what they need to go, they know what prices they get and things like that. So I think broadly it operates at a quite an effective level without any dumping or any of that kind of thing.
Yeah, yesterday we had a presentation in which fishermen were given incentive to collect plastic from the sea. Have you tried anything of that sort yet?
Yeah, so in fact, I was just going to say we have two projects. Like one is we're working with Kovalam, the fishing community here. It's part of a Denida funded project where there's a Gleco, which is a manufacturer in Denmark. They make PP big bags, construction bags, and so they have 2 manufacturing plants here. So we are going there to work with the informal sector to collect that plastic load and send it into the ecosystem. So I think one thing should really look at is the linkages between the local informal supply chain in fishing communities and what that means for ghost fishing here. Because if the economics and the system was set right, it could formulate part of an already existing pipeline to pull that away. Essentially, that material is recyclable. Like you can pelletize it and sell it back either as injection grade or whatever. So creating those linkages and suddenly finding a local partner in every fishing community in the Tamil Nadu coast to collect that ghost gear instead of making your own MRF is really a low-hanging fruit from that perspective.
Please.
I think for the system to be efficient, we have to include in the game all the players, in particular me and you. That means every person generating garbage should start by sorting their garbage. It's not yet in people's mind, it's coming, but it's the only way efficient. And we focus on plastic. I'm not saying it's not a problem, but you have many other pollutions already there, like electronic pollution, batteries, that are less visible than plastic, but more toxic to the environment, that are not enough handles. And the only way is to including the manufacturer. For instance, just to give you an example, in Europe, when you manufacture a car, during manufacturing, you have to say how it has to be dismantled and recycled. Not after one guy did what they want to do, make the way he wants it, and then now you sit and say, how do I have to do it? From the very beginning, and if this component is not recyclable, you have to find something else. So if you just solve half of the problem with these people collecting, you're not solving even 1% of the problem. Thank you.
Yeah, I completely reflect with that. I think what we have seen with the scrap shops in general, so there is this, again, our research, we've been doing some mapping across different geographies. I can speak from primary data collection from India, a few different cities, Sri Lanka, Hong Kong, and Indonesia. And in all cases, the scrap shop, this level 1 aggregator, the waste pickers are only collecting about 30% of the feedstock. The rest 70% is communities coming to the scrap shop to sell it like a waste bank. And so I think in that activity, there's a lot more opportunity. Like you could have local programs, you could have a smartphone app where people can find their local scrap shop and figure out what materials they sell. For stuff that they don't collect right now, low value plastic, it's about the right policy incentives to subsidize that collection. So yes, the informal sector is hyper entrepreneurial, market driven. They buy stuff that they can sell for a profit. They don't take stuff that they can't back channel, send it across. And so I think policy plays a key lever there to help collect as much and reduce the cost of all the single stream. There's some complication there where, like e-waste is a great example, where they're breaking things down. They shouldn't be doing that. We believe they should just aggregate and send it to, the breaking down of material, e-waste especially, should happen at a formal processor. But still, the incentive is not enough for the scrap shop and the community to just hand it to them and just keep it. They want to extract more material. So I think, given the way they do work, there's a huge opportunity to examine a host of materials they can collect, but all of them will have different backlinks. Some are profitable, like PET, but some have to be subsidized, like low-value plastic.
But you can also combine the scrap shop and the shop.
Absolutely.
And you have a project with Norway, I think, where the supermarket selling plastic bottles, they have a machine, you put back your bottle, you get a refund. And if you do this process, people realize that this has a value. The only problem is that in people's mind, it has no value. So if I can get something out of it in the scrap shop, okay. But if you put the supermarket and the sellers in the loop, this is the only way to make it go forward.
Agree with you, sir.
Really quick one. Amazing presentation. What about textile? Is that something that is of value or starting to be of value?
Yeah, textile is a huge problem. I was in a meeting, Niti Aayog meeting, where 10 years ago when we started Kabadiwala Connect, the amount of textile waste in municipal waste was something like 2% or 3%. Now I was informed there's 15%. And so that's fast fashion for you, coming in a very strong way. We are going to see higher volumes. Right now, there is no collection path for textiles with the informal sector. So there are no incentives being placed for the collection. What's happening mainly in textile recycling is pre-consumer recycling. So the waste that's generated from the textile mills, and we have a lot of mills in South India, that's being prioritized for recycling. But there is no collection demand being created from municipal waste with regards to textile. Massive problem.
I have one suggestion. Because we have already, NCCR is writing a policy paper, drafting a policy paper. They have drafted, these things can be, have you published or do you have any white paper? Means if you can make out of your experience, because what you have made, I think Dr. Shanita, you can later on, you can include that this experience means it can be an example, like what Professor Jakaria said, that battery. We know battery, whatever the battery you are using, torch battery, it is not recycled and it is straight go to the environment. And we are not aware of what is the bad toxic effect of it. So even I think Pollution Control Board has also forgotten that our country has forgotten such material is how much. Similarly, chemicals, what we use in our schools. Suppose in school experiments, in environment experiments, even in our laboratories, we don't recycle. Many things are there in India, even medicines. The expired medicines goes to the environment. So similar way, so because you have a good experience, I think, and you are from the right down from up to a point where you are claiming that 20% are getting recycled at least. So we can have a white paper, and that can be, I think you can collaborate and we can write and we can put it to the government, like that will be the one of the best solution. That how we can, means we can improvise it. What is the best solution? At least whatever we can do, let us try. Yeah, thank you.
Thank you, sir. No, I'm happy to. It would be a privilege to be a part of it. Again, for us, being a social enterprise, the policy input is that we need to look at waste pollution, waste collection systems, and its impact on marine litter. Again, another low-hanging fruit just here, sir, is every time you do a cleanup, if you bring the local scrap shop, because again, scrap shops are close by to any cleanup you want to do. they can take a part of that fraction away instead of just taking it and putting it into the dump sites. So again, like we've done some pilots on that where a cleanup along with a scrap shop partner, and in some cases we see something like 50 to 100 kgs being collected that the scrap shop can take, ghost nets included. And yeah, something along those lines to showcase low cost, effective waste collection solutions that can really support, like, you know, waste being dumped to the landfill or waterways. We would love to partner and see how we can.
That's what you can make a paper,
sure, sir,
at least which can be put in our website, and we can also further see it how with the ministry, other ministry, we can work it out. That will be one of the best solution, I think.
Sounds good, sir. It'd be a privilege. Thank you.
Thank you, sir. Thank you for interesting and informative presentation on the role of informal sector in waste management. Finally, I welcome Sri T.C. Sekar, who will be delivering a presentation on solutions to combating river and stream pollution. He is the founder and director of Alfama Limited, a leader in marine environmental studies and AI-driven solutions for ocean and river plastic cleanup. Please, over to you, sir.
Good evening, everyone. Thank you, NCCR, for calling me to share my views. I have been listening to the amazing talks of various people from morning, how to define the problem statement, how to analyze, how to measure, how to do what is required. So it's good, myself and Mr. Handa, we have taken up at least 1 hour. We will take up to discuss solutions, and hopefully in the next few sessions we will take up half the day. More and more solutions will come. I hope so. Myself, as a merchant navy captain for over 20 years, I've been at sea, and I've seen the waves, the currents, the storms, all of it. I intuitively understand water, how it works, and we have designed solutions. We believe technology can solve a lot of the problems that we have on hand, and we have been solving. The last 10 years, we have been standing practically like a wall between the plastic that finally ends up in the river, and if it goes like you mentioned, the sea is the plastic sink. I hope not, and we are standing in the middle to prevent exactly that. And let me tell you about the technologies that we have developed, used, and the learning we got along the way. So this is a floating barrier. What you see over here is a Google Earth image of 2016. We made a barrier of stainless steel mesh with the right hydrostatics. When I say that, I mean in simple language, with buoyancy on top and the ballast at the bottom so that it stands straight in a dynamic, hydrodynamic situation. And two things we are very particular about. One is it should meet the scale of the problem. When I say that, I mean in a small city river, 50,000 liters of water pass by every second. And most of the solutions that I see in the social media and all of that, they fail on that test of scale. They're all made for very small things. So we made a barrier with a 26 tons. This one has a tensile strength. It is anchored on both sides, and it has the bare minimum drag force. Now drag force, I think this group will know, but just in case I'll tell you, drag force is when you put your finger in flowing waters, the force that you feel on your finger is a drag force. So this has the bare minimum drag force, highest tensile strength, and that is why today, 10 years later from this, 9 years later from this, we have our installations in 40 locations, 10 cities, the longest floating barrier in the world at 192 meters, it is just 10 kilometers away in Adyar River. The second longest floating barrier in the world, 172 meters, again it is in Adyar River. And this has stopped an amazing amount of solid waste without using a drop of fuel. What this does is, it stops the surface trash, and the surface trash, because of its diagonal alignment, it simply slides to the corner from where it is picked up from the river bank. That is a key we always follow, thumb rule, that our downstream end should be accessible by road very well. So the trucks can come, tipper trucks can come, the JCB can come, simply scoop it and put it on the trucks and take it away. Now it is zero carbon footprint until the river bank. We don't put a boat inside to pick it up and again send it to the river bank. All that we believe is not required. And this year we plan to put in turbines, river turbines, closed loop hydraulics, so that we can even pick up what is collected here and put it on the vehicle using just the flow of river. Now let's look at the journey of fugitive plastics. I like the term fugitive. That means the plastic has escaped the formal collection system. Okay. Because I believe no municipality in the world can sweep every inch of the ground. And interestingly, a few years back, one municipality engineer was talking to his colleague. I was in that meeting, and he said, look, when it is on the ground, you can pick it up, but once it falls into the drain, then it is out of control. And I realized I have a role to play because I know what exactly to do after it falls into the drain. From there on, until it crosses the river mouth, I know what to do. The flowing water brings the trash and plastics to exactly where you have decided to collect, free of cost with the flow. You have to be smart where you're going to collect it and put your installation there. So let's look at the journey of this plastics. When it's lying on the roadside, from there, the wind is throwing it around until the first big rain, and it goes into a small drain, and from there to a bigger drain, stormwater drain, river mouth. That is a very long unidimensional journey of the plastic. And after it crosses the river mouth, then it spreads on the river surface, on the sea surface in a two-dimensional spread. After a few months and years, it is broken up by the waves and it goes down into the water column in the ocean depths as microplastics, whatever. Now, with today's technology that we have, we have not built capacity to stop and remove it from the rivers. We have the technology. In the open sea, we do not have a scalable solution. I know the ocean cleanup is taking two big, large vessels. That's not a scalable solution according to me, but it's very good first initiative. But you can't take two big vessels burning 20 tons of furnace oil and doing the job. So we need to improvise. This is a very good first step. And once it goes down to the depths of the ocean, there is nothing as of today, even I can imagine what we can do to clean it up. So we will be giving a major problem to the future generations if we don't stop this. And the best place to stop this is in the long unidimensional journey of the plastic from the small drain to the river mouth. You have to stop it in between. So this is a project done in Hyderabad. I'm sorry, this did not change there. Yeah. I don't know why there's a mismatch. I'm seeing different screens, but never mind. There's a little time lag. Okay. Okay. Inside the red circle, you can see the JCBs and the tipper trucks. What I'm trying to show is the length of the barrier. This is almost 132 meters, whereas the longest one is 192 meters. So this neatly brings it to where it is collected, and we normally do not like to get involved in the removal and disposal, but here in Hyderabad they convinced us that you must do that, and we made the process flow so well that 10 locations in 6 hours, our team used to pick it up, whatever is collected in the morning, go back, come the next day. And it used to be collected by the JCB which is standing on the river bank. This is one more of those barriers. So we ensure, we had a small trench like the natural crevices where we used to collect it, and that used to help us whenever in the rainy season we used to have the trucks that come there very slushy. And because we could get it inside these crevices, the vehicle could come right in front of that and pick it up and go. So the process flow was done very well. And you will be surprised, in Kuvam River in 2018, the first full year of operation, the corporation, we put in the technology, we asked the corporation to remove it, and they told us at the end of the year 22,000 tons of trash was removed. Out of that, 10% was plastics, and not a drop of fuel was spent until the river bank. This last one was Musi River, Hyderabad. Yes. Okay, this is how it pans out every morning. It will come there ready to be taken away, and it used to take half an hour to remove each one of them. And when we deal with a problem, we don't simply deal with it as a job. We keep thinking about how to improve the process flow, how to do it smarter and smarter, and then we could do each of these in about half an hour and take it away. Though we don't like to get involved in removal, but we can train the other people now that we have ourselves put our hands to it and made a nice workable model. This is Musi River. This is Musi River. 10 locations, 10 tons of trash used to come out every day. How many days? This is every day.
This is everyday scenario.
Everyday scenario.
Means every day you have to clean.
Every day morning, our guys used to go to all the 10 locations with a JCB, 2 teams. JCB simply scoop up whatever is there, put it in the tipper truck and take it away. 10 tons used to come out every day. Yes.
You have the data.
We have the data for the entire thing. 10,000 tons was removed in 3 years. Yeah. So this is the news report that came in Hindu. 2018, after the first full year of operation, 21,665 tons of waste was removed, and out of that 10% was plastics. Then there is other sludge and so many other things. Now I believe it has come down to less than 15,000 tons per year. So we would have removed in that year, at least I know what the rest of the world had done. If you add it all up, this was more than that. The good part is, the bad part is we threw that much in the water. The good part is now we can catch the bull by the horn. We have a solution of that scale to deal with it. Now currently we would have removed almost 100,000 tons out of the waters by now across all our installations, 10 cities and 40 locations, and over so many years. The benefit of making a very low drag force design is that immediately after the rain, when the water flows fast, the drag force has an exponential relationship with the velocity of the water. So after 1.5 meter per second velocity, it becomes quite tricky because it's an exponential relation. So we have minimized the drag force, maximized the tensile strength, and this can take about 1.5 meters. And there is a couple of very simple mistakes done by some other players in the world. They put a solid fabric there. And in fact, the first project that went into the ocean to remove that had a solid fabric. Then some other companies have put up a solid fabric in the flowing waters. Solid fabric has a lot of drag force. It cannot hold its position against flowing waters. It will simply lift up the fabric and everything will escape. So sometimes I wonder, people talk of $1 million projects, but sometimes over a cup of coffee you can think, very easy to understand why what you're doing. So these are other barriers. On top left you can see it has got what we call as a reverse barrier, because there we had eddy currents in the river. So eddy currents wouldn't take the trash to the corner, it would keep taking it in circles, and so we had to break that circle and bring it up. So we used to pick it up in the upstream side for a change. Now, what do you do when there is boat traffic? It's not very difficult, very intuitively you can understand. You stagger it in 2 parts, the boat will zigzag past, whereas the trash will flow straight and it will get trapped. That's all it takes. This on the left side is 172 meters, that's the second longest in the world. 192 is also ours, only in the same river. Now, we have signed an MOU with ISRO, the premium space agency of the country, to jointly develop AI. So we have the maximum ground truthing data, the plastics in front of if you are standing in front of the river and you have the images, terrestrial images, my staff can mark out what is plastic, what is not. And ISRO has got the images from remote sensing satellites, and somewhere you have to ground truth it, validate it, otherwise the AI algorithm is untested. So this is our MOU, but as we bite our teeth into the problem, we realize the resolution is one issue. Then secondly, this doesn't reflect very well in the image processing. There's the unique signature of plastics in the water is not very, very distinct. So we are working on that. There are, I think, newer satellites going up, synthetic aperture radar. Each one of them, we'll be seeing how to do a better job. Now, in case of, on the top left is Tawang Valley. It's in Arunachal. It's in mountain areas. You don't get very flat seabed, and you have rocks. So we made a slightly different model. We call it MDF. On the right side is the city solid waste, stormwater drains. So this does very well. It floats when the water level is up. When the water level is down, it will just sit neatly and it will go on. Most of the solution that we have created is when people tell us, look, this is our problem statement, and we go back and say, okay, we'll solve this, how to solve that. So we have made one. In another month we will be launching that. It's a robot for cleaning silt under the culverts. What the municipality engineers told us, that under the culvert their Hitachi, the excavator doesn't go inside. So that becomes a choke point. When you have a heavy rain and that is a place where silt is accumulated, you can't remove it, and already the pillars are there. So we have made a robot now under trials in Bangalore. Perhaps in another month and a half, we will be testing this in about 2-3 municipalities. On the left is a typical scenario of a stormwater drain in very, very urban congested surroundings. If you pick up, if you send a Hitachi there, if you pick up a bucket of silt in the middle of that, he has to go all the way up to that road or come all the way back this road with one single bucket to throw it, because it doesn't have place on the side to throw it. So it becomes a very tedious, very slow process. So this robot will be going inside that and then pumping it to the nearest road, 50 meters, 100 meters away. We have a certain traction in robotics. That's why we got into this. I'll show you. Now hyacinth, lot of places hyacinth, as we understand, it's a symptom of the problem. It is not the problem itself. There's too much of nutrients in the water and the hyacinth is coming because of that. But then it causes other problems of I'm not a very good biologist, I'm not very good at chemistry, so it's all acquired knowledge, the conversation I'm saying. People tell me the problem statements that the sunlight can't penetrate, so can we control this? Of course it blocks the stormwater drains, culverts, all of that happens. So we make this very strong. We tell normally that don't let it load more than 10 meters upstream of the barriers, but quite often, like you see the top right image, it is right here in Kuvam. For whatever reason, that went 200 meters. So we over specify the strength of that heavily because we know things won't happen on time. And it is better to avoid it breaking than explain why.
That's what home viewer, why I'm telling once you installed in 2016.
Yes.
It remained for almost, I think, till now, it has already become a soil, land area. So a portion of that. That's why who is responsible?
See, we are not doing the maintenance.
Yeah, maintenance, so that's what.
Yes.
So they should give something also.
Yes.
When they are avoiding the project. Why they are not giving that also? So that better technology you can develop, and that is also one other point.
Yes, but they are reluctant to give maintenance. They want some local contractor to do it. Maybe budget is an issue, whatever may be the case.
I don't think that can also be written in a policy like thing. I think we have to focus also. Suppose we are trying to implement some solution. What is the best ways to also implement in the field, so that you can achieve this 100% success? Because here you gave your idea, okay, that's fine. So, but after that we saw, that's what we still now in Google Image you can see. Yes. Your trap has it has become completely land because this type of problems.
See, it is like this. When we did this, our cost was 5% of the international campaign cost. 5%. I'm not saying 5% less. It was only 5% of that. But I need a little more leverage with some funds for maintenance if they want to engage me. So I tell them about it, but leave it to their discretion. I don't want to chase them for maintenance and things like that. It's their wisdom to engage me or train some people of their own corporation to maintain it. Whatever. So we explain the factors to them. Yeah. So this is
Why I told you, you can give something like a solution. Maybe Sanita and Goda, they are now taking care of this program. So in our draft policy, we can write. This is the lacuna. So we can write, and this should be given importance. So for focused way, we can make it. Yeah. Please.
So now this is electrical. Later on, we have moved to hydraulics. Later on we move to hydraulics because outdoor hydraulics does well. You don't have insulation problem in the morning with electrical motor. Secondly, the guys who, there's a remote location, some guy will try to steal it. They don't know what to do with the hydraulic motor. They know exactly what to do with the electric motor. So it helps. Now our belief is in the flowing waters of the river, don't spend a drop of fuel to arrest the plastics or surface solid waste debris. But in a lake scenario, you do not have that luxury. So you need to sweep it. So we have made something we call tandem sweeping. One master boat, one slave boat together, it will sweep 10 meters wide patch to one side of the lake, take it away. That water jet propelled boats on the right side is something that we have developed. It doesn't have a propeller, so it doesn't get entangled with the plants. It's a water jet. This is a technology comparison, although we also make the boats. This comparison between what we call a skimmer boat. In Delhi, there's a lot of this is running. Our advice is the floating barrier works 24/7 without a drop of fuel, and you can come in the morning after coffee and see what has got collected, take it and go away. But the skimmer boat operates only in the daytime, operates only when there is no rain, no fog, requires crew, fuel, all of it, and it covers only 3 meters wide in a 100-meter wide river. So why would anybody spend money on that? Although we also have a boat, but we say floating barrier makes more sense. This is another problem we have dealt with, not 100%, but it's in the final stages of technology. We have found a huge success in trapping silt, a passive barrier, a passive trap that is at the bed level. So the silt which is moving along the bed, it keeps falling into that very neatly. And we use only our knowledge for pumps to pump it from there. It's a fixed structure. So when you have that kind of scenario where both sides you have houses and one road here, one road there, putting a silt trap over here makes a lot of sense so that you don't have to go to the middle of this stretch to pick up the silt that is going. This year we plan to go to the open sea. Not because that's a very smart thing to do. We always believe shut the tap before you mop the floor. But some of you are just jealous that the guy who does the open sea gets all the media. And we said, okay, let's get started with this. Only difference is we will be using ocean renewables, wave energy, wind energy. When I say wind energy, it might sound like a big word, but I'm talking of good old sails used very smartly. So that what the idea is like this: when you take a sieve, when you have to sieve, you have to have a relative motion through the water, period. And the sieving happens. So whether you are stopped in a river and the water flows past you, or in a lake, you are taking the sieve and moving through the water, it's the same thing. So in the open sea, you don't have much currents. The littoral currents are less, very less. So we do not believe in taking two big boats and then burning furnace oil and doing the job. So we will be using wind energy. I'm sure the wind will not go in the same direction. And the wave, I will show you about that. And anchoring. Wherever we have little currents, we have a means, we have made a special craft where you can take a 4-ton anchor, go all the way to the bed, disconnect from that anchor, and the craft will come up again. You can take the next anchor and go and anchor like that. We have made a special craft like that. So
here I have something to
please.
Because you are telling open sea, because I don't think that you will get the scenario what is given for the open sea is not true, because about 80% of the litter what is coming originating from our rivers or coming to the sea, it moves along the coast, along the breakers zone.
It is correct.
So along the longshore current it will move, and very rarely it will come out of the breaker zone, and then it will go to the open sea.
When I say open sea, I meant that coastal waters only. When I say open sea, it's exposed to the waves and those elements. But
beyond the breaker zone, you can.
Yes.
Trapping this within the breaker zone, you have to think something, a new theory or something, how you are going to trap it, because within the breaker zones it's very difficult.
No, it will be difficult, but I think just off where there is some littoral current,
Yeah.
but it will be going along the coast. We are thinking in terms of Bombay, just outside Bombay,
exactly.
just along the coast.
Some of the places you can achieve, that's fine.
That's the idea. When I say open sea, I mean open to the elements of the sea. That's what I meant. So this is what we have done 7 years back. This is an ocean wave energy harvesting device. We have tested it in IIT Madras wave pool. So the floats on top that you see, there's a seabed unit there. It is cranking, it's rotating a shaft underwater there. And that becomes useful energy. Once you rotate a shaft with a certain torque and RPM, it's useful energy. And those are things that we're going to make use of to propel our sieve. On the left is a wave powered boat we have designed but not yet made it. That works on the basic principle, like if you're on a roller coaster, you're going up and down, your stomach is following your body with a small time lag. And if this is the inner hull and outer hull, this changing shape can be used, the space can be used to produce useful energy, and we'll be using that, and that is perhaps what we'll be using in the open sea. These are some of the robots. It's not directly connected to this, but on the top left we have made robots that goes inside crude oil, petroleum crude oil tank. Sludge is made for the highest explosive zone, zone 0, and that cleans up the sludge, sends it out 50-60 meters outside the tank to wherever the receptacle is. And the same principle, minus all the explosive elements which makes it expensive, minus all of that will go to the stormwater drain application. Bottom right is another robot that goes into the retail neighborhood petrol pump, goes through the small manhole, opens the arms, cleans it, and then comes out. So these two is for the petroleum industry, but minus the explosive thing that makes it very expensive. We'll be using this for the municipal applications. We have signed an MOU with Goa government. The project is called Mazo Darya or My Rivers. And we will be installing our solution in all the streams and rivers draining into the Arabian Sea, funded by CSR, practically. Now, when we talk of pollution, accidental marine oil spill response is definitely a consideration. So we have, of course, that has been our regular business. There's nothing very great. We have not made a new concept there. We have made a new design of the existing class of equipment. And this is something that moves in the water at 3 knots, and on the right is our test tank, and for oil spill response. Now, one particular pollution aspect which has not been appreciated so far, has been not recognized, is plastic nurdles. Those granules that goes inside containers in big container ships. As the container ships are getting bigger, when it rolls, some of it from the top, sometimes in bad storm, they break and fall. And when it opens, all the plastic nurdle is spread on the sea. And Sri Lanka, there is a vessel which caught fire and the entire coast was coated with that, with all the effect in tourism. But as of now, I think the world itself, because I know, have not recognized that we have to make equipment to deal with this. And the day it happens, we are doing everything manually on such a huge scale. So we have a plan to make a solution for that. Let's see. That kind of brings me to the end of my presentation. Happy to answer any questions. Thank you.
I think you got some startup for some prize for your startup, I think, by Government of India.
We got one star for the beta tank robotics. We got best startup award from the government Ministry of Petroleum, and then Economic Times gave us a best innovative startup award from the Economic Times, and also Tally Solutions. Kind of, yeah.
My former boss used to tell me, don't come to see me with a problem, come to see me with a solution. And this is exactly what you are providing. Thank you for this presentation. I have a very stupid question, because mainly concerning the river where you put details. I see exactly what you are doing. You are bringing everything on the surface. But this river is also carrying stones, woods, and all junk, I mean natural pollution, I would call it. how your system will be clogged with all this? Do you have to clean it every summer or with diver, or how does it work? I mean, if you block all this, you create a dam, and it will not resist to the river.
No, this system goes to 40 centimeters below the surface. So whatever floats, this is only for that purpose. Yeah, we have also toyed with the idea of stopping anything on the. There's only the cloth that is in the water column that moves. Otherwise, you have some of the thing that goes on the bed, and the water, it will keep slowly rolling. It doesn't move very fast. We have designed a system, but we are not ourselves convinced that removal is so easy as it is on the surface. And when it accumulates, you have to, you can do it once in a while, you can pick it up and take it out. But it's not such a smooth affair like what you do on the surface. So unless somebody wants, I think we're dealing one problem at a time. See, the surface is clean. No, I understand what you're saying.
I'm not saying you should do it. I'm saying how do you avoid it? So you just work in the first 40 centimeters, in fact.
Just 40 centimeters on the surface, that's all. Because once it gets clogged, then the drag force becomes too much if we put it for the full height. But we have made a floating security barrier, a floating fence that is now deployed on the international border. Last 7 months, NCNC trial with the authorities. That stops all the illegal boats, cannot cross over. There's a floating gate in that so that they can allow the bona fide boats past. And there we have also designed a barrier that goes right to the bottom. That's a flexible steel mesh, and that may be useful for shipyards for very small areas, not a big area. I wouldn't recommend that for any big area.
Sir, very nice information. At the same time, collection of these plastics is not that much easy, which how they innovatively are doing. And from my side is that when you are collecting that hotspots exactly, and almost 90% of the plastic where it is coming hotspots, that is particularly.
Can I just mention, we are not actually looking for hotspots. People call me from the world over and say, we'll give you AI and we tell you where is the hotspot, you can go and collect. No, we are putting our barrier at certain place, the river brings it to where I am collecting. And where I am collecting, the downstream has to be accessible by road. The place should not be very rocky. We have few criterias, but we are not looking for hotspot because whatever is there in the river upstream of this will come to where I am collecting it.
Yeah. Exactly, coming to that. So where we are collecting like that, as you said, that in Musi, Hyderabad and Kokam and Arunachal Pradesh, which is generally, water flow is very limited, basically. As far as concerned, my understanding where I worked in these Indian rivers, monsoonal estuaries, so the flow is the matter. So typically we can Indian rivers, we can categorize it into the 3 aspects based on the discharge, river discharge. Because some are perennial rivers, some are non-perennial rivers, in which minor rivers, medium rivers and major rivers. So as you said, these all things which will be work out for these minor rivers.
Okay, I'll answer your question. I got your question.
Yeah.
The major rivers like Yamuna, Ganga, those
Yeah,
kind of
Godavari,
rivers, what we
Krishna.
do, I'll tell you.
Yeah.
We would not put a barrier across the river because the linear, the drag force increases proportionally, not exponentially in those cases, but still it's too big. So what we do in that, we put a small arc along the river bank just downstream of the generating location. Like you have a ghat section which will generate a lot. Immediately downstream we put a small arc.
You have already put in Informal river. Informal river is there. He has put a in Informal river. The place where the point source. He has to put a point source. Suppose you take Ganga. Ganges itself is 3 kilometers stretch wide. So how you can put a barrier? So whatever the ghat area, you will put a barrier. So now you can collect. So the main source point you have to collect.
So immediately downstream of that is where the trash which is generated is going to flow. So we put like an arc. This is the river bank. There is a small arc of 100 meters of this barrier. So whatever is generated, it will come and stop here. Again removed from the, accessible from the land, it's removed. One end is anchored in the stream. That's why we made that other special craft for you to go and take a 5-ton anchor, go inside and then anchor where you want to do and come.
Yeah, my point of the thing is that when we are saying major HUDs, when we lift the gates, or we can say that huge water mass, lakhs of cusecs of water suddenly will flow when we lift the gates. Okay. Similarly, this kind of mechanism in Godavari river per se, from Nasik to up to this Bhairapalam, where Andhra, 1300 kilometers of this travel, it will stretches. When it comes to huge water mass, sometimes this water, whatever the bank is there, both sides, it will be exceeds that water.
I will just answer your the first question.
You understood your question, let him answer.
Okay. Yeah, that is one my concern.
There are times when they lift the gates and there's a big flow of water that comes. So what is a practice that we have developed is we have a quick disconnector. I think many of you would see if you Google to disconnect a chain, one person can go without applying the force. Even if there's a lot of strain on the chain, one person can go and disconnect it and it will open. Upstream is still connected. So the entire barrier will lie straight along the upstream side river bank. And after the flow is reduced, then after that you just pull the downstream end and connect it back. See, wherever we go, mostly the people will tell us, when I ask them what is the flow rate, what is the maximum flow in the monsoon, I want to know whether it's more than 1.5 meter per second, which we have rated. Nobody knows. They will tell you in cusecs. Yeah. And I want to know, cusecs cannot be directly translated into, you can't simply divide by the cross section and say meter per second. It's different. So when I ask them, I have equipment to measure that, but I am going in the month of November, monsoon is starting in June. So that has got no relation. So these are some of the problems that we deal with. So we have this disconnector, you disconnect the downstream end, it will open up and then you measure during monsoon.
It's more the water, unexpected forces as well.
Correct.
So
it's not an automatic release. Somebody will come in a two-wheeler, two fellows can come with a torch, because you will get to know at 6 o'clock that they are releasing water, and by the time it has become dark and then other fellows have gone home, two fellows are there, they will come in a two-wheeler, quickly go and knock it off and go back. Opening it is an emergency operation, connecting it back is a planned operation.
Sir, we have one online question. Can we take it quickly? Jaya Pavan, I see that you have a question. Please raise your question.
Sir, good evening, sir. Excellent work that you have done. My question is that in my area, there is a backwater drain, in which every single day they collect waste around like 50 to 100 kg. As the street is very narrow, bringing that JCP in every day and clearing it is not actually feasible. Sometimes they do that, but not every day. They are collecting the waste manually, and I feel that it is not right. Is there any solution that you could suggest?
I'll tell you, this device helps you to collect it at a location of your choice, number one. As far as removing is concerned, we have made some very, very simple, intuitive tools. We call it a fork. My boys name it aluminum handle with, like a fork it is. They will just dip it, pick it up. 100 kgs is not much. So they must be currently going down and removing it. They don't have to step into the water. That I can guarantee. From top, some of the simple tools. In fact, we have made something, we call it a weed puller. It's two rollers. When it goes that side, all the claw is lifted up. When you pull this side, the claw is fallen down. It will pull everything towards one side. It is just intuitive. When you close your mind and imagine how your hand is going to do the job on a lake surface, and you open your eyes and design it like that. So we have some very simple, intuitive tools for that. 100 kgs and all, you don't have to bring the JCB. I don't think those roads, you can bring it also.
Yes, sir. Thank you so much.
Thank you.
So the last question I want to ask, why you have named your company Alpha Marine?
Okay. It was earlier Alpha Marine Emergency Response Services. I wanted to do only oil spill response. Then I found that doesn't fit into the visiting card very well. And anyway, we are doing other things. So.
Thank you, sir, for bringing your valuable and practical perspectives on solving river and stream pollution to us. May I request Dr. Ramu to felicitate Sri Siddharth Hande and Sri Sekhar, please? today. Just join here. Okay. Please join us for a group photo, please, everyone. And tomorrow we will meet here at the same hall at 10 a.m.